Welcome, everyone. I'm Ann Nalley, and I'm representing the Senior Chemists Committee. And today, we're going to pay a tribute to a very, very special person today and tomorrow. And I'm going to start out with, this is, of course, the title of the symposium. We have a very special treat for you today. Not all of our speakers could be here. And in this case, we have I'm making the introductory remarks, but I cheated because today I'm not going to make the introductory remarks. Alda is going to make the introductory remarks. So I'm going to just review about 3 slides here, and then we'll click to the introductory remarks so we don't get too far behind. All of you know Alda, and I put this picture up because some years ago, when I first knew Alan, he was an actor on NASH. Oh God, I thought he was so good looking. I just loved him. I fell in love with him early on. And then later on, I found out he's really passionate about communicating science. And that's what he has in common with Bassam. And so the introductory remarks are going to be by him as a recording. And this is Alan and Bassam together. And then, ta-da, I finally got to have my picture made with Alan Alda, so my dream came true. So this is Ann and Alan at the Indianapolis meeting, and now I'm going to get out of this, and we're going to get to hear from Alan himself. So let's see if I can.
Bassam, I'm so glad to be able to join everyone in celebrating you and all you've done to help people love science, and especially chemistry. Your impact has been explosive. But you've not only used chemistry to light up a stage with flame and explosions. You've used your own personal chemistry to light up the minds of young people to the joy and wonder of science. To see the joy brimming in those faces, it's no wonder that some of the kids who have seen your shows have grown up to become scientists. Or grown up to become parents who wanted to share the joy of science with their kids. Thank you for all you've done, Bassam. Take a bow.
Okay, Bassam, take a bow.
Harry Gray here. Very happy to be at this symposium in honor of my good friend Bassam Shakhashiri. I'd like to thank Ann Nalley for putting this program together and particularly for inviting me to participate. It's a great honor to be in a symposium to a great man like Bassam. I'd like to start by telling you a little bit about how I got to know Bassam and my connections with him were really through my friend Gil Haidt. When I was in Copenhagen as a postdoc with Carl Ballhausen in 1960, in the fall of 1960, I wanted to learn Danish so I could communicate in Danish with people who were on the street and sold food and sold drinks and places that you could have fun. So I enrolled in Hellerup High School, in a Danish course in Hellerup High School. And guess what? In that class was Gil and Shirley Haidt. And I got to know them. Gil was working with Yannick Bjerrum on the old inorganic laboratory in Sulgade. And I was working with Ballhausen on the lab in Bleidomsvej, but I got to know Gil. Gil was a very interesting guy. He loved to say one sentence in Danish, which was, "I have 6 children." Because in Danish, that's "Jeg har 6 bjørn." And so he loved the fact that 6 in Danish is sex. And he loved to say that all the time. That's about all he said, actually, in the class was "Jeg har 6 bjørn." But I got to know him well, and we started talking, and we had interest in chemistry and teaching chemistry. In fact, Gil really got me much more excited about teaching chemistry, which I hadn't done very much before. And so when I got to Columbia, I connected with Gil, who at that time was at Swarthmore College teaching chemistry. And he invited me to Swarthmore to give a talk. My first talk outside of Columbia was at Swarthmore. I remember that day because there was a very famous speaker there that day, which wasn't me. I forget who it was, but whoever it was very famous. So all the students went to his talk and not mine. I had maybe 5 or 6 stragglers came into my talk, but what the heck, I could take that. And at that time at Swarthmore, Gil suggested that, we should maybe try to write a book together on general chemistry. He said, I've got ideas about how to do thermodynamics and kinetics, and Harry, I know you can do molecular structure and bonding, so let's get together and write a book together. And so I said, oh, okay, why not? We're both tennis players, pretty reasonable tennis players, and we had quite a competition going at this point. So on weekends, I would take the train from New York down to 30th Street, Philadelphia, and take the main line out to Swarthmore, get off and stay with Gil and Shirley and their 6 kids in his old house at Swarthmore. That was I could tell stories about that, but it would take too long. Anyway, we had good intentions, but instead of writing the book every weekend, we would just play tennis. And so after about a year of going down every weekend and playing tennis, Gil says, well, maybe we should start writing this book. And so we did. And off and on, we wrote the book. And by the time I had left Columbia for Caltech, 1966, we had the book pretty well finished. And it was published, Bassam, as you know, in 1968. It was called Chemical Principles by Gray and Haight. We called it great. Most people called it the Yellow Peril because it had so many mistakes in it that after the first year when people used it, they really couldn't use it anymore because it was, we played too much tennis and didn't pay attention to all the mistakes in the book. And Bassam, I know a little later you pointed all of that out to me and you told me that, what were you guys thinking writing that crazy book that has all the errors in it. So thank you for that. Thank you for being sort of kind to me and your criticism. I really appreciate it. Of course, your connection is also Gil Haight. Our joint connection is Gil because you postdoc with Gil in 1968. And I know that you went to Illinois and taught chemistry probably much better than Gil did because I know you got big awards for it. And I know that Gil respected you tremendously, and he kept calling me and telling me what a great guy you are and how terrific you are as an educator and so forth. I don't know where you got the bug to do demonstrations, but maybe it was from Gil. Certainly, I got my ideas for demonstrations, first ones from Gil, because he had these crazy demonstrations. One of them that was completely nuts was when he put liquid oxygen on his tongue and lit a cigar, and he was literally a flaming dragon, a fire-breathing dragon, as the fire emitted from his cigar with the oxygen coming out of his tongue. Of course, once the cigar froze to his lips with disastrous consequences because he had to pull the thing off and ripped his mouth up. And I guess he didn't do that again. Anyway, I got the bug to do demonstrations. And so when I got to Columbia in fall of 1961, I found an old Frenchman by the name of Michel Fouget, who had been ignored by all the Columbia faculty members. He was literal lecture demonstration. He'd done that in the late 40s and 50s, but early 50s, but people had forgotten all about him. But I found him, and he came to me, and I said, Mr. Fouget, let's do some lecture demonstrations. Let's do some really good stuff. And he said, okay, Professor, I will work with you on this. And so we made a team, and we did all kinds of crazy demonstrations, rocket ships with bell jars filled with hydrogen that would then seep in oxygen and reach an explosive mixture and take off to the ceiling. But perhaps our most famous one was recrystallization from supersaturated solution of sodium acetate. We would take a 6-liter beaker, and Mr. Fouget would start dissolving sodium acetate in it over a period of 2 weeks and cover it up and not let dust in. And the time it was ready, supersaturated after 2 weeks, he would bring it out in the big lecture room at Columbia, and I would be at the podium, and I would say, Mr. Fouget, is the supersaturated sodium acetate solution ready? And he would say, Professor, it is ready. And then I would tell the students, now don't say anything, be very quiet, because Mr. Fouget now is going to tiptoe up to the podium where I will drop a seed crystal into the supersaturated solution, and it will crystallize, and it's highly exothermic. And so don't do anything before Fouget gets up to the podium. But he never did. In the 5 years we did that at Columbia, he never made it to the podium because somebody in the class would whistle or do something, and he would shake it, and it would crystallize, and it would get really hot, and he would dump it out, and crystals would go all over the room. I remember that Walter Sullivan, the science writer for the New York Times, very famous science writer for the New York Times, called to me and said, I've heard you and Mr. Fouget doing these crazy demonstrations. Can I come up and listen in and write it up? And I said, sure. Walter Sullivan came up, we went through our routine, and sure enough, when Fouget was in front of Walter Sullivan in the front row, somebody whistled, and he shook the thing, and it crystallized, and he dumped it all in Walter Sullivan's lap. But Sullivan took it rather well, and he went back to the New York Times, and he wrote a very nice article about this crazy duo at Columbia, Harry Gray and Michel Fouget, who do these crazy demos, and he wrote them all up at the time. I wish I could find that article again. Maybe you can, Bassam. Anyway, we finally got Dick Dickerson to rewrite our book, Dickerson, Gray and Haight. He got all the errors out and made it much better, and it did quite well for quite a few years. The third edition finally went out of print, but it's available free of charge on the Caltech authors website, so students can now download PDFs of chapters anytime they want, free of charge. And some schools are now using the third edition of Dickerson, Gray, and Haight in courses by assigning various chapters that they want to. When I got to Caltech, I was, of course, anxious to do my demos. I was really passionate about demonstrations, and I developed a whole bunch of great ones with Mr. Fouget at Columbia, and I wanted to try them out. But when I got to Columbia, George Hammond wanted me to help him with the Hammond curriculum. You may remember that, Bassam. Let me remind you, George Hammond thought the chemistry curriculum was 30 years out of date and should be completely overhauled. And his idea was that organic and inorganic, physical and analytical were or not good, the right courses now for chemistry. He invented a curriculum that would feature structure, dynamics, and synthesis. And so he volunteered me to teach these courses with him. And I did that for a couple of years, but my conclusion was that it's not the curriculum that is making chemistry unpopular. It's the fact that we don't give kids a chance to see demos and actually get in research labs and do hands-on work. And so I started really saying, we've got to get kids in labs right away, as soon as we can as undergraduates, and get them into hands-on work. And they'll then be hooked on chemistry. And that really worked out. It really changed things. And so after the Hammond curriculum was over, I was asked to teach freshman chemistry at Caltech again. And that was my chance again to get back in demos. Like, I know you're the world's greatest demonstrator, Bassam. I'm only a minor version of you. But however, I did couple up with my first graduate student, George Rossman. And George was really a terrific chemist, and he loved demonstrations. We invented a whole bunch of new demonstrations, particularly ones that are double clock reactions. We invented a special one called the double chemiluminescent clock. And Bassam, I'm now challenging you to figure out what those reactions are. And you can email me and let me know if you figured it out, because these reactions have only been run at Caltech. It goes like this. You have two big Erlenmeyer flasks filled with solutions. And I can tell you that copper is in them, cyanide is in them, and luminol is in them. And maybe some other things that you'd have to figure out, Bassam. But at any rate, there's two big Erlenmeyers, and I hold one, and George holds one. At the start of the reaction, I say, let's start the chemiluminescent clock, and I pour my Erlenmeyer into his Erlenmeyer. And after 7 seconds, the darkness becomes light. There's a big flash of light after. That's the first flash. Then the thing goes completely dark. But after 15 seconds, there's a second enormous, incredible flash of light. And it's highly exothermic, so it's a fountain of light that literally hits the ceiling in the lecture room. And this was a very, very popular. Then it goes black again, and so there's two big bursts of light, timed 7 and 15 seconds. It's a great demo. Everybody loves it. It's called the Caltech chemiluminescent clock. Only been done at Caltech. And it got so popular that the alumni asked George and me to do this in a big alumni meeting in 147 Noise. So George and I got together and said, well, we're going to have to do this for the alumni. Let's scale it up. Let's scale it up so it'll be a really big flash of light. That was a big mistake, Bassam, big mistake. We scaled it up to two big Erlenmeyers, lots of solution. We started it, and I poured my solution from my Erlenmeyer into his. And after 7 seconds, sure enough, there was a big flash of light and it went dark. And after 15 seconds, there was an incredible flash of light and an enormous fountain of light that hit the ceiling of 147 Noise, where for years you could see a big black spot where we'd hit it. But that's not all that happened. George's Erlenmeyer blew out the bottom in the explosion. This was too exothermic. And the alums loved it. They thought we had planned this blowout of the back. They thought the whole thing was the way we planned it. But of course it wasn't. They gave us a several minute standing ovation for this when George and I looked at each other, and George said, Harry, I don't think we're ever going to run this again. And we haven't. That was the last time the double chemiluminescent clock was run. Well, Bassam, what can I say? You're the greatest. Your contributions to chemistry have just been amazing. Not only at Wisconsin, when you went to Wisconsin in 1970 and you've been there ever since, you've been such a hero. You've done your Christmas demos, you've done everything to make kids, and old and young alike, really love chemistry. You have just done so much for chemistry worldwide. I can't thank you enough. At NSF, you changed everything in educational system. You did such a great job at NSF. And you were a super president of the American Chemical Society. You had us all feeling really good about being chemists when you were president of ACS. And your leadership in all areas is just something that has just been overwhelming, and we can't thank you enough. I'm very honored to be in this symposium to kick it off, and I wish you all the best. And I wish I could be with you now, but I'm at some hotel a few blocks away from you right now with Bob Bergman and Angela Wilson talking to students. So I haven't figured out how to be two places at once. So maybe we'll run into each other at this meeting. Anyway, my good friend, thank you for all you've done, and thank you for all you've done, and thank everyone who's in the audience for listening.
I am following two very hard acts, Alan Alda and Harry Gray, but I will do my best, because what I want to do today is give a snippet of one thing that happened, one event, memorable event that happened in Alabama more than 30 years ago. And at that time, the Alabama Academy of Science was roughly about 70 years old, and it's now over 100 years old. So what I'm going to do in this presentation is give you a story that will tell you something about the Alabama Academy of Science, and then show the role that Bassam played in that society. And the memorable part is that people are still talking about it in Alabama. So anyway, again, what I'm doing is I'll tell you something about the Alabama Academy. I've been a member of that organization since the 1980s. And in 1990, I was president of the Alabama Academy of Science. And that was the year that Bassam came to Alabama and gave a presentation to the Academy. And it was, as I said, a very, very memorable presentation. Now, first, the Alabama Academy of Science, I'm obviously very proud of that academy. They do a lot for science education in the state of Alabama, and they have for many, many years. It started out in, the first meeting was in 1923. And at that point, they were more an organization for presentations of papers by people in the colleges and universities of Alabama. But it quickly grew to an organization that spread its wings to secondary education and even primary education in the state of Alabama. And most recently, the Academy has formed a semi-partnership with the state of Alabama to promote science education in Alabama, sorely needed, but a wonderful organization to help with that. So this March, we had our 100th meeting. And at that meeting, the kinds of things that happened were we had Gorgas Scholarship Competition. And the Gorgas Scholarship is something that was founded in the 1940s by a partnership with Alabama Power. And Alabama Power provided a very large chunk of money in a foundation for that in order to provide scholarships for high school students. So a dozen high school students are selected by competition for the Gorgas competition, and they present their research at this meeting. And this has been happening since the 1940s. So that gives you an idea of how far back the Academy was trying to interact with high school students and promote STEM careers. Lots of other things happen in the Academy that promote science education. One of them is the Mason scholarships. And those were started in 1990. And what that does is provide $1,000 to a graduate of a school in Alabama in some field of science or engineering so that they can get certification for teaching in grades K through 12. And we've followed most of those, and their careers in the high school system in both Alabama and Georgia has been astounding. So it has an impact. And most recently, we started the Adriane Johnson Mentoring Award. And that was just this meeting that was first awarded. And that was given this year to a high school teacher that coordinated the science fairs in the Alabama Academy of Science, and also to a professor at the University of Alabama at Birmingham. So again, there's lots of things we do, and I'll give you the website at some point, and it's a fascinating organization. It has the effect of giving undergraduates and graduate students their first opportunity to present papers, gives a chance for faculty to test things out, and it also links to the high school students. Okay, just quickly, this is the glorious state of Alabama, the heart of Dixie, okay? And currently we're divided in these various color-coded regions. And you can tell it's sort of like taking Pennsylvania and turning it 90 degrees. And to travel from one end, say Huntsville, which is in Madison County at the top, the star at the top, down to Mobile, it's a good ride. Take you probably a good 5 hours at least to go from the top to the bottom. And that's on interstates. So it's a long state, and having an organization that stays connected has been quite a task. But one of the ways it's done is by making sure that the regions come together at some point. And the Alabama Academy of Science has provided that kind of umbrella. Science fairs are held and coordinated by a member of the executive committee of the Alabama Academy of Science. And it goes all the way from the local competitions to the regional, to the state. And then we always send somebody to the international as well. And this has been going on as long as I've been a member and many years before that. The Science Olympiad is something that students really like. It didn't start in Alabama till 1990. And again, the umbrella for it is the Alabama Academy of Science. And there are elementary school competitions. There are middle school and high school competitions. And this is all coordinated so that finally the students that do the best in this go to the National Science Olympiad. And there's a member of the executive committee of the Alabama Academy of Science that coordinates that. And at every meeting annually, high school students in 5 different areas of science to humanities compete for the Junior Academy Awards, and then those that win end up going to the national competition. Now, for the other activities, the science fairs and the Science Olympiad, the Academy provides some funding, but for the Junior Academy, the Armed Forces, the Army, provides a good chunk of the funding. So annually, high school students come, and this is where Bassam was involved, because we have Junior and Senior Academy meeting together. And at the time that he came, the way it worked is there was a banquet Friday night, and then Saturday morning, there was an opportunity for the speaker to meet with the high school students and the high school teachers. So it was a kind of venue that he was invited to. Okay, and this is just, again, a little bit more about our 100th meeting, and I only want to point this slide out because Alabama, back in 1920s, 30s, 40s, 50s, and 60s, was not known for diversity. And by the time I joined, of course, things were starting to change. This is now our 100th meeting. And I'd like to point out that one of the panels that we had at that meeting was the science of health disparities research. Okay, it was a very well attended panel. Secondly, the banquet speaker this year was Charlene Newman. She's a tenured professor at the University of Alabama in Tuscaloosa, and she happens to be African American. And then finally, Adriane Johnson was a member of the Academy. He was in line to be president of the Academy. He's African American, was African American. He was tragically murdered. He worked at the University of Alabama at Huntsville, and there was a horrible incident that happened where 3 faculties were killed. And this year, we finally got our act together and we established an award in his honor. His wife was there to help present it, and it was given to the 2 people I mentioned earlier. So diversity has, by leaps and bounds, actually made a big move in the Alabama Academy of Science. You know, up till the 1960s, the organization was entirely white, and there was no equivalent for the rest of the state. So anyway, if you want to find out more about the Academy, I'm stopping here, but there's our wonderful long word website, alabamaacademyofscience.org, and it gives you a good view of what goes on in the Academy. Okay, now we're going to go back a few years to March of 1990. And this is where, again, a similar meeting was held. The organization was not as large as it is right now in terms of things that it funded and followed, but we did have a good number of papers as well then. There was the same junior academy competition, the Gorgas competition, and of course the banquet speaker was Bassam Shakhashiri. And he gave a demonstration on the following morning with the high school students. And what I want to do is, I happen to have saved many of the letters between the Tuskegee as well as the Alabama Academy and Dr. Shakhashiri. So I'm going to run through those and give you a insight as to how that actually happened, how it happened that we were so fortunate as to have Shakhashiri as our banquet speaker and his giving a chemical demonstration. Okay. This will give you an idea of how determined we were to get him. This is now the fall of 1988. Okay, I'm now president-elect of the Academy. And I didn't make this decision myself, but the executive committee decided we wanted to invite Bassam Shakhashiri to our meeting in 1990. And so I wrote a letter, explained what we were wanting to do, and you know, basically telling him there would be an honorarium, we'd handled everything, and we would love to have him. Okay, so that is now the fall of 1988. He answers almost right away, still the fall of 1988. And he doesn't say yes, and he doesn't say no. He says, I'm honored, but I can't tell you yes or no. So this is now the end of November. There's exams at Tuskegee and so on. So I finally answer him in January of 1989 and say, yes, we'd love to have you. We're going to wait. Basically, that's what I said. And we'll keep in touch. Okay, we'll keep in touch. And we did. February of 1989. At this point, I had said to him in my previous January letter that we thought it would be the end of March for the meeting in 1990, and now I knew the exact date, so I give him that date and say, we're getting ready for our 1989 meeting, and I'll be sure to tell you all about that. So, you know, we're keeping the communication lines going. No response to either of those letters, but I'm assuming they made it where they were supposed to go. And then April of 1989, we've had our 1989 meeting. And I write another letter and I send the brochure, program brochure to him, tell him something about the speaker and the fact that the speaker and his wife did a rap session afterwards on Saturday morning with the high school students. So he gets a feel of what we are all about. Still no answer, okay? But that's okay. I know he said no answer until the fall of '89, so I'm still waiting. We're still waiting. And then finally, September, fall of '89 comes, and I figure, okay, it's time for another letter. And so we write another letter and say, you know, we're ready for your yes or no. And that's basically what this letter says. And finally, not too much later, that was September, it's now November, I get a call from Ann, and I don't remember her last name, I'm sure you do, from the NSF office, and she says, yes, he's coming. So we've got it all set up and the arrangements for his coming are now beginning. So it tells you what the process was in order to get him. But we had a plan B, we had a plan C. You know, if Bassam had said, no, I'm sorry, I'm too busy, we would have been sad, but you know, we would go on. But we were more than ecstatic when we finally got that yes, actually. The Saturday activity turned out to be what was going to be his demonstrations. And let me tell you how we planned these meetings. They're held at various schools in the state of Alabama. And in 1990, it just so happened it was being held at a small school, relatively small school called Mobile College at the time. It's now called the University of Mobile. And a member of the academy from that college becomes the chair of the local arrangements committee. And then he has a committee at his college and they get everything in place for the meeting, much like a mini version of what happens at any of these professional meetings, but it's all done by that school that's going to be the host for the meeting that year. And the meetings are held at various schools all through the state of Alabama. Okay, so happened this year, 1990, let me go back a little bit. And in November, once we found out that Bassam was coming, I contacted Joe Pyle, who was the professor at Mobile College that was going to coordinate this. And I said, probably not too much more work because of what's going to happen on Saturday morning, but I'll keep you abreast. Well, turns out I was very wrong. It was a lot more work that he had to do. And unfortunately, February, about a month before the meeting, I get a list of everything that's needed for the demonstrations on Saturday. And God bless Joe. He and his committee put it all together. Every little bit was ready and waiting when Saturday morning arrived and Bassam met with the junior academy, which are high school students and their teachers, and there were some members of the senior members of the academy there as well. I was there. I was definitely there. I will never forget it. So anyway, God bless Joe again. Every bit was done and we were ready when Bassam came. Now, one thing that happened at this meeting, and again, I'm not sure exactly how this all evolved, but we had two students go meet Bassam and escort him to the hotel, is how I remember it. And the two were picked with reason. One was Andy Jernigan, who was at that point, a high school student, a high school senior, and president of the Alabama Junior Academy of Science. And the second was Kevin Carter, who was a student chemistry major at Tuskegee University. And he had done some work with me as well. So those two gentlemen ended up having the honor of meeting Bassam and taking him to the hotel. We had arranged for his travel, but apparently being a government employee, we could not pay for it. So we had this chunk of money still left that we didn't use for that purpose. And I'll come to that in a minute. But the program for the meeting, and that's a nice younger picture of what you probably looked like in 1990. I don't know. But at that time, that is actually not in Alabama. I pulled that from somewhere else, but we have a program and he's listed there. And on the far right is the fact that on Saturday morning, first, very early, there's the paper competition for the Junior Academy. And then there was the chemistry demonstrations, and then afterwards, business meetings and so on. But it was a very, very memorable event. I mean, there's no words to describe how that impacted the students at that particular time. Now, just a little bit about some of the outcomes from that. This is something that we did, the executive committee of the Alabama Academy of Science did after the meeting. It was never done before, and it has never been done since. We sent Bassam an honorary membership of the Alabama Academy of Science. At that point, we did not have a fellow, so that didn't happen until somewhere in the year 2000, but he became an honorary member of the Academy. And I think that says something for how we were impacted by his presence. And I'll say that we very, very generally, high school students. In fact, at this most recent 2023 meeting of the Academy, I had people comment to me about the fact that this happened because it impacted the students. They saw something very human in what he was doing, just the way he does it. And the effect was memorable. Another thing that we did with this money that wasn't used for his travel is we bought the demonstration books that existed at that point, and we distributed them as far as we could to the various schools in Alabama. So that was done in 1990. He sent posters to Andy and to Kevin that were autographed. And I don't know where Andy is. I recently found out that Kevin is somewhere in this area in San Francisco, and maybe I'll run into him. I don't know, but that poster stayed with him, I'm sure. And then finally, one other outcome was a few years later, the National Organization for the Junior Academies was holding its meeting in Huntsville, Alabama, and there was communication between the organizers and the Alabama contact person to invite Bassam. And I don't know what happened there, and I don't think either of us remember exactly, but I kind of was out of the pocket from that year, so I don't have an answer. But it's just, again, an indication of Bassam Shakhashiri. And finally, my last slide, I just want to say thank you to him for just bringing that human side of science to these young students and the way it impacted them. So there's nothing else that I can say except thank you. And thank you, everybody. Yes.
Thank you very much. You brought back very good memories of this visit. I have been to Alabama many times, and I know you know this, but I'd like to say it to everyone else. When I was in Washington on leave of absence from the University of Wisconsin to be the assistant director of the National Science Foundation, I was working 14-hour days every day to get the science and engineering education programs launched, organized, and well-funded. One of the biggest joys I got was invitations to do the kinds of visit that you just described. And usually it was said to me, we're not inviting you because you're a high public official. We're inviting you because we want you to come. I'm sorry it took 2 years to make it happen. But you're not the only one. Thank you, Adriane.
With us. So
Yes, hello, Bassam. Hello, Ann. Hello, everyone there. I want to join in this celebration of Bassam Shakhashiri by talking about something that's dear to both of our hearts, and that is the relationship between art and science, because this is one of the many themes that link Bassam and me, is our desire to see chemistry in culture and also culture in chemistry. Some of the other factors that you know that bring us together are our central commitment to teaching and to learning. And in both of our cases, this comes out of our immigrant experience and our families. You will hear a little more from Bruce Lewenstein about the immigrant experience, but I could not pass up the opportunity of showing a picture of Bassam, and now I must be able to somehow advance these things. And that, okay, I'm having trouble advancing now my slide. Hold on, please. Okay, I can advance it this way. So this is the picture I wanted to show you, which is a picture of Bassam, a younger Bassam, being sworn in by George Keyworth at the National Science Foundation. And what's important to me, and of course was important to him, was that we see his mother and father, Adma and Zekin Shakhashiri, here. I wanted to show you also a picture that I got from Bassam's niece of his mother and father at a different stage in life, which is on their marriage day. Bassam was not yet around, but here in 1938, he was going to come to this world in a short time. I was there for a year already. In a very different part of the world, you can see his parents. And I wanted to show you his parents in their sort of fullness of their life. Here am I, you know where this is. It's not Cornell's agricultural school. We are in Wisconsin, and Rodney and Jerry and Bassam and I are enjoying the company after a day of fun teaching science to people. I'm going to tell you a story about art and science, which comes out of a book which I hope to finish, which has both an English and a Russian, Ukrainian title, Kamushki, which is the Russian word for pebbles. It's a book that's going to be written by me, by Alexander Svitin, and by Enrique Martinez Celaya. And what pebbles have to do with art and science is something you'll have to wait for the book to talk about. But in the context of modern politics, present politics, I don't want to escape the notion that one of the authors is from Ithaca, and another one, Svitin, is from Krasnoyarsk in Russia. And Enrique Martinez Celaya is from Los Angeles. And one of us is an American, but then where I was born was Austria-Hungary when my mother was born. It was Poland when I was born. It is now in free and independent Ukraine. and being Jewish meant a lot in the context of surviving terrible times in World War II. I am a bona fide Ukrainian. I'm probably the only person here who appears on a Ukrainian stamp, but also this is probably the only stamp in the world which has molecular orbitals on it. There are some with atomic orbitals. Alexander Svitin is a Russian, and Enrique Martinez Celaya is a Cuban-American, a very successful artist in the Los Angeles area. How we came together is another story, but one of the things I want to say in these difficult times is there is Russia and the Ukraine are very important to me. I authored the appeal of Nobel laureates about the criminal invasion of Ukraine by Russia. But at the same time, there is a curtain falling around Russia and Russians, which hurts immensely Russian artists and scientists whose war this isn't. And I am intent on doing everything I can to encourage the people there. And in some sense, this commonality is part of it. Let's talk about, though, the subject. What about the things that bring art and science together? In some sense, everything has been said in C.P. Snow's essay, but there are still some things to be said, and perhaps something to be said from the viewpoint of a scientist and an artist and a philosopher working together. So what do I see as common? What do we see as common in this book? The most important thing is that science and art are acts of human creation. Let me summarize this as succinctly as I can to my artist friends. Sculptures do not grow on trees. We have been put on this earth to transform it, and we have to be judged by our transformations. And so a garlic plant, which is what you see at left, a single garlic plant may be a natural object for wild garlic, but a field of garlic, that's agriculture, which both Cornell and Wisconsin are very good at. It is a human transformation using biological things, as much a transformation as what happens in a refinery. And this is the interesting thing. Both art and science try to avoid the ethical questions that are there around creation, and they cannot be avoided in our time. Another thing that joins them together. One is that the objects are made with attention, with detail. For arts and for science, that hands and minds are both engaged and doing and cooperating, this is our finest link. Let me put it to the scientists in the audience in this way. When at Cornell, one time, the Faculty of Arts and Sciences suggested that we replace in a requirement a beginning chemistry course by a history of chemistry course. The best support we got was from the studio arts people at Cornell. Bill Reed, here I quote, a Canadian Haida goldsmith and sculptor, says that one basic quality unites all the works of mankind that speak to us in human recognizable voices across the barriers of time, culture, and space. That's the simple quality of being well made. And that goes for chemistry. It goes as much for the arts as well. Here is Enrique Martinez Celaya at work in his studio in Culver City in California. And he's not that far away from being a chemist in this setting. The third factor that brings them together, us together, is that we all use representation. That is, there is reality, there are the things we deal with, but we must represent them in some way. I chose to illustrate this by one of the findings in my files, which I was so happy, and you know what this is. This is the proverbial restaurant napkin. And I'm talking to my colleagues at Columbia in this case, and I'm trying to represent chemical molecules. But are those molecules? What's the distance between substances and molecular structures? One of the interesting things about representation is an awareness that we represent in science is very important, because very often in science, through our romance with mathematics, we try to hide non-mathematicizable, I've just made that up, ways of analogy and metaphor, because we think they will not impress our colleagues enough. And yet in those unmathematical explanations is where the real world resides. In art, it looks, they have another problem. There, sometimes representation looks like, here is Isaac Levitan, one of the greatest of landscape painters, a Russian painter, painting a typical landscape of birch trees in a forest. I hope you don't think this can be replaced by a photograph. It's not the same thing. A landscape here to illustrate a mood and a setting is something much more than just a photograph. And a photograph is not as simple as you think it is. Something that's valued in both art and science is an economy of statement, an intensity. This is there when the Balmer series here in hydrogen at left is represented by a Rydberg formula in the middle. And then along comes Bohr to explain this. That economy of statement is something marvelous, and how a scientist wishes they could explain, they can, to an artist, the special economy in a symmetry argument or in some chemical equation. In another context, in art, there is an economy of statement. Here I choose, because I like Japanese ceramics, a classic Japanese tea bowl from the Edo period by Koetsu. That bowl, I don't have the good view of it, is not perfectly cylindrical, but I assure you, and we know it from other bowls made by the same artist, that he could make a perfectly cylindrical bowl if he wanted to. He made this not cylindrical, and in our grappling with that, as well as with the bands of color in this, if someone takes you by the hand, you can understand something about simplicity and complexity, and what is the reality of being a circle and what that means. In both art and science, we share a desire to communicate. Now, I will accept that in some totalitarian societies, people write for the drawer, but science and art are reaching out. They're also cross-cultural, which is a very interesting thing, but that's somewhat of a subject to debate about the cultural. I found this picture of Bassam reaching out, and he's standing there on the, I think on the, he may be talking to alumni, but he's at the Union at Wisconsin, and he's by the water, and I really like that, to see that, because to me it felt like Bassam in his native setting, so to speak. fantasy and imagination clearly matter in both science. They're a desirable aspect of creation. There are interesting limits. For instance, the obvious one that theoreticians' wild dreams have to be limited by the experimental reality of what they are trying to explain. And there are interesting limitations on the imagination, even in art. Attention, close observation, and patience. I wish I could show you the drawings of Ramon y Cajal in Spain of nerve cells. Careful observation of things is very important in both art and science. Synthesis and analysis, yes, taking things apart, but in order to put them together, perhaps building something new. And in all that, and we don't do too well, to remember ethics. There is ethics in bringing a child to this world. There is ethics in making a new molecule and applying it for some therapeutic purposes. Chemistry is especially good at synthesis. This is our special strong card, so to speak, in the world of science. Drafts and hypotheses. That's very interesting to trace that in art and in science. And some of you have seen these two pictures, which I showed to people. One is the earliest draft of Mendeleev's table of the elements at left, written part in German, part in Russian. You can see the symbols are recognizable because Berzelius introduced them. The atomic weights have just fallen into place by 1860, by 1850s when Mendeleev is writing this. And there is the periodic table. He's missing the whole column of the noble gases because they had not yet been detected. And much to his discredit, he fights their discovery when it happens. Over at the right, you see William Blake's draft, last draft. That line going down the middle from top to bottom is the printer's mark to just indicate that he has set this into type from this tiger, tiger, burning bright. Then he comes to the fourth line and he's not sure. Dare frame, could frame, dare grasp, could grasp. Like a good poet, if he chooses one line, but he has some other pair of words that sound right to him, he's going to use it later in a poem. And we can check down about 2 inches from the bottom. He uses dread grasp because he liked it so much, even though it doesn't fit in the first place. There is in both art and science a curious combination of selfishness and altruism. We create and we rejoice in the understanding and beauty we have achieved, but surely some of the pleasure comes about when we have brought into the world something we can share with others. Yes, there are other aspects to showing, telling, selling, but there is a special altruism at work in science, and so there is in art. Another is storytelling. Storytelling is very interesting. It has very important for both art and science, but both have an ambiguous attitude toward the act. Let me just explain. Scientists are, for some crazy reason, afraid of stories because they think that the stories are just things that are made up. But of course, what is a hypothesis but a story to be tested experimentally? And in art, abstraction is interesting. I mean, you can tell a story, you can ask a historian to tell you a story about why Carlo Crivelli in 1480 painted a fly on the parapet of this painting and what the importance of the cucumbers and the peaches or apples as symbols are, but no one asks that question of an abstract piece of art. It does not need a story. So there is an interesting ambiguity towards storytelling in both of these. There is a common aesthetic in both art and science. One likes a molecule like cubane. It has a beeline into our soul. Someone had to take me by the hand to make me appreciate hemoglobin in the second painting, second model at the left. When you look at the Taj Mahal, or when you look at a Mexican Baroque church in Chulala in Puebla, you see the working out of simplicity and complexity in that. There is an interest in doubt and trust in both of them. It's an absolute necessity of science, but it's also a correlation, a tension in art as well. Here is, I think I have a quotation from Agnes de Mille here. Yes, a dancer. She said, when I see my work, I take for granted what other people value in it. I see only inaptitude, inorganic flaws, and crudities. I am not pleased or satisfied. Martha Graham, another dancer, says, no artist answers her. This is an interview. No artist is pleased. She continues, but then there is no satisfaction. No satisfaction at whatever at any time. There is only a queer, divine dissatisfaction, a blessed unrest that keeps us marching and makes us more alive than others. Very interesting. There is regularity and complementarity. We look for order, but what if there isn't just one way of seeing things? What if light has to be seen sometimes as a wave and sometimes as a particle? And don't get too upset if I use one day valence bond theory and molecular orbital theory the next day. It's okay, as long as you understand the relationship. And then there's a movement to the unknown. Here scientists have a little bit of a problem with some of the things for the humanities. Many of the things that trouble artists and the humanities do not admit of a solution. I mean, 1 million poems have been written about the end of love. Are you going to say that you can't write the 1,001st poem about the end of love? Of course you can. And you can judge whether it's a good poem or not just therapy for the writer. There is so much to know, and a lot of what we know is not reducible to simple scientific stories. I want to talk about divergences, because that was enough about similarities. There are differences, and it's very interesting to see the differences, to look for them and to see whether in fact one could learn something from them. One is that and it's a problem for our times, it's the currencies, I mean that figuratively, in which achievements are valued. How do things make you feel, and how important that is, and numbers. And the numbers here comes up under artificial intelligence, a problem for our day. Science has not found good ways for including emotions into the communication of the essences that it finds between scientists and other people. But artists know how to introduce the emotions. And we have something to learn from that. And this is one of the problems I've always been fighting with the format of the scientific paper and the gatekeepers of referees and editors, so little would be lost by including something about emotions in what is allowable, and everyone who teaches knows how we sneak in a way to have the student understand that you, the teacher, care that they learn, but you won't get angry at them if they don't. It's that kind of emotional contact which makes for things. The reason I show here the Roscoe Chapel is because you might think there is nothing more abstract than these paintings by Rothko, but I've seen people cry in that chapel when they allow themselves to sit and contemplate them. There's an interesting story about the role of ambiguity. It's the way it's central in art, that a word in a poem mean 3 different things, and that it has a resonance to 17 other things, references. That's not bad, that's good. That makes the poem richer. But in 19th century England, when people built conversions of coal into energy, until they defined work and heat exactly and unambiguously, one could not figure out why those gleaming engines could not produce energy with a higher than a certain efficiency. One of the interesting differences is one that Gunther Stent has noted, that of infinitely paraphrasable universals versus the single particular. We really value theories of everything that explain everything, but maybe we should be looking at some specific things. Here is Archie Ammons, a colleague and guru at Cornell. He wrote a little poem about a weed. I found a weed that had a mirror in it, and that mirror looked in at a mirror in me that had a weed in it. We could go and talk about that poem at some length, but that poem deals with a specific weed. It's a specific poem, but it has some universal truths in it. Solutions and resolutions. We've already talked about this. The arts speak through all the senses to a world of resolutions, and that suffices for most of the problems of this world. The next one is, I can give you some statistic on, and that is, what is society willing to pay for art and science? And my colleagues are crying all the time about their grants, right? They don't get enough. Well, let me tell you something about the grant picture at Cornell, nowhere else. In one year, not too long ago, there were $465 million coming into Cornell, which came mostly from federal sources. Science, mathematics, and engineering accounted for 441 million of those grants. The social sciences got 24 million, and the arts, humanities, and cultural studies brought in about 500,000. This is not a technical university. This is a liberal arts institution. Do you want your children taught in those proportions? Or what do you want them taught if those proportions? I am begging here scientists to relax a little, no matter how inane cultural studies and other things may be in the humanities. Give them a chance to educate our students how to write well, how to appreciate literature. It's okay if we give them a little extra money to do that, because we get more than enough. If I had time, I would talk to you about myths and stories, but it's time to stop. And there's another difference. And I want to come to the end, and that is, I've given you just a series of vignettes about art and science, similarities and differences. Bassam and I have worked together on so many things, from putting on a play at Wisconsin that Carl Gerasi and I wrote, to bringing an Islamic scholar of science to various universities, on publishing a book about art and science and getting the artist invited to a festival at Wisconsin. We share this culture, we're interested in it, and I'm very happy to join in celebrating a wonderful person who has worked for all of us. Thank you, Bassam.
And Roald, thank you. We always appreciate your insight into so many things. I knew it would be a different kind of presentation. I'm sorry that you weren't here to help us celebrate today, but we celebrate with you, and thank you so much for being a part of this today.
Thank you.
I think Bassam
you.
wants the last word.
Roald? Are you still there?
Yes, I'm here, of course. I'm always here.
We talk science, we talk arts, we talk humanities, we talk using language. Roald, I love you.
Thank you. Thank you, Bassam.
As co-presider, it's my pleasure to introduce Ann Nalley, who's going to talk about Bassam, the ultimate science educator. And this is an in-person talk.
So one of the reasons I wanted to do this today is that you don't always have a chance in your life to thank somebody for having a big influence on your life. And Bassam doesn't know this. So this is Tell It All Day for Bassam. So my title, Bassam, the Ultimate Science Educator. And I'm going to tell you what ultimate actually means. What is the ultimate science educator? I don't know if anybody's ever defined it, but if you wanted to define it, I think you would use Bassam as the example. Here's his achievements. As we all know, he's an expert on chemical education, science outreach, communicating science to the public. He's a noted science demonstrator. And then he's done all of these other things, but right at the bottom, I'm not going to read them all to you, but at the bottom, a great teacher. And I'm going to tell you why I think that's true. And a great communicator. My philosophy of teaching, Bassam has had a little bit to do with this. In order to teach, one of the first things you must do is capture the attention of your audience. If you don't have the attention of your audience, I've been teaching, I finished my 54th year this last year. If you don't have the attention of your audience, then you've lost them before the class begins. You look around and the class is sleeping, or now they're playing with their cell phone, which I tell them they can't do, or they have their laptop computer and they're playing games. So I start off my class at the beginning of the year, which I can't do because my class is starting tomorrow, but I asked Kyle to do it for me. I tell my students, if this is not the most fun class you've ever had, then you should go watch As the World Turns, because you can get back into your room in time to watch a soap opera. But I guarantee you, you're going to have more fun in this class than you've ever had before. Whether we're teaching our students or a general audience, if we don't get their attention, we've lost them. So how do we do this? How do we capture the attention? How do we make sure that everybody's paying attention to what we're doing? I love this a minute ago when Roald said, telling a story. I have 1,000 stories. And one of the things we started to do when I was ACS president, as I started writing the stories down and they said they were going to publish, they gave up. I said, Ann, this is impossible. Nobody can tell the stories like you do. But so I tell a story by wearing a costume. When I first started teaching, and I didn't do this right away. I'll tell you why I didn't do it right away. I used to run into class when I run into class, I made myself a cape. And it was a Captain Nalley. It had a big N on the back of it. I sewed an N on the back. It was a red cape with a big blue N on the back. And I'd run into class with this cape around me, and the kids knew that it was going to be a great story to start the class that day. I was a little bit crazy when I first started teaching. Now, of course, I'm not. But so you wear costumes, and I've worn many, many costumes. I'll share a few of these with you over the years. And in chemistry, we use demonstrations. So I start out, and Sam doesn't always do this, but I do, because it's something I think you adapt your own idea of what a demonstration is. And I tell my students, this is going to be a CHEMYSTERY, chemistry show. And I've always been a little crazy. I bring in this when I do go out to the public to the schools. I always bring in a blank sheet of paper, and my students they hold it up for me. It's blank, and it has a sign written on it that's written in phenolphthalein. And one of the students will run up and paint it and spray ammonia on it, and it suddenly starts turning color, and they've got the Chem Mystery Show. Now, when I did it for when I did the Harry Potter show, when they opened up the new show in the mall, they said, Ann, can you do a Harry Potter show? Well, I didn't know anything about Harry Potter, but I knew that he did mass mystery. He was a mystery demonstrator. He called it magician. And I said, sure, I can do that. I didn't know anything about Harry Potter, but I found out how to do it. And we did this thing then. But what I did is we made the sign, and then we ran out and we sprayed it, and the phenolphthalein ran down, and it looked like blood. So we started out our chemistry show with blood running from it. So in chemistry, we use demonstrations. So where did I get the idea that you use demonstrations? I went to graduate school at Oklahoma State after my first year of teaching high school, which didn't work out very well. That's another story. And I won't tell you all my stories today, because then you'll want to come back and listen to me again. So I always tell my students that you're going to want to take my next class, because you're not going to get all my stories today. So when did I first meet Bassam? He came to Oklahoma to attend something called the OCCE, the Oklahoma Collegiate Conference on Chemical Education. And it was organized by Dwayne Eubanks. And when I was a graduate student at OSU, Dwayne came in. My advisor passed away, and Dwayne replaced him, but he was a year off in replacing him. And so I had to work with Dwayne that first year. I was a graduate student, he was a professor, and we were using the same instrument. And I got to pull it up and down the elevator to take us. When I finished, I had to take it back to him. Anyway, Dwayne and I became really good friends. And I took my first teaching job at Cameron after I finished my master's degree, because my advisor passed away. And I thought, geez, I'm going to be forever. I'm never going to get out of school. So I left the master's, and I wanted to get a job in industry. And I sent out 40 resumes. Nobody wanted me. Nobody liked me. And I went into my teaching professor's office, and he said, what are you going to do, Ann, when you finish? This is in April. I said, I hope to get a job, but I've sent out 40 resumes and nobody wants me. He said, why don't you teach? He said, you're a great teacher. And he didn't give me a chance. He picks up the telephone. He calls the president at Cameron. He's a former president. My major professor there was a former president. He called the president at Cameron and said, do you have an opening? And he said, we sure do. Just a minute and I'll patch you through to the chair of the department. Cameron was becoming a 4-year school from a community college to a 4, and they hired 5 new professors that year, and I was one of them. So I was off and running, and immediately I'd already made a friendship with Dwayne, and anybody who knew Dwayne Eubanks knew that he wanted chemistry to succeed in Oklahoma, and he did everything he could. So this OCCE was a conglomerate of all the professors that taught in Oklahoma, and during Christmas break, every year we would meet, and we did lots of things from chemical education to planning curriculum to talking about what we were teaching. And in 73, he brought in Bassam because they worked together in chemical education to attend the OCC Oklahoma Collegiate Conference on Chemical Education at Ponca City, Oklahoma. Now remember, I started my teaching career in 69. I hadn't figured out yet what I was going to do because I got my undergraduate degree in chemical engineering. That first year at Cameron, I found out what they do with the new teachers. It was like they do in high school. They give you a little bit of everything. So I taught slide rule, and I taught one course in physical science and another two courses of chemistry. I only taught 19 hours. I don't know why I thought it was bad, but anyway, so I wanted to be involved. So I started going to these chemical, and I met Bassam. And what did Bassam do? He came in and did all these demonstrations. And Bassam is the kind of person who encourages you. You need to do this, you need to do that, you need to, and he had it all together. And I was still developing my teaching style. I thought, I can't be a Bassam. But following that meeting, he became my role model and mentor. And so I began to look for ways, and every chance I got to hear Bassam and see him again, I was just absolutely fascinated with how he could do a demonstration. He could make anything look mystery, and he could explain it so well. And I loved it. So he came back to Oklahoma twice more, once to the biennial conference on chemical education. And because I couldn't say no, I went there as Dwayne talked me into bringing in the industry. But anyway, I saw Bassam again. And Bassam can do demonstrations, as you all know. We've heard from everybody else like no one else. Bassam knows what it takes to capture the attention of an audience. Ta-da. And can make fire too. Now, the first time I did this, I remember what I was doing there is I was spraying like a podium powder into a candle. And that day I had a really great aspirator. And so there was a photographer from the Lawton Constitution there, and I sprayed fire. I'm Jesus that went a mile out from where I was, and the photographer got that picture. It was on the front page of the Lawton Constitution the next day and said, Dr. Nalley is a pyromaniac. Well, it started a whole series of letters to the editor, but I learned I could make fire. And by the way, I'm still making fire, but a smaller way, because I did this 3 weeks ago at my summer academy. And so anyway, making fire is one way to catch attention. But I also wore costumes. I've got 6 different witch costumes, but all of them aren't witches. And I have my students, the one presenting with me, they all help me. And we have all these things on the desk like Bassam has. You got to have a lot of things there if you want to do demonstrations. And you need helpers sometime. And so there's one of my high school teachers helping me, because I do summer workshops for high school teachers. I do chemical magic shows for elementary students. I think you're never too young, and it's really easy to capture their attention. They love demos. I started to bring it, I couldn't find it, but I've got it on another slide. I know is a picture of me. This little kid wrote, thank you, Dr. Nalley, for coming to our school and doing the demonstrations. And then underneath this, he had drawn a picture of me. And it was I knew it was me because it had long dangly earrings, but the face was of a alligator. And underneath he had Dr. Nalley and Mrs. Hyde. And this was at like 2nd grade, but he drew this picture of me. So I thought maybe I figured out how to capture their attention. And lots of costumes. When I was president, I think I had a costume for every day. And I went to the board meeting with that costume on. And I still got a little flack about, I think John Crum told me, he said, Ann, don't you think this is carrying it a little too far? And I said, John, I didn't have time to change. So anyway, that's me at the the Fernbank Science Museum. And I remember one little kid grabbing me around the leg and he said, are you the good witch of the West? Or Merlin the magician? And I said, honey, I'm both. And so I learned to wear costumes because like I told you, I made myself, I haven't seen Bassam in too many costumes because he's got all these wonderful t-shirts but then I also, an ACS taught me into doing this. I want you to become an effective communicator to help dispel the fear of chemistry. And they call that Aunt Ann. And I wore that at the exhibition center all day long and gave out free cookies I had an apron on. So anyway, I've worn a lot of costumes in my day because I used to be a little crazy, but now I'm real dignified. What does it take to capture the interest of a 3-year-old? So one of the activities we do, I do a lot of outreach and I bring a lot of kids in. The 6th graders come in, and one of the parents came in with their students, and they make slime out of Elmer's glue. And I call it chemistry in a bag. My kids and I went to the National ACS meeting in Anaheim, and we made 5,000 bags of slime that day as the kids came and went to Disneyland, and it was all in a bag. And I'll say you more about that someday. But anyway, she took the slime back home and she was letting her 3-year-old play with it. And she took all of her farm animals and put it in the slime and mixed it all up. So I think that captures the attention of a 3-year-old. So she sent me that picture back. Well, Sam came back to Oklahoma to the biennial. And by then I'd already made up my mind that he was my role model. And every chance I had, I watched him and I thought, I can't be him, but if I can be half as effective as he is, maybe I've made it. And then we worked together. Bassam and I also we found out we had another interest in common. We also got a chance, and this was the highlight of my career. I never told you this, Bassam, when I got to be on the program with him. We were at the biennial conference on chemical education not the biennial, the internet ICCE in Seoul, Korea. And we were on the program together, and we were invited to come out to do a program for the community. And so we went. There was probably 500 people in the room that day. Bassam got up and gave his demo, and I thought, I don't know how to do all this. I'm not nearly as effective as listing all those things you're going to need. And I was glad Adriane showed all that, because I remember when he came to Carroll, he did exactly that. He sends you a list of everything you need to put together to make sure you did. And I thought, I'm not that good. So what I did is I carried baby diapers, and I knew I could get water when I got there. So the picture of me on the front page of the Korean the Seoul Times next day was 2 little kids holding a baby diaper with me pouring water. And it says, Dr. Nalley says, chemistry is improving lives through the transforming power of chemistry. So anyway, but Bassam stole the show, but we both got to be on the program together. And that was one of the highlights of my career. And I thought, well, maybe I've kind of made it because my mentor has carried me through and given me all these great opportunities. So I continued to model my teaching after him. Like I said, the ultimate came when we were at the ICCE. We have other interests in common, we found out, as we got to serve together on the International Subcommittee on International Activities on Scientific Freedom and Responsibility. And Zafra Lerman is here. She chaired that subcommittee. And out of that subcommittee came the idea of forming the Malta conferences. And so you'll hear from her tomorrow on the role that Bassam played in that and what the Malta conferences are all about. So ultimate, that's what the ultimate teacher is. The ultimate science educator inspires other teachers. You communicate to the public, but you inspire. And Bassam, I'm telling you this because you are my inspiration and my role model. But I know lots of other people who've said the same thing about you and haven't had the chance to tell you, but today I have the chance to tell you. So anyway, I have the set of books still on my shelf, and I still look at them occasionally, although I've developed my own demos that I do. And this is his lecture in Korea, but I'm not going to say it because this is the worst thing you're supposed to do, is put up a slide that says everything. This kind of gives you an idea of what kind of talks that Bassam gave. And I'll be happy to share this with you because Bassam has the talent to put it all together in such a way like nobody else can do. He could do it with demos, but he can also do it with words. And I think that's what education is all about. He talked about chemistry and society, enlightening the responsibilities of being enlightened. He does it all the time. He's so good. And I still haven't gotten there yet, but my goal in life is to keep on keeping on. Maybe one of these days I'll be a Bassam Shakhashiri. Well, Bassam is afflicted with another problem that I have, and it's that he can't say no. It may take him 3 years, but now we can communicate a lot better since we have email. And ta-da! So we had the ACS Pentasectional meeting at Cameron, and it was in 2006. And some of you may know what that year is for. That was the year that I was ACS president. And I sort of talked to Bassam about it, and I'd invited him, and he said, "You know how busy I am?" And I said, "Yeah, I know, because you can't say no, you're like me." And he said, "If it were anybody else, I would say no." So I want to point out this picture. I can't remember if I was what role I had in the Pentasectional meeting, but I was really, really busy because that's the story of my life. So my students went to the airport and picked up Bassam, and there they are with him. And by the way, all 4 of those went on and got PhDs in chemistry. So Bassam has not only inspired young faculty, but he's inspired many students to go on and be like him. And so Bassam, thank you for the role you played in my life, because probably without you, I wouldn't have made it to become president of the American Chemical Society. When I was president, I stood at the close of my presidency, and I got a chance to do on my past president's dinner, the tribute to the 28 presidents that I'd had a chance to serve with during my years of the council. Bassam followed me, so I didn't get a chance to pay the tribute to, but I'm making up for it today, Bassam. So thank you again for all you've done for all of us, and I hope you continue to do it for many years. Thank you so much.
Hello, my name is Bruce Lewenstein. For those who don't know me, I teach science communication at Cornell with a particular interest in the history of public communication of science and technology. And first, I want to thank the organizers for the invitation to participate in this symposium, and I'm sorry that I can't be with you live or in person. Next, I want to apologize. Unlike some of the others in this symposium, I've only known Bassam for 35 or 40 years. We met when he was at NSF, and I was meeting with the head of what was then called the Informal Science Education, or ISE program. It was part of my dissertation research into what the term public understanding of science meant in the years after World War II. The ISE program was a descendant, or perhaps reincarnation is a better word, of the NSF's program in public understanding of science, which had been created in the months after Sputnik, when there was a crisis of confidence in the American science education world. I remember going into Bassam's office, meeting with him, talking for a few minutes, but that's about it. Although I remain connected to chemistry and the ACS through my advisor, the historian of chemistry, Arnold Thackeray, and the organization he created with ACS support, first called the Center for History of Chemistry, then the Chemical Heritage Foundation, and now the Science History Institute, I don't actually remember any other direct interactions with Bassam for almost 25 years. Then, in 2010, I was scheduled to give a talk at Wisconsin, where one of my former students teaches. Bassam saw a notice of the talk and sent me a message asking if we could meet while I was on campus. Of course, I said. It turned out that Bassam wanted help from a historian in sorting through his records, thinking about what lessons he wanted to pass on from his years in chemistry and so on. And as we talked, and because of my connection with the Chemical Heritage Foundation, it made sense to think about an oral history, creating an oral history for the CHF's collection. Well, we've been working on that project for well over a decade now, and we're not there yet, although we have recorded a few conversations. More important, we have had a lot of unrecorded conversations. And that's what I'll be drawing on today. It's fair to say that most people think of Bassam as a chemical educator with a particular awareness of his textbooks on chemical demonstrations. And of course, there's his public presence in the tradition of the great chemical demonstrators that runs from Humphrey Davy and Michael Faraday at the Royal Institution in London through the incomparable Hubert Allier at Princeton. As other speakers in this symposium are highlighting, Bassam is a master of using spectacle to create interest and learning in science, and especially in chemistry. And he calls this his commitment to science literacy. When Bassam talks about his interest in chemistry, he tells the story of a yellow sweater that his mother knit him, and how it sparked an interest in color and in the chemistry behind colors. Some of you have probably heard this story many times. But what interests me isn't the origin of his interest in chemistry. I'm intrigued instead by his words when he introduces the story, as he did in an ACS video prepared for the 2011 International Year of Chemistry. There, what he said was, "When I was growing up in my native Lebanon, my mother knitted a sweater for me." His native Lebanon. He doesn't call it his home country. Indeed, after he left Lebanon in 1957, he only returned there once before he was 60 years old. Bassam is an immigrant American chemist, and I think it's worth exploring how that has shaped his activities and his approach to the world. Many of you, of course, are familiar with the many 50 or more presentations of Once Upon a Christmas Cheery from the lab of Shakhashiri. But outside of Madison, I think many fewer people know about his other annual production called Science is Fun, presented at the 4th of July Independence Day celebrations at the University of Wisconsin's Memorial Union Terrace. What's particularly interesting to me is that this isn't just about exploding fireworks, though of course those are present, along with Bassam's explanations of the chemistry of color, that topic that has excited him ever since his mother's yellow sweater. What's particularly interesting is that for Bassam, this event is also about the celebration of the American spirit. At those events, Bassam distributed what he calls the American Trilogy, a pamphlet describing the Declaration of Independence, containing a reprint of the Declaration of Independence, the Constitution, and the Bill of Rights. You can see this commitment also on his Wikipedia page, which features a talk on the rewards and responsibilities of freedom. Bassam told me once that the concept of citizenship and the practice of citizenship and living citizenship, these are very important for me. So I want to suggest that understanding Bassam Shakhashiri and his influence depends not so much on his contributions to chemistry, legion though they are, but on understanding the way he exemplifies the story of science in America, the story of immigrant contributions to science and to the country. There's a long history of seeing the connections between American democracy and American science. Some of you may know what are called Merton's norms, the description of the scientific ethos developed by sociologist Robert Merton. Merton was one of the great sociologists of the 20th century. If you've ever used the terms unintended consequences, self-fulfilling prophecy, or role model, you're using Merton's ideas. Though his work ranged widely, Merton began his studies looking especially at science. And some of his earliest work identified what we now call the norms of science. And these were communalism. This is the idea that knowledge is held collectively. That's why we don't think of Leonardo da Vinci, brilliant though he was, as a great scientist. He published his technical work only in coded mirror writing. But if the findings aren't communicated, they aren't science. I'll explain the strikeout in a minute. The second norm is universalism. This is the idea that knowledge is the same everywhere. The historian David Hollinger points out that this ideal is particularly relevant for democracy, where in the ideal form, only merit counts, not heritage or status or anything else. Everyone is fundamentally the same and has equal opportunity. The third norm is disinterestedness. This is the idea that scientists put their work out there to be judged and don't have a personal commitment to the findings. Because of disinterestedness, scientists write, "The experiment was performed," instead of "I performed the experiment." The individual is not supposed to be part of the knowledge. And finally, organized skepticism. This speaks to journals and conferences and other public presentations of findings and the fact that they aren't ad hoc, but they're an institutionalized, organized system for testing findings and conclusions. There's a lot more I could say about the norms. In particular, later sociologists have shown that they are ideals, and there's a set of counter norms: solitariness or miserism, particularism, interestedness, organized dogmatism, that are equally present in how science actually operates. But for our purposes, what's relevant is that Morton developed his ideas in publications initially produced in the late 1930s and early 1940s, just as the world faced the threat of fascism from Nazi Germany. Again, as David Hollinger has shown, Morton was explicitly concerned about the, quote, "conspicuous hostility to science manifest in Nazi Germany since 1933, close quote. Morton was trying to connect the values of science to the anti-authoritarian values of democracy, arguing that science has a specific social order that depended on democratic values of openness and equality. And Morton was not alone. In 1943, for example, Columbia hosted a conference on the scientific spirit and democratic faith. There's a long tradition in the 20th century of saying that there's a special tie between science and democracy. But politics is always part of science. When Morton first published his norms in 1942, the first one was communism. Eventually, he relabeled it, and that's why I crossed it out. In the final version, published in the 1970s, he'd renamed it as communalism. The idea of linking science and democracy to communism no longer worked in our American political system. And to some, it was in fact a dangerous idea, which is an issue, of course, addressed in this summer's blockbuster movie on Oppenheimer. Although initially published in the 1940s, the version of Morton's norms most widely known was republished in 1957, coincidentally the same year that Bassam came to the United States. I actually always remember Bassam's arrival date of September 17th, 1957, because it was one day before I was born. Anyway, Bassam's scientific life in college, in graduate school, and in his role as a chemistry education professor, they have grown together with our understanding of the links between science and democracy. And for Bassam, this is a deeply personal connection. On May 24th, 1974, when Bassam became a U.S. citizen, he was sworn in by federal judge James Doyle, whose son later became governor of Wisconsin. Bassam remembered that Judge Doyle said, quote, "said to me and to everyone else, enjoy your freedoms." Part of what's interesting is that Bassam remembers that statement as speaking directly to him, even as he acknowledges that this was a general statement to everyone who was sworn in that day. More than 30 years later, the judge's son, Governor Jim Doyle, was part of the dedication for the Shane Building, part of the chemistry complex at Wisconsin. Bassam asked for permission to say something. He remembers the governor saying, "Do I have a choice?" And then he repeated what the father had said. For Bassam, dedicating a chemistry building was intimately connected to the freedoms that citizenship in the United States provides. This connection of science and democracy is also part of the story of Bassam's time at NSF. He was telling me once about the invitation he got in early 1984 to come to the White House to talk about his ideas about science education. Although he knew that this might be linked to an opportunity at NSF, he didn't know for sure. He flew to what was then still called National Airport, and he rented a car. He drove to the new executive office building on Pennsylvania Avenue. Then he told me, I'd found a parking spot, and I got out of the car, and I had goosebumps. I was awed by being invited to the White House to talk about science and science education. And I just felt an overflow of emotion that in 1984, having come with my dad, my mom, and my two younger sisters to America in 1957, and having gone to graduate school at the University of Maryland just up the street and so on, that I would be in a situation like this. It was overwhelming. Several times as we talked, Bassam returned to this theme, that when he went to NSF in 1984, he wasn't doing it for chemistry or for science. He was doing it for his country, for the opportunities he'd been given. Once we were sitting in his 1981 Corvette, a quintessentially American car, which he lovingly maintains. We were sitting in the dark before going into dinner. He kept reflecting on this, trying to get me to understand that he made the commitment to NSF because it gave him a chance to give back. One example, the opportunity to go to NSF came just a year after Bassam had created the Institute for Chemical Education. Quote, it was hard for me to let go, Bassam told me. Quote, but I felt very deeply and strongly that this is a responsibility, this is an obligation, this is a duty that I should undertake. Another example he was telling me about was the challenges he faced getting funding for science education restored to the NSF budget after the Reagan administration tried to zero out the program. I won't go into the specific challenges, but he talked about what motivated him. Like all federal employees, he'd sworn an oath. I, Bassam Shakhashiri, do solemnly swear that I will support and defend the Constitution of the United States against all enemies, foreign and domestic, and that I will bear true faith and allegiance to the same, that I take this obligation freely, without any mental reservation or purpose of evasion, and that I will well and faithfully discharge the duties of the office on which I am about to enter. So help me God. For Bassam, discharging the duties of office meant rebuilding the NSF's education program. Quote, I'd given my word that the NSF would support science and engineering education. That's why I wanted the words in the oath to be in there. He's talking, I think, about some congressional testimony. It's a standard oath that all government employees take, but to me, it was very special. 35 years later, when he was talking to me, he said, it still is. Now, I haven't dug as deeply into this, but I think that Bassam's commitment to Wisconsin is similarly motivated by his belief that with a commitment to country and state comes a commitment to giving back and to the kind of communal, disinterested, and properly skeptical inquiry that leads to universal knowledge. In other words, the norms that Morton drew from democracy to describe as the core ideals of science. This manifests in Bassam's commitment to the Wisconsin idea, a progressive political philosophy that celebrates both the knowledge developed in universities and the application of that knowledge for public benefit. In the article that my friend Terry Devitt wrote when Bassam retired a couple of years ago, he quoted Bassam as saying, Wisconsin was very attractive to me. I learned the meaning of the Wisconsin idea. I felt it in my bones. I cherished the freedom of scholarly work and public service. Bassam spent 20 years as the first William Evu Distinguished Chair for the Wisconsin idea. And when he retired, he said, I will continue to live the Wisconsin idea. When Bassam and I were talking about the Wisconsin idea, he talked about, quote, inspiring people to public service at the federal level. And then here's a part I want to emphasize. We live in a country that's very special in the way it is organized, even though it's not perfect. I want good people to go into government service. Obviously, there are many dimensions to Bassam Shakhashiri and his work. This symposium is trying to capture many of them. My conclusion is that we can't understand what Bassam achieved through his career without understanding how much he exemplified the immigrant experience, both the ambition to do well and the belief in giving back for all that the United States of America had given him. Thank you very much.
Now moving to Kalamazoo College in Michigan, and I'm here to have another conversation in honor of Bassam Shakhashiri, who I consider the master of having another conversation. So some of you might not have met before, so maybe not quite another conversation in that sense, but I hope after the presentation, I get to talk to you some, even though I'm not there in person, maybe reach out over email and we can chat. But Bassam here, I've worked with for the past 6 years, and it's been a real pleasure. This is one of the events we went to on the right. Bassam is having a great conversation with some people about the bubbles in their champagne. Yes, we were at a fundraiser gala, and we were talking about science through the champagne people were drinking. And Bassam always made it look so easy. Engaged people, he translated from having bubbles in the champagne to important issues such as climate change. And he always had the fire extinguisher. You can see it in the bottom right. We were mostly working with bubbly drinks, but we were prepared in case one of them exploded. So, a little bit on how I know Bassam. So I started working with Bassam in 2018 at UW-Madison. I came to Madison really excited to do science outreach. I was like, great, Dr. Shakhashiri does this awesome work. And I quickly learned that it was a lot more than just science outreach. I've come to accept Bassam's term of public engagement as much more accurate. So I've worked with Bassam on a multitude of projects, everything from doing hands-on science experiments at the farmers market, to talking to state legislators at the state capitol, events at the terrace, at schools, at libraries, going to the ChemEd conference. We've done a lot of different events. Christmas show, always a big undertaking. And through this, Bassam has become a trusted advisor and friend. And it hasn't just been these events we've gone to, we've done climate workshops, we've worked on the climate features workbook, we've done research on different at-home experiments and writing them up for people to try. So I've learned a lot from Bassam during this time. Right now, I can't be there in person, unfortunately, because I'm on my way to Kalamazoo, Michigan, possibly literally in the car at this moment as my presentation plays. And I'm starting a new job as a professor at Kalamazoo College, where I hope to be able to channel some of the good public engagement work Bassam has done in Wisconsin and take it to Michigan. So, what is it like working with Bassam? This is a question I got a surprising number of times from people, both graduate students I worked with and other people. Here's one example. We got a note from a student after one of the events at their school, and it read this way: "Dear Professor Shakhashiri, thank you so much for coming to St. Peter's. I really liked it when Cece poured the dry ice in the boiling water. It was so cool. I also liked the colored water. Thank you so much for taking the time in your day to show us this. P.S. Is working your company fun or a lot of work? Sincerely, Olivia W." Olivia W. was never the only one that asked this. So to give you a little bit of an idea, it was a lot of work. We just packed this whole truck, and then Levi strapped me into the truck, threatening to leave me to ride in the back. Don't worry, I got up to the front of the cab. I was actually the one driving the truck. But this was in prep for a Christmas show. But we'd take this truck all around Wisconsin, and driving the truck sometimes felt like a lot of work. And then I'd pull up next to these semis, and it no longer felt like a lot of work. I'd much rather drive this truck than any other truck. all of it was also fun at the same time. Here, Bassam and Christina have put Science is Fun stickers on their head, wearing some goofy goggles, and who knows what other shenanigans they're managing to get into. But I guarantee you, it was a lot. So it was a lot more than just the events. We had to prep events, plan events, and there was always a lot of conversations before the events. So I want to talk about a few of the lessons Bassam has taught me during the time I've worked with him. Now, I pulled these lessons from sort of 3 sayings that if you worked with Bassam, you heard a lot. The first one is, get the credentials to do the things you dream of. Sam said this a lot of ways, but getting the credentials was always the first goal. In fact, when I first came to him asking if I could work with him, he kind of turned me away. He said it was too early, he didn't accept first-year grad students, and to come back in a year, which is fair. But Sam always wanted us to put our research first and getting our PhD done. And he didn't do this just for me. He made sure that everyone across campus was doing this. He created the Whistle Award for communicating PhD research to the public, where dissertators wrote a chapter in their thesis that explained their research to the general public. And this was good not only for the student, but also for spreading the Wisconsin idea that everyone should have access to the research we're doing. Many of you probably know this, but also as his time as ACS president, had a report on graduate education. But the effects I felt most was when Bassam came and gave his talk to first-year grad students. This is during orientation week. All the grad students are in the large lecture hall, and we've been listening to professors talk to us in 15-minute increments about their research for the past 4 hours, and we've got 4 hours left. Hey, it's supposed to be helping us choose a research group, which is great and all, but 4 hours in, everyone is barely paying attention. Bassam comes in, and he's setting up these colored cylinders, and he starts doing experiments with us, and you can bet, even as grad students, we are waking up for some fun science demos. But it doesn't just stop at science demos. Bassam constantly encouraged us to think about the different challenges of grad school. Here, he was highlighting that we should get enough sleep, get some physical exercise, monitor our professional progress, live the Wisconsin idea, and his last point, always in all caps, have fun. So Bassam early on was trying to remind graduate students to watch out for themselves and make sure they take care of themselves outside the lab. And he would encourage us to keep doing that throughout grad school. He also encouraged us to do this through picking our priorities, aka telling us to stay in our lane. And that doesn't mean we couldn't do things, but it meant thinking about what you're doing before you jump into a totally different lane and miss your exit for a different project. And Bassam himself highlighted this in the way he talked about his grand challenges to society. He narrowed it down to a list of 10. I'm not going to present all 10 here, but the one that I always kind of focused on and picked out that I liked best. From progress. This was also embodied in the back of our truck. There are several phrases on here, but after the science in motion, the very first one is fostering community appreciation of science. Fostering community appreciation helps people help fund science, appreciate science, and spread science, and live the Wisconsin idea in that way. And so everything Bassam did fit into these grand challenges and helping to foster that community appreciation of science. I remember many long conversations where we would be sitting, especially after COVID, when things were just starting to open back up, and why do we want to do this? How does it help? And you had to convince Bassam. He was convincible. I did it sometimes, but you had to convince him. And I think it was always a good exercise in making sure we're doing activities for the right reason. And one of the biggest things we accomplished during that time that I'm very proud of was Jerry led the charge and did a whole ton of work on this climate science concepts to fit your classroom workbook. So Jerry did great work on this. This is another climate science would be another one of Bassam's grand challenges. And Bassam really honed in on this. And not only did he write the workbook, but he involved a lot of the graduate students, which was great for us to see how he went about it. I'll be honest, I've never seen a paragraph of text debated for quite as long or for on such specific words as we did for some of these. But it meant that the workbook is a great and very accurate resource. So this was a very fun project we worked on. I'm sure other people are talking about this, so I don't want to harp on it too long, except to say that it was great to work with Jerry on this and Bassam as well as many others. And I think it was a worthwhile project. And what does this boil down to, though? Well, you might have guessed it from the title of my talk, but Bassam also always said the goal of any conversation is to have another conversation, to leave room open for another one at least. I think this might be highlighted best that whenever I traveled anywhere with Bassam, we could walk into any building and suddenly a conversation would start with someone. It was often, oh, Bassam, I don't know if you remember me, but you taught me so many years ago. And actually, I'm hoping, that one day my child would get you at UW-Madison. Everyone remembered Bassam. You walk into a restaurant and people are stopping to chat with him or recognizing his name, and they all want to chat. They want to have another conversation. In fact, even my dad, when I learned I was coming to UW-Madison, asked if I was going to be able to have a meeting with Dr. Shakhashiri. He had come to Madison 10 years prior for the Science Olympiad national event with my brother and still remembered. So that illustrates that Dr. Shakhashiri really is the master of having another conversation. And he tried to pass these skills on to us. I still think he's much better than me at it, but we're learning. And one of these events that you could tell that he was so adored and people wanted to listen to what he had to say was the Christmas show. So this is looking backstage from the Christmas show he hosted for 50 years. That also aired on PBS. The auditorium's not quite full yet. I wouldn't be out on stage in that case. But by the start of the show, every single seat in that auditorium would be filled. There are certainly examples of people that came as kids that are now bringing their kids to the event. And so this boils down to the three main messages that I'm left with when I think of the phrases that Sam talked about during my time working with him. 1, get your credentials. 2, know your priorities, or as he commonly said it, stay in your lane. And these kind of go together, right? During grad school, I had to get my credentials, and that was the priority, and then not take on too many projects. Pick a project and then stay in your lane. And finally, I think the most important message to take away is the goal is always to have another conversation. Don't shut it down. Connect to people, listen to them, and leave the door open to have another conversation later on. So with that, I'd like to say thank you. Here's a lovely picture of Bassam and the Sciences Fund crew just before everything shut down for COVID at that same gala that first image was from. We don't always dress this nice, believe it or not. But thank you to Bassam, who has been really a trusted advisor, mentor, colleague for the past 6 years. I think will continue to be. I always love our conversations. and the way you've taught me to think about science and how we talk about science, and made me a better scientist and person. But our Science is Fun crew would not run also without Casey, who I think is the most organized person I know, and managed to keep all of us who are running in different directions somehow getting to the right place at the right time with most of the supplies we need. She wasn't even in charge of getting our supplies, but somehow she always made sure we were prepared. Rodney, Jerry, Tom, and Ron are all longtime members of the Science is Fun crew and great advisors. And Ray, Levi, Catherine, Amanda, Mackenzie, and Jill, who also were graduate students in the Science is Fun group with me. And all of these people, we engaged in many great conversations about the best ways to talk about science, communicate science, and increase public appreciation, foster public appreciation of science. That's all I have for today. I'm really bummed I can't be there in person to talk with everyone. Feel free to reach out to me if you want to chat or just say hi. I would be glad to talk with anyone. Thanks, and enjoy the rest of your meeting.
Welcome, everybody, to part 2 of Science is Fun. And we're here to honor Bassam Shakhashiri. I'm really pleased to invite our first speaker of the morning, Dr. Richard Zare. I think we met when you were at Ohio University, right? We go, yeah, that's for.
Where my father failed out of graduate school in chemistry.
Oh my God. So I don't need to say anymore. Sir.
Influence on me. Thank you so much. What a pleasure to be here and a great honor. This is somebody I admire greatly. He's done so much. I think if I might, I'd like to start with a bit of humor of a certain sort. And I want to remind you of an exchange of letters between the wonderful playwright, George Bernard Shaw, and the revered statesman, Winston Churchill. And George Bernard Shaw sent a letter to Winston Churchill, and it said, here are 2 tickets to the opening night of my new play. Bring a friend, comma, if you have one. And Winston Churchill replied, okay, sorry that I am tied up the first night, but I will come to the second night, comma, if there is one. Now, I share these put downs and rejoinders with you because to tell you this is absolutely not what Bassam Shakhashiri's like at all. This man always takes the high road. And I've watched in many difficult circumstances. I was particularly watchful what happened at the National Science Foundation when he came in and he saved the education program, which had basically been decimated, and brought it back to life. And the reason why we really have such a robust program today is thanks to him. I know, because I was chair of the National Science Board later on and heard more about this. But now I'm going to stop this because there's such a limited period of time. And I want to tell you about some new results, if I might. So let me begin. And I'm going to begin with this question to everybody. What's in a 1 liter beaker of pure water? You can imagine you start to ask this question. And you could start with a freshman who's going to be a chemistry major. And the answer will be, 55 moles of water, HOH, right? And there's an Avogadro's number in a mole, which is huge, 6 times 10 to the 23 something. And it's a huge number of water molecules. You ask them, well, what else is in water? And after a bit of thought, the answer is, well, there's 10 to the minus 7 moles of H plus, the hydronium ion. Of course, it's hydrated. And there's also 10 to the minus 7 moles of OH minus, water's neutral. And that's why everybody who starts chemistry learns that the pH, the negative logarithm to the base 10 of the H plus concentrations. A simple way to talk about it is 7. He smiles, and you smile back and you say, yes. Have you ever thought about what is the pH of a water droplet in air, particularly on the outside? And because you're a professor of chemistry and you've just asked him this question, he knows the answer is probably not 7. But what is it and what's going on? And I want to show you some of that. Things are happening at the interface which are not generally appreciated. We teach chemistry generally as if the walls of a container don't matter. They do, and in this case, this is a very small container in air or in oil or whatever. And I want to go through this with you and explain. And I'm going to start with, if I might, for bulk water, these are calculations done by my postdoc, Yu Xia, and DFT calculations. And we of course know that H plus and OH minus do not go on to make OH dot and H dot in bulk water. In fact, when you calculate it, it's delta H. It is endothermic by a lot, 97.6 kcals per mole. There is no OH and H in water, right? Now, what about the interface? This is going to be really important. This really relates recently to work that great person, Augustin Calusi, published in JACS. And here is our calculation. And you'll see that it is actually exothermic to form OH dot and H dot. I'm telling you that water not only autoionizes, but it makes radicals at the surface. We have actually used ESR or EPR, however you call it, electron paramagnetic resonance, and seen the H atom. And we've also collected H2 from water droplets. Okay, this is not published yet. This is new, but this is real. And we have lots of evidence of OH, all types of experiments where we can catch the OH radical, like with tempo or other things, and see it or do reactions with it. This is going to be very important because once you have H dot and OH dot, remember OH is what cleans up the atmosphere. Very, very reactive. Okay, all types of chemistry is possible. Chemistry that you don't first think of. We all tend to think that water is sort of a benign and almost universal solvent, particularly for polar compounds. And now I'm going to show you that water droplets are highly reactive. And here is work, and this is work done in my lab by Dr. Xiaowei Song, who's postdoc with me, and a visitor who's spent now his second summer with me, Professor Chanbasha Bashir from King Fahd University of Petroleum and Minerals in Saudi Arabia. And I'm going to show you that it is possible to spray. Take a look here. Hope I get this to work. Now let me try to get them. Does this make a, well, I was hoping to make a pointer. It did it here? I can't see it, but anyways. Okay, so look, I'm telling you, water, methane doesn't dissolve in water worth anything, but spray the water with methane. In fact, you can do it with methane in air. It's even better. You have droplets, and I'm telling you, you get all these species, partial oxidation. We can turn methane into methanol. Now, what's the point of this? Today, people recognize that methane is a greenhouse gas that's even actually more powerful in absorbing infrared light than carbon dioxide. Many oil companies basically flame off the methane at the refinery. Some people know it's valuable and they collect it and they make liquefied natural gas under cold temperatures and pressures. And it's hard to transport, but very important. But if you can turn methane into methanol, remember methanol is a liquid with alcohol, you really gain a lot if you could do this on a large scale. And here's our simple setup. I hope I'm making clear to you. We're converting methane to methanol using water droplets. Here's a tank of methane. Here is air. You can actually just do it with pure methane, but air is actually a little better. with it because of the oxygen. Here's a syringe pump that's pumping water. We can use water. We can use distilled water. We can use tap water. We've even found you can use salt water. Okay, not that specific. There's a sprayer and we can collect the droplets or we can send them into a mass spectrometer. We've done all types of things. For example, we've done carbon-13 NMR to prove that we have things like methanol. And I'm now showing you, I want to show you what we're producing, if I might. This is just, if you look here, this is the direct spray. And these are in parts per million translated into micromolar. And we get up to over 100 parts per million. And we get up to, as you see, something over 2.5 millimolar of methanol by doing this. Okay. And we don't need light. You don't need ultrasound helps. Air and ultrasound are the best. Ultrasound actually helps us make hydrogen peroxide, which is also done all by itself as we've shown in our own lab. Okay, and you see side products. I'm sorry, I didn't show you. A whole bunch of other side products are being formed because we've got these radical reactions. Here is, for example, methyl peroxide. Okay, and you find all types of other stuff being formed. Okay, we even find we can make things like ethanol and acetic acid from this process. All types of things are coming from methane and water when we spray it. I think that it's certainly, to me, great chemistry news and very exciting and great pleasure. And science is fun, somebody said. And this has been great fun, very, very exciting to see this. I know time's very limited. Let's see what we have. 2 more minutes, I think. Okay, so here are some possible simple mechanisms. Well, thank you. Okay, so look, when you have an H atom or an OH radical around, it'll go to the methane and clip off a hydrogen, forming either H2 or water, right? And then you got the methyl radical. The methyl radical will go on and react. Where does the hydrogen peroxide come from? Well, OH combines with itself in water to make HOOH, that's hydrogen peroxide, H2O2. And in any case, you see, you get all types of things. I forgot to tell you, 47% of the products we see, the oxidation products, are methanol. The problem has been for people who've tried to do this by other methods is that you need partial oxidation. And unfortunately, as you start to oxidize it, it's easier to oxidize it some more. And people end up with CO2 when they start to do this process by some other means. It's very hard to make it, slow it down and make it specific to methanol. So I have great hopes for this process to go on. And now, if I might, I thought of perhaps bringing something to you, because after all, the master of lecture demonstrations is with us. And that's one of the first ways I met Professor Bassam Shakhashiri. So I thought it's important that I show you some lecture demonstration. And however, I'm going to be careful. Now, Bassam, you know, always does them in triplicate. See that, I trust, right? And careful, right? And I decided, no. I'm going to show you this with a control. And this is going to be done by another postdoc in my group. This is going to be by Yangja Lee.
Dick, thank you so much for always showing us that for those of us who are interested in chemistry education, that the emphasis is on chemistry education, not so much on chemistry education. Thank you, Dick.
We're really pleased to have President-elect Mary Carroll. Science made fun for all not dreary, the life's work of Shakhashiri.
Perfect. Thank you very much. And of course, I'm thrilled to be here. I think I'm honored to have been asked to do this. I know a number of the other speakers in the session have collaborated with Professor Bassam Shakhashiri for years. My interactions have primarily, as far as the organizers know, been through ACS governance, but that is not actually how I was first introduced to his work. And so I will start with that. My talk is going to focus on reflections of my interactions, direct and indirect, with our honoree throughout the years. And as was mentioned in the introduction, I'm now in the first year of the presidential succession, and a number of my interactions with him were while he was in the presidential succession. So I really like the symmetry of that. As I start, let's see if this advances. It's not advancing. Let's try it this way. There we go. We'll just use the advanced thing. So I've been on the faculty of Union College, a liberal arts institution in upstate New York, for, I hesitate to say, 31 years. And my introduction to the work of Dr. Bassam Shakhashiri came as I joined the faculty, because these books were very, very influential within the department. And so my mentors within the department directed me to the chemical demonstrations book. They were on the shelves of what we called the chemistry library, which was a really fancy name for our conference room that had a shelf of books. And I believe that the fourth one came out in 1992, the year I joined Union's faculty. And so in addition to being utilized, particularly in our general chemistry courses, these demonstrations were part of a course in chemical demonstrations that my colleagues taught for students in a Master of Arts in Teaching program. Now, Union no longer has this program. We spun off our small graduate program to a separate institution probably 15, 20 years ago. And then it was taken over by Clarkson University more recently. But the courses in chemical demonstrations were an integral part of this one-year Master of Arts in Teaching program that had simply an outstanding placement rate of the teachers. And a number of the middle school and high school teachers in the capital region of New York State and beyond were substantially influenced by the opportunity to do these experiments. And I think it's a real testament to his legacy that so many teachers at so many levels, at so many institutions have been not only incorporating demonstrations, but incorporating these demonstrations into their work. And chemistry is a very visual science, or at least it ought to be, right? I have a colleague in the physics department. He's an experimental physicist who tells me that the best course, laboratory course he ever took was general chemistry. And he's an experimental physicist, because things changed color and they precipitated and gases were formed. And it was just an exciting thing to do. Now, obviously that's not where he went, but he also told me if we ever needed anybody else to teach a Gen Chem lab, that we could consider asking him, because he just thought it was so much fun. And so I was very aware of the work. I'd heard of the Christmas lectures, right? The holiday lectures, which the title of my talk is a play on. And in fact, and this is from a recent article a couple of years ago on his retirement, but this picture, according to the University of Wisconsin website, was taken in 2001. And coincidentally, 2001 is when I joined the ACS Society Committee on Education as a committee associate, and where I first met Professor Shakhashiri. And so this shows him about the time that I met him in person. And so one of the things, that we know, those of us involved in ACS governance, is that there are lots of different things that the American Chemical Society does. And education is one of the really important foundational things. Education in chemistry, excellent education in chemistry. And the Society Committee on Education, or SOC-Ed, brings together educators from lots of different areas, as well as people who work in chemistry and related fields outside of education, in national labs or industry. And so I joined as a committee associate. And for those of you not familiar, committee associate means you're there for a year and you're checking them out and they're checking you out. And you're not a voting member yet. And I was a committee associate for 3 or 4 years before I became a full member of the committee. And a couple of years after that, I was asked to chair the subcommittee on higher education. And I agreed to do that. I said, okay, this is going to be a good opportunity. I agreed to chair it. And then I agreed to chair it before I asked who was on it. Okay. And here's a partial list of who was on my subcommittee as I'm starting as a new subcommittee chair. In addition to our honoree today, former ACS President Eli Pierce, and I believe Mort Hoffman is one of the speakers later on, and that he's on virtually. And I thought, oh, wow. Right. First of all, we're going to have some really lively conversations. We're not all going to agree, and that's fine. We're all working toward the same goals. But we're not going to have people holding back in this room. And somehow I'm supposed to chair this. Right. And I think that's also one of the advantages of getting involved in ACS service, is that you're given opportunities for leadership development. You're given opportunities to lead a group that might be filled with people that are very distinguished, that have longer careers than you've had, and that are all interested in working towards similar goals. And so it's been, it was real privilege to do that. I will say that Bassam was quite outspoken, right? That we didn't always agree about everything. And that was true of everyone in the room, but that we were really focused on helping direct ACS's efforts in science policy. And this, again, was on the subcommittee B, specifically related to higher education. The committee as a whole was looking at K through, whenever education, infinite education. But this was a phenomenal group of people to work with. I do remember having some particularly lively conversations with that. But I was still on the Society Committee on Education when Bassam was elected to the presidential succession. And if I'm correct, you were president in 2011, is that correct? 2012. And so the president-elect in 2011, that's what I was thinking, the same role I have. And so the presidential time overlapped with my time as I assumed the chairmanship of SOC-Ed. And so we interacted quite a lot during that time as well. One of the things that was a major initiative during your presidential time was the ACS Presidential Task Force on Climate Science. And Jerry Bell, your long-term collaborator, chaired that task force, I believe is on virtually today. And what came out of that, one of the things that came out of that was the ACS Climate Science Toolkit, a set of collected information that could be used to communicate about very important topics related to climate science at all different levels. Communicate to the public, whether the public were school children, whether the public were adults within the community, whether the public meant legislators. And this focus was very important. This focus continues to be very important. And in fact, the ACS now does have an Office of Sustainable Development. And if you go to the ACS website and you put in ACS Climate Science Toolkit, you are directed to the new ACS Climate Change Advocacy Workshop. So which has built upon that foundation and which is an absolutely free workshop. This one focused on how to effectively, I'm quoting, how to effectively advocate for climate change action on the federal level. And this is something that's absolutely free, available on the web. And I didn't put where one would click to actually go through the process. But this is something that people that are involved in ACS from all around the world have the opportunity to do. And I think that speaks to the overall legacy of Professor Bassam Shakhashiri within the ACS, as well as within the chemistry community. So I took this right out of an article published on your retirement. And I just want to say something about this article. It's titled, "A Curtain Call for Impresario, Tireless Advocate for Science Literacy, Shakhashiri Retires." And I don't know that I've ever heard the word impresario applied to a chemist. But in this case, it is wholly appropriate and was really nice to see. And here's a quote from our honoree. "Science is a way of looking at the world. Science literacy is the appreciation of science without a deep understanding of chemistry, physics, biology, or any other science. It's an attitude. And throughout your career, you focused on being sure that attitude was a positive one, was a joyous one, that people who aren't scientists see that science is fun." And it's not in my talk because it came through via text this morning. You know, the science world is a large world and it's a small world. And so I have a text from my brother-in-law, Eric Wilcox, Dean of the College of Letters and Sciences, and Mary C. Jacoby Professor of Astronomy at the University of Wisconsin-Madison. And he's got a quote for me to share with you. "Bassam is a remarkable embodiment of the Wisconsin idea. That is our commitment to seeing to it that, in the words of President Van Hise, 1904, quote, the beneficent influence of the university reaches every home in the state," unquote. Bassam's impact can be felt in so many ways, including the creation of the Wisconsin Science Festival. And of course, Bassam has redefined the holiday season in Madison with his show. If you have not been to the Science is Fun webpage, from which I have taken these screenshots, you should definitely go there. It gives an idea of the scope of activities, right? Everything from experimental work to the public's face of science in America to specific things and chemistry of fireworks and statements and writings. And I had to take screenshots because these things move on the website. Science is fun. The website is fun. The little bubbles move. There's changes in color. This gives an idea, and you see the Wisconsin idea that Eric mentioned in the quote I just shared. And the beauty of it and the fun of it is really important. And so I'd like to close simply by saying thank you.
Thank you, Mary.
Of course.
President-elect Mary. And also, please convey, this is for you,
Oh, thank you very much.
and please convey my thanks to my dean also.
Okay, I will.
Thank you so much.
And I want to say for the people online, the bag I've just been handed, I'm not quite sure what's in it yet. But on the outside, it says, "Long live the Wisconsin idea. 50 years, once upon a Christmas cheery in the lab of Shakhashiri." Thank you.
Welcome back to Science is Fun. It's my great pleasure to introduce our next speaker, Geraldine Richmond, who is currently Undersecretary for Science and Innovation, Department of Energy, Washington, D.C., and I think at University of Oregon, right? Okay, got to throw that in. Thank you.
Well, it is a pleasure to be here. You're right, I'm on leave from the University of Oregon. But some of the work that I'm going to talk about today actually originates from a group at the University of Oregon, which I'm on leave from, but they're interesting results. And so that's why I wanted to be able to present it with you today. And it's to honor Bassam. Big hugs, Bassam, yay. What a great honor to be for me to be able to be here with you, because you have been so influential to this field and all the students and others like myself out there too. Okay, so we sit at a time that is very scary. Today, as we watch the death toll rise on Maui, as we watch the fires raging even around my home in Eugene. Fortunately, we're not evacuating yet, but it's scary. And we all know that climate change plays a big role in this. So the earth is changing in ways that we predicted. I certainly predicted in freshman chemistry back in the 90s, but I never expected it to get as bad as it is. But the workforce is also changing. So let's shift to that for a few minutes. So as we know, there's a recent report that's put out by the Deloitte, and it talked about what the Gen Z and millennials want today in their careers. And this was a huge study with 44 countries, as you can see there. And I'm going to just highlight a few of those issues that were raised by those that are in our graduate population and in early stages of their careers. And also then compare it with recent survey data of the ACS on graduate experience. And then I'll come back to show how that ties in with what this study shows. And then I'll end up with talking a little bit about what we're doing at the Department of Energy. And I'll talk about this more at Jean Pemberton's symposium tomorrow. So this special group of folks, they have a lot of concerns that I think many of us do share, but not necessarily all of our departments share as deeply as they should. But it's not just our departments, it's also industry and government laboratories. But they really care about DEI. They want to be able to work in teams that are diverse, have different views, and they also would like to have a little work-life balance in addition to wanting to affect change. So whereas they recognize progress in most places that they work, again, these 22,000 folks, they think it's too slow. We need to do more. So in their jobs, the survey shows that they're really seeking purpose in those jobs. The surveys did not note publications for a measure of impact. They want to have an impact, and nearly 4 in 10 have rejected work assignments due to ethical concerns. And a third turned down employees they feel weren't doing enough about the environment, DEI, and mental health. And that could be not just the companies they're going into, but it could potentially even be graduate school. So they're seeking to drive change at their work. They're more confident in influencing societal change. And increasingly, they want their employers to value what they value. And that's what they're seeking, jobs where the employers value what they value. So what trends then are we seeing in career choices in US graduate students? And how has the pandemic affected them? So this is a series of surveys that were done by the ACS 2013, 2019, 2022. I participated in the research up until 2019 till I took leave for this position. And Dr. Jean Stockard, who is a very extraordinary social scientist, has continued on doing these 3 surveys with multivariate analysis, much deeper than has been done if you were just going to use a team of scientists, chemists doing it. But it's a series. Those that have worked on this is also Priscilla Lewis and a number of folks from ACS that were really involved in the survey. So I want to say huge thanks to ACS for letting us have, or letting Jean have, all the details of the survey so she could do the multivariate analysis that you need to do in order to get at some of the big issues. So let's first talk about career sector of interest and where they're thinking about going. If you look at here, the statistics here, you can see, and we have 2019 and 2022 data here, and you can see that there's an increased interest in government positions as well as in industry over academia. So there's certainly, it's a small shift, but it is certainly a significant shift over into other areas. And then the next, so I've just chosen several of the points that I want to highlight in this survey, because otherwise I could do many more slides, but these are the ones I wanted to highlight. So important to our field, important for climate change issues, is looking to see whether the graduate students are staying in the chemical sciences once they leave. And you can see that over these 3 years that have been examined, it actually is staying pretty steady across the board, even increasing a little bit for those that are extremely likely to go and continue in the chemical sciences. However, what is not shown here is the likelihood decreases from 2013 to 2022 in the 5th year of graduate school. So there's so this is a paper actually that they've submitted for publication. And so I didn't show the data here, but it shows that actually there's a declining interest in staying in the chemical sciences as they go from 1st and 2nd year to the 5th year and plus, from 86% to 70%. So that's a concern for us. Plans to stay in the chemical sciences by quality of advisor-student relationship. So back in the 2019 study, what we found out was that the quality of advisor-student relationship actually declined depending on the rank of the institutions. So for example, those students so that if you use the NSF ranking of the top 25, and then the bottom 25, and in the middle 2, the top ranked ones are the top ranked 25 chemistry departments in the country. And in that case, they were found to be the lesser quality of the student advisor relationship. But that aside, and I'm going to refer back to this in a minute, but the point is that it's great if you have a great relationship with your advisor. You can see here you're more likely to stay in the chemical sciences if you have a good relationship with your advisor. And it gets a little bit, when you down to the poor relationship, of course, it goes down a lot to 22%. And actually, I think I recall that, yeah, I'll come back to that in a minute. I'll come back in a minute. Anyway, highly dependent, it's not a shock to us, right? This is not a surprise to us. The fact that the experience with the graduate student and the advisor is very important. So now I'm going to say just a few words about the experience of the negative impact of the pandemic. And so what's really interesting about this study, especially the 2022, was that we could look at the 2023 data and so forth. But what we really focused on was then the 2022 data, because it was taken about a year ago when the pandemic was starting to slow down. So we were through the worst parts of the pandemic. But I'm going to show you this data, and then I'm going to show you in the next slide, comparing what they thought these impacts were, especially to the pandemic. So let me do this one first. So the striking point is that 94% indicated they had experienced at least one of these personal negative impact from the pandemic. Mental health issues, 80% of the students, 50% increased financial concerns, 33, you can see the numbers just as I read them because they're really serious issues. They're really serious issues. So if you look at then, so when the survey happened and they think back to the beginning of the pandemic, did they feel that these effects had increased or decreased as the time went on? And in fact, what you see here across the board for all of those is that there was actually an increase in stress in these areas after the pandemic, after the heavy brunt of the pandemic. So, and particularly in the increased financial concerns. So you can see that just a tremendous impact of what that we're living with right now, that our graduate students are living with right now with regards to mental health issues, financial concerns, physical health, and caregiving. This really cannot be ignored. This really cannot be ignored. And by not having strong advisor-student relationships in the department, it doesn't help. Or I should say, having good student advisor relationships helps a lot. So these, and so with this, then you can see that nearly 2/3 of the students who reported financial concerns indicated these. So that's taking this all into account. 2/3 of the students overall reported financial concerns. 2/3. 2/3. And that's why the Department of Energy, we are setting the graduate stipends at $45K. And I'm urging NSF to at least come up to that number, because that's at least a minimum to go. We cannot afford any longer to treat our graduate students as if they're just free help. So that's why I've been working really hard at the Department of Energy to make sure that we're getting the graduate stipends up to a level that at least is somewhat acceptable, and that they have health care too. But living on $30,000 and $32,000 a year just does not make it. Does not make it. Now, it's really tough to enforce these numbers. We say this is what we highly recommend, but the PI can decide that they want to pay 30 so they can get a half another graduate student. And we looking for ways at which we can monitor that to make sure that the graduate students are getting the kind of stipends that they need. But it's not just the stipends. You can see all the other issues too. So let's stay on this financial side for a little bit longer, because it really is key. We know from our previous studies and other studies too, that the group that's most affected by these financial constraints are underrepresented groups. They tend to come with less backing from their parents. They tend to come with higher loans. They tend to come with a situation where they can't just lean on family members or anyone else. And so those are the ones that we're most concerned about with the climate crisis, is because if we're going to increase the numbers, it's not just those that are in represented groups, but we also need to increase the numbers that are in underrepresented groups. And if we're not paying them enough to be able to do that, they can go be a UPS driver. What did we see on the news yesterday? You can make, or you can go to community college. And I was at Auburn Community College outside of Denver last week. And you can make 6 figures in 5 or 6 years after being an electrician. Maybe we should all become electricians. Well, anyway, but I don't mean to make fun of this, because this is really, really important. And I don't think that we in the sciences are taking, and our universities are really taking this seriously enough. They're more, as I said here, they're more often reported by students that identify with racial ethnic groups that have been traditionally underrepresented. And these differences are highly significant and remain with controls for the rank of the department and the range. So what this shows is, again, for our top ranked institutions, but also our unranked institutions, that the URM difference and the non-URM difference is still huge, And we have to make sure that we are doing this, that all institutions are being able to pay their students. And one might guess, not always the case, that in the top 25, you might be in a more urban area and so more expensive, but that's not always the case, right? So these are sobering statistics, and they're not getting any better. So based on department rank, again, it goes back to this issue of unranked, ranked, and top 25 almost. And so with this, for URM, not URM, with these data, if I were to take all this data together, almost 75% of the students who identified as URM reported increased financial because of the pandemic. Okay, so this is today, and this is serious. So then shifting over to how this aligns then with what they're finding in the Deloitte survey, they also showed that those in Gen Z and millennials, and you probably see this in the news all the time, over half of them say they live paycheck to paycheck. And I believe that's probably the case for many graduate students too. Economic uncertainty is causing them to postpone big life decisions, buying a house, starting a family, seeking a promotion or job change. We should not consider, under these circumstances, we have to be, I won't say it, we have to be very careful when it comes to starting a family and buying a house and deciding on which state you should go to for graduate school if you're going to be financially viable and also have a family. So, and for the millennials, climate change is increasingly shaping their career decisions. And that's where we come in with the Department of Energy, because we feel we can help fill the void of the graduate students that feel what they're doing in graduate school may not get them the kind of job they need or fit within their values. So as you can see here, only 15% of the Gen Zers and millennials feel able to influence their organization's efforts on sustainability. It's at their academic department and institution too. More than 50% say their research is a brand's environmental impact and political before accepting a role. They think about that. Maybe they'll think about that when they're going to go to graduate school or with the department they're going to go to. And you can see there too, they plan to change jobs or sectors due to climate concerns. That may also be an influence students going to graduate school, but it also may, all of these may influencing whether they're going to go into chemical industry also, especially if they see chemical companies that aren't valuing the kinds of things that they value, including trying to make a difference with climate change. And I see and I hear this every day in the Department of Energy. This is my team that I work with in the Department of Energy. My special advisor is in the back, Vanessa Grisco. She's in this picture too. This is a group that has decided to take their science into science policy, and that's where they're working right now. And they are absolutely passionate about making the work that we do at the Department of Energy save the planet. And I believe that there are other graduate students out there too that would go into the policy area if they knew ways to do that, but they could also stay in the sciences if they saw a way that they could do that too. And we at the Department of Energy are doing the best that we can to provide programs that they can get involved with, and the rest of us too, to go forward. So just to show you some of the things that I oversee all of the programs in the Office of Science, all the basic sciences, $8 billion portfolio of the fundamental sciences that we all love and cherish. These programs all have, in particular the Office of Science, have a number of different programs. We have the Community College Internships programs, which encourages community colleges to enter technical careers by providing technical training experiences. And they have, in the year of 2023, we have 135 students, largely from underrepresented institutions, that would love to explore ways to partner in our laboratories in which they work. And I oversee 14 of the 17 national laboratories, and all of these programs are helping to support. In all the DOE laboratories are working hard to support growing the workforce especially in the climate areas and energy areas as we do the energy transition. The Science Undergraduate Laboratory Internships, the SULI program. This is a lot for undergraduates and recent graduates to pursue STEM careers by going into the laboratories. That's what I did in 1978. I worked at Lawrence Berkeley National Laboratory, and that convinced me to go to graduate school, which I did at UC Berkeley and then continue. So this is really a powerful program too. Renew, reaching a new energy sciences workforce. It aims to build the foundation of the Office of Science Research at institutions historically underrepresented in its research portfolio. And funding for accelerated inclusive research, or FAIR, aims to build research capacity, infrastructure, and expertise at institutions also historically underrepresented through its Office of Science programs. $90 million was available for the two programs in fiscal 2023, and we hope that continue depending on what Congress decides to do. So these are a few of the areas that the Office of Science is working in. And then we also have the other side of my portfolio is all of the applied sciences, all the applied areas, working hard on wind, nuclear fusion, solar, transportation, critical minerals, all these are in their portfolio. They have many opportunities for graduate students to get involved at our applied laboratories and also to get funding at universities, as well as the Office of Science, of course, funds thousands of PIs at universities. So there's a lot to do in these areas, and what I'm proud of with regards to these programs is in the past, the Office of Science has been siloed from the applied science areas, and we've really broken down those silos and connected these programs. So somebody that's doing material science can see how they could impact separations for critical minerals or materials or carbon management and so forth. And so we have, so one of the things that we've done, one of the major things that we've done that's very cross-cutting is our Earth shots. And these Earth shots are targeting the remaining RD&D problems that we need to solve in the next decade. And so, and to advance reduction in greenhouse gases to reach the president's goals. And in my portfolio, the Earthshots reside in my portfolio to bridge the gap. But then with the new Undersecretary for Infrastructure, we then pass what we've gotten done in the applied areas to deployment so we can get out into the field, because we have about $100 billion and $90 billion in deployment areas funds from IRA bill Act. So a lot going on, but we just have to make sure that the science gets done in the fundamental, passed to the applied, and then into the deployment area. And with the energy Earthshots, we've announced 7 so far, and states are buying for these because there's a lot of money for the states, but there's also a lot of money for science. That would be in hydrogen Earthshot, a long duration storage, carbon capture and storage, enhanced geothermal, floating offshore wind, industrial heat, and the best for chemists, clean fuels and products. And there'll be one more announced next month. I'll have to keep that under wraps, but it's a very exciting one too. And making sure that through all of these programs and all this money to be spent, we leave no community and no talents behind. And as Jennifer Granholm, who is secretary, and I would follow her anywhere. As you can see her quote, when you hear President Biden say he wants to build a better America, he means a more equitable America. And so in all of the FOAs that we have going out, all of the grant announcements that we have going out, they all say you have to be inclusive in the communities you're working in and the people that you're working with, every single one of them. So anyone that applies for these $1 billion of money, they have to say how they're going to affect communities that otherwise have been underutilized. And with that, I'll end and say thank you very much. Bassam, wasn't quite the fun talk that you get for the others, but I think it's one that we all have to take seriously. And I know you do too. So great, thanks.
You, Jerry. Thank you so much. Okay. Thank you, Jerry. A vivid display of connecting science with society. So many different ways we can do this. Public service at the federal level is one. It's not the only way. I had the privilege of participating and being part of what I did at NSF nearly 40 years ago. And how refreshing it is for me to see the vigor and the power of what Jerry is trying to do. Connecting science with society is crucial. We all must do it. We engage in chemical research so that we advance knowledge, but we must put this knowledge to help our fellow citizens. A native-born American, an immigrant American. Long live America.
LBNL at Berkeley, he's asking how the national labs can help with graduate students. So we have thousands of graduate students that work in our laboratories, and they work very close. The unique aspect of how they're working in our laboratory is they work in teams. So our laboratories don't function anymore as individual investigators, unless there's a PI that comes from campus that wants to keep doing that, but that usually gets broken down. But the point is that when the graduate students come to work in a laboratory, they work with scientists across the disciplines, which of course at universities we have a hard time doing. And so in this case, it's a unique experience to not only be using, doing the best AI, using the largest exascale computers, the light sources, whether that be the LCLS, the APS, or the ALS, or the Argonne and Berkeley, sorry, these acronyms just come so easily, but also the neutron facilities. They just have access to 28 user facilities, but your graduate students do too, and your undergraduates do too. They are really open. So I see the laboratories as just a really sweet place to be able to do research. And again, you don't just have to be fully employed there, you can use these facilities at no cost. And graduate students then can mix and mingle with graduate students from other institutions too. Thank you, Dick, for asking that question. We're just trying to get more visibility to the labs. Yeah.
Yes, I will. Thank you again so much. That was really good. And I mean, those data are really sobering, right? Especially in relation to the underserved. I vacillate between underrepresented and underserved. I think I landed on underserved for a while.
Okay.
But I think, you pointed out, those data point out, right? That relationship that exists between the mentor is fundamental, right? And that is really what the National Academies call the culture of the place, right? The culture piece. And I wonder, and you might know that NSF have funded some work on the Inclusive Graduate Education Network, on SIMMER, on really getting to that mentorship piece, because it is so essential for our underrepresented minorities. So I wonder if you see the Department of Energy really getting into that culture piece, which might be tricky, but beyond just the funding and the opportunities.
Yeah. So this is what my goal is. We'll see if I can reach it in time. And that is, we need to have a database. Universities, graduate programs need to put out the statistics for the graduation rate and retention rate of underrepresented graduate students in each department in STEM. And right now, the UC San Francisco has a website on the life sciences where universities can volunteer to put the data in. The last time I saw, there were like 15 or 20. I think we need to start requiring this because we need to know which institutions do the best for retention of graduate students, particularly from underrepresented groups, because it seems to me those are the metrics we need to be able to follow over time and not just 1 year. So, I don't know if I can get it done in time, but I couldn't get the National Science Foundation to do that. I couldn't get the National Science Board to take this on. And so I'm working really hard to do it because we have to have that data to decide which departments are really good at this. And then we can decide where we're going to invest our money.
Yeah, it would be great if there would be some recommendation. There would be some recommendation to incorporate inclusive mentoring training, for instance, as a practice, and as you fund these billions of dollars, because you probably know, I don't have to tell you, that you take somebody who's underserved, you put them in a national lab where they don't see anybody else like them. That's a very othering experience for them.
That's right. That's right. And in fact, I think the national labs have improved a lot, even in the last 5 years, and they have their DEI workshop coming up next month. I've seen a huge improvement because I fought them through Coach for 10 years trying to get their data. And so now I just see a sea change in that.
And maybe just last comment. I think sometimes the framework that we think about serving these underrepresented minorities is like take them out and put them in better places. I think there's a corollary framework which take the better places and bring them to the HBCUs and MSIs, so then they can get trained on training these students. They have the know-how. And I think that's such a changing gear. I would love, and thank you for everything you do. I would love to see some funding for that to happen. Take faculty from the top 25 and place them in HBCUs so they can actually learn them.
Actually, we have some of that in our DOE labs. Yeah, because it's absolutely right. Because they got to have their students with them.
Yes, I know. Thank you so much. Yeah.
Yeah, I was really impacted by the statistics on graduate student stipends, et cetera. And I want to make a lot of comments, just, sort of be an advocate for things. And I remember you mentioned, these are the guidelines, but what do you do with the hundreds of departments in this country where I think research faculty, they're like outside contractors. Okay, pardon me for using that term. Trying to save money on labor because they're entrepreneurs. You have departments that just want TAs and they'll just take people in and sometimes throw them out at the end of the year. Okay, that's sort of a fact there. I was active with the U.S. Army Medical Command, and you're probably familiar with their program. If you go into the U.S. Army Medical Command, they'll pay for all of your education. I think if you're in dentistry, they'll pay off your college loans because this is important. That's where the business is. And are we too big a country, or why can't we act like, our counterparts in Central Europe, where the federal government takes care of stipends for graduate students, et cetera. I have no idea about projections. I never know, what's going to be out there sort of 5 years later. But I really like what you're doing, but to me, it's a mess out there, with all of the institutions. So I made some provocative comments, I hope, and I'd love to get sort of some feedback on that.
I think as far as our academic institutions, they're the ones that have to decide that they're going to put, for example, in the tenure and promotion guidelines, the PIs have to demonstrate their commitment to mentoring students and also the success in mentoring students. And until the institutions actually put actions into place rather than just talk, then these changes aren't going to happen. That's why it's so great to be involved in the national labs, because they're really, we really know how to watch this. Are we perfect? No, but at least there's an understanding of most all the laboratories have decided what their values are, and their metrics will be based upon those values. And that's not what we do at our academic institutions. In most, not all, many of our undergraduate institutions are better. And I believe many of our MSIs are better too. In fact, you saw the numbers there. And we have other data too, that the MSIs are much better at mentoring. Finances are not working so well. But on the other hand, I think until our academic institutions take this seriously, but that's just not at the top. That's the departments too. The departments have to decide that this is really important. And I've seen some shining stars out there in chemistry departments, but we could do a whole lot more. I also have been preaching since I took this position that, publications, H indices are not a measure of impact. They're not. They're numbers, but as scientists, we want to see numbers, right? So we really need to think about how we measure impact, and that's what departments have to take up too. And that impact could be how many students that you mentor. I've got Sung-Hee Lee in the back there that works at Iona College. She usually brings like 10, 12 students here to the ACS meeting, undergraduates. I mean, she's like the best of the best in terms of undergraduate researchers. And it scares me when she sends her undergraduates off to institutions that don't care as much about them as she has. So sorry, Sung-Hee, to put you on the spot there. Just happened to be in the audience there. But I just think that we have, if there's any time to take this seriously, it is now. It is now. Okay, that's enough. Great, thank you.
Good morning. My name is Deb Piper. I'm a producer and director here at PBS Wisconsin. We are a statewide network based in Madison on the University of Wisconsin campus. And I have a long-standing history with Professor Bassam Shakhashiri, extending back over 30 years. Bassam presented his first holiday lecture in 1970. And in 1973, we started our partnership with him to broadcast these lectures. I haven't been with the show quite that long, but my first introduction to Bassam and the holiday lectures was in 1989, when I served as the floor manager for the television crew. And I began producing the program in the mid-1990s. I can tell you that we have gone through 3 brand changes since Bassam started his holiday lectures. First WHA-TV, then Wisconsin Public Television, and now PBS Wisconsin. And it truly has been a partnership and collaboration between Bassam, Dr. Rodney Schreiner, their team, and our team to create and capture the best of these lectures and present these 1-hour programs for broadcast. Over the course of a weekend, we recorded up to 4 of these presentations, and every one of them was packed with an enthusiastic audience. Back in 1970, at the end of the first semester, Bassam presented a lecture for his freshman chemistry class. In that class, he conducted fun experiments for and with the students. His goal? Engage the students and encourage them to sign up for the second semester.
Going to happen. Okay, ready? Go. Not very hard, not very hard. Just and you see that in one of the containers here, we are developing a rather cloudy situation. And what's happening is that the calcium hydroxide is absorbing the carbon dioxide that they are exhaling, and they're forming calcium hydroxide. And I think it's pretty close to a draw, so why don't you just stop now? Thank you both very much.
After that first lecture, the word spread, and it became a popular event that students looked forward to each December. The crowds grew, the lectures were open to the public, and the age demographics expanded from the very young to the very experienced. And the key to that was Bassam's approach and presentation for the audience, a great mixture of wow and why and how. With every color change or explosion, Bassam shared some of the chemical reactions and how they happened, but in a fun, informative, and accessible manner.
It is a baby bottle, but I have modified it a little bit. In place of the nipple that has the hole in it where the milk comes out, I have replaced that with the rubber bulb from a medicine dropper. This is a very strong piece of rubber. I'd like to show you how strong it is by attempting to inflate it as I blow air into it. Here we go. Cannot do it. It's a very strong piece of rubber that neither I nor you or any other human being can inflate with the powers of our lungs. So, what do you see? Foam, fizz. You see bubbles, right? What kind of bubbles are those? They're carbon dioxide bubbles. They're coming out of the beverage. I'm going to fill this to the top. And then I'm going to take the screw cap and put it on. Screw it on tightly. What should I do next? You've done this experiment before, huh? So I'm going to shake this, and let's see what happens. And you can see how much carbon dioxide gas is coming out of this carbonated beverage and changing and inflating this very strong piece of rubber that neither I nor any other human being can inflate. So there's a lot of carbonation in carbonated beverages.
Bassam knew early on the importance of media and sharing information to a wider audience than just those in the lecture hall. We incorporated the use of multiple cameras. Extreme close-ups and slow-motion replay of the chemical reactions engaged the audience and helped to explain what they were seeing. Aside from the lectures, we also recorded experiments to accompany the chemical demonstration textbooks that Bassam had written. I'm not going to lie, some of the best reactions and participation from the audience were those big explosions and dramatic color changes. But that is what brought the families back to the lecture hall year after year.
Every time I look at it, it's blue. You tell me when to look, all right? Tell me when to look. Shall I look right now? Right now? You're sure? I don't want to trip over anything. Maybe you can help me better on this side here. Tell me when to look, all right? Should I look right now? Right this second. You sure? I don't want to trip over it. Right now? Every time I look, it's blue. What's going on here? I don't get it. I don't get it. Oh, wow. What is it that you were doing that I was not doing? You were looking all the time. I was looking all the time, but not over here. I was looking everywhere else. I was looking at you. When we do experiments, we have to pay attention. We have to be focused.
Those kids who came to many lectures knew some of the experiments we repeated every year, and yet they looked forward to them, and they enthusiastically participated throughout the show. To capture that wonder and curiosity, and to continue it beyond his classroom, Bassam and his team created fun experiments that the kids and their families could do together at home. Bassam's mantra is evident throughout: science is fun. But Bassam wasn't the only one at the front of the lecture hall. He invited guests to join him in his lab to participate in these experiments and to provide additional entertainment for the audience. Being a holiday lecture, of course Santa was involved every year. Joining Santa and Bassam was the UW varsity band conductor Mike LaCrone, an audience favorite. And the audience always looked forward to an appearance by UW-Madison's mascot, Bucky Badger. Bucky couldn't talk, but he did sport a pair of supersized safety glasses because Bassam always stressed safety first. Bassam is a strong believer in the marriage of the arts and the sciences. He invited young artists to join him for experiments and to perform for the audience. That helped reinforce that it isn't an either-or scenario for the arts and science. It can be a both-and. Musicians, opera singers, and theater actors were all part of Bassam's lab every year. The annual Once Upon a Christmas Cheery program was offered to other PBS stations across the country through NETA, the National Educational Telecommunications Association. So dozens of PBS stations coast to coast have aired the programs over the years. Bassam tells a story of once being in Wyoming to present a lecture, and there on the TV in his hotel room was Once Upon a Christmas Cheery in the lab of Shakhashiri. Beyond the annual holiday show, Bassam and PBS Wisconsin have collaborated on other programs and events. The holiday lecture was re-edited into two 30-minute programs called Science is Fun, which were available to air any time of the year. In 2003, we collaborated with the university's theater department to present and record a production of Oxygen, a play by Carl Gerassi and Roald Hoffmann. And in the last decade or so, PBS Wisconsin has recorded some of Bassam's other public lectures and chemical demonstrations. These are available as part of University Place, which is our virtual lecture hall series, available online and on air. 50 years of sparking curiosity and sharing the wonders of science. As I mentioned, audience members returned year after year. It became generational. Those chemistry majors graduated and then brought their kids. It wasn't unusual to see 3 generations of a family in the audience. And it wasn't just in the audience. Bassam's daughter Elizabeth joined him in the lab to do experiments at a young age, and she returned several more times throughout the years, bringing her daughter on stage for the 50th show in 2019. It has been a great pleasure collaborating with Bassam, Rodney, and their team for so many years. May we always remember, science is fun. Thank you.
I wonder if in doing the Christmas demos, there was ever a time where a demo didn't go how you intended it to. It didn't follow the script, and what you did when it didn't.
What script? We do experiments. We mix things together to see what happens. The TV director, Deb, had an inclination ahead of time of what's going to happen, but when it didn't happen, we just went on. There was a great deal of post-production editing that was done over several days because they videotaped 4 programs at one time. And then they would take which parts were suitable. For the first couple of years of post-production, I went to watch to see what they're doing, and then they kicked me out. But Rodney Schreiner, our next speaker, he was involved not only in the preparation of what we did, but in the post-production activities. And he might say more about this. But we did experiments. There were times when a loud balloon explosion would frighten a youngster. I would walk over to the youngster. They kept that in the video. The whole attempt was to show and to share the joy of science, the joy of doing experiments. And safety is paramount. Deb mentioned this. You all know this. In everything I do, safety is paramount. There were many experiments that We had to tell the director ahead of time what we wanted to show. So the close-ups, they all look spontaneous and natural. They're natural, but she did a very good job with that. Does that help with your question?
Yes.
Yeah.
Thank you.
Rod, you want to talk about things outside your talk?
I can comment a bit also on that. Post-production. Yeah, fix it in post was something we spoke, words we said very often. So we would do 4 shows, and then we would discuss after the first one what we could fix in the next show and what we would fix in post. Most of the fix in post was after the 4th show, and we figured none of this seemed to work. None of it turned out quite to what we had wanted to show. But as Bassam says, there is no script to the chemistry, and what Bassam and I know is that you don't say, now I'm going to show you how this reacts with that and makes, I'm going to mix this liquid and that liquid, and when I mix them together, they're going to turn blue. You don't say that. You just do it. Because the bottle that you took off the shelf may have had the wrong label on it, and what is in here is not what you think it is. And so when you mix them together, they don't do what you think they're going to do. So don't announce ahead of time. Besides, if you announce ahead of time, you're kind of taking the fun out of it. It's not, oh, so it turned blue. It's, wow, it turned blue.
And isn't this really discovery-based learning at its essence?
We had an agreement with the television people right from the beginning that they were videotaping what is happening. And in the process of doing that, they learned some chemistry too. And also became helpful to us in saying to me, for example, when you do this experiment, just do the experiment, but look over here because the camera is going to be over there. So it was a collaborative, cooperative effort. And it all looks natural when you see it on television. I've been to so many different places where people have seen the TV program, and they would say to me, well, in the next 10 minutes, we're going to ask you to do some of the same things that we did before. Well, good luck with that.
And as you could tell from the video that Deb sent, she is a supreme professional, very talented at what she does. She's a perfectionist. So in the post-production, we would be editing something and I'd say, oh, that looks good. And then we'd go on, and then she'd say, oh, 5 or 6 minutes later, she said, no, I don't like what we did back then. We need to go back and do something else. She said, because I just thought of something. And then we'd put that in, and it was much, much better. She is a wonder to work with.
I would be amiss in not emphasizing the collaborative nature of the work that was done, as Rodney and I have been sharing with you, but also financially, because doing television programs is very, very expensive. I'm fortunate to have had access and support to funds that contributed to making this TV production. Everybody that came to the program was admitted free of charge. Nobody ever paid for seeing any of these programs. And it is in keeping with living the Wisconsin idea.
And if I can add what really struck me during all this, at the Denver meeting, was it 2 Denver meetings ago, we did a session called Hollywood Science. And You may or may not know that Donna Nelson, one of our past ACS presidents, was a scientific advisor for Breaking Bad. And the reason I bring this up, obviously, you discussed demonstrations that people could do at home. What came out of this is they purposely had incorrect instructions for how you make bombs and drugs and so on and so forth, because we'd really be in chaos in the country. And in some ways, I think we need to repeat that as well. We really need to have a whole session with, it's communicating science we've been talking about, but even at that particular level. And I'll never forget that symposium. It was a total eye-opener. We got a few more minutes before Rodney talk. Anybody else has any comments that they'd like to add?
Well, on the subject of Hollywood, one of our home experiments made an unscheduled, from our point of view, appearance on a television program. I can't remember the name of the program, but it was a character who was, in fact, I don't even remember the exact scenery, the setup. But what happened is some producer had taken one of our home experiments that's on the web, printed it out, and it was on the desk of this character on a popular television program. Unfortunately, I don't remember the name. This was like 20 years ago. And I didn't see it. Some other person in Texas, I think it was, sent a message through our website asking, did you see your home experiment was on such and such a program? You know, the camera just pans across the desk and there is our home experiment.
Without further ado, and let's hope no more audio interruptions, I'm pleased to introduce Rodney Schreiner, University of Wisconsin-Madison, Bassam and the Fully Human.
And if you don't like the color of my fonts, don't blame me. I'm just imitating the ACS. Okay, so what's Bassam best known for? Well, according to the program for this symposium, the statement is best known for his colorful and sometimes loud public demonstrations of chemical phenomena. Shakhashiri played to packed houses from Washington, including the halls of Congress, to Silicon Valley. His goal was always the same, to convey to audiences the value of science to society and broad science literacy for understanding everything from human health to climate change. Quoting Bassam, science literacy is the appreciation of science without a deep understanding of chemistry, physics, biology, or any other science. It's an attitude. Now, pretty much everything that you're going to hear from me today will be a recap of things you have seen and heard before, because many of us have worked with Bassam for a long time. In fact, I have worked with Bassam for over 50 years. So I know him quite well. He knows me very well. I came to Madison in 1971 as a graduate student in mathematics. I discovered quite quickly that mathematics and I were not going to get along. And I heard through the grapevine from other students in my math classes that chemistry is always looking for teaching assistants. So I walked down the hill from the math department to the chemistry department and went to talk to somebody who knew about the chemistry teaching assistant program, who happened to be the one who ran it, Professor Shakhashiri. I went and I talked to him and I said, can Can I teach? Can I be a TA here? He asked me my credentials. I said, yes, I have a major in chemistry. And there we began. There we began. So what's Bassam known for? Yes, he is known for these chemical shows. You have seen probably pictures of this many times. It is one of his signature demonstrations, cylinders filled with pH indicators into which he drops some solid carbon dioxide, dry ice, I guess, and they change color. They always get the wows and the oohs from the little kids. Of course, what he does is he drops it in. Look, he also had this. Does this pointer work? Let's see. Is that it? Yeah. Oh, you can actually see it. He does these in pairs because when the color changes, he wants you to remember to see this is what it used to be. That's what it is now. So you can tell it's a change because if you look away and look back again, you'll be using your memory. So one of his famous demonstrations. Another one, which is very popular, is the thermite reaction. Here he's doing it out of doors at the Union Terrace during a July 4th presentation. Several of the people prior to me showed the Union Terrace presentation from the audience perspective, audience looking toward him where he is standing in front of the lake. I wanted you to see the audience and how much fun they're having. And I think you can see he's having fun too. Now, if you haven't been lucky enough to see Bassam's show, a big major production, you might know Bassam from these 5 books, the Chemical Demonstrations, the Handbook for Teachers of Chemistry. Incidentally, my name appears in every one of those 5 books. 50 years. But there's a lot more that Bassam does, which doesn't show up in the chemistry demonstration shows, even in the chemistry demonstration books. He has many, many interests. I'm not sure all of them are even on this. This is from his website, which lists, whoops, wrong button. Let's go back. Go back, thank you. Lists many of his interests and activities. And if you go to an inner page, you'll find the Wisconsin Initiative for Science Literacy, which is his organization, which is the blanket or the for all of his outreach activities, engagement activities. And as you can see, nearly all of them say science, 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 science. Yes, he is science. But there are some other words up in here, and I want to today focus on 3 of these. One of them is science, politics, and the economy. Another is science, religion, and ethics. And the third is science, the arts, and the humanities, because those don't get a lot of circulation. They're not as showy as explosions and color changes. So here, science, religion, and ethics. I want to read to you what it says on the screen, but I don't want you to read it off the screen. So 2 of the strongest forces in society are science and religion. Some view them as being at odds with one another, with irreconcilable differences, while some others see them as dealing with different domains of life. WISL programs explore and promote civil and respectful discourse on important issues such as evolution, stem cell research, the complementarity of science and religion, and the ethical responsibility of scientists in the practice of science and for its consequences on society. And as an example of one of these activities dealing with science and religion is a presentation that was sponsored by WISL, Science and Religion and Jewish Thought by Professor Stephen Nadler, who's in philosophy in Madison. Not a chemist, not even a scientist, a humanist, I guess. And it is, down there in the bottom, sponsored by Science, Religion, and Ethics, Wisconsin Initiative for Science Literacy, scifund.org, Bassam Shakhashiri. Another of his activities is Science, the Arts, and the Humanities. Again, I will read for you what it said there. Creativity, passion, and the urge for expression and exploration are essential human qualities that inspire science, the arts, and the humanities, and thus constitute a common bond among them. WISL helps people explore, discuss, and cultivate the intellectual and emotional links between science, the arts, and the humanities. People can value, appreciate, and enjoy science without a deep understanding of specific details, just as they can appreciate music without a specialized knowledge of music theory, or appreciate literature, the theater, and the visual arts without being experts in those fields. Programs of the initiative focus on relationships, similarities and differences in inquiry, creativity, and personal expression among scientists, artists, and humanists. We heard yesterday from Roald Hoffmann, who gave absolutely stupendous elaboration of these ideas. And here is an example of one of the activities sponsored by WISL. The author, Davis Sobel, the author of Galileo's Daughter, came to Madison to speak about her book. And it also is sponsored by Wisconsin Initiative for Science Literacy, but it is also, this is important, it is a collaboration between WISL and the Center for Humanities on campus. So it's science and the humanities. Okay, science and the arts. Both Bassam and I are members of an organization on the campus, the McPherson Eye Research Institute. The McPherson Eye Research Institute has, as part of its physical facilities, an art gallery. And that art gallery shows exhibitions that try to show interactions between arts and the sciences. This was a show, Artists Among Us, which is people who work at the university, not as artists, but who have art as an avocation. And Bassam and I are supporters of this gallery, as you can see. WISL supports this gallery. So arts and sciences. Then music and sciences. Again, a presentation about revolution in 17th century science, Galileo, and music, the transformations from polyphonic music development in the 17th century. So there's a talk and a reading and a concert. Again, sponsored by WISL. Another interaction, this is really quite a special one for us, music and science interacting actually in the chemistry department with chemists providing the music. It is a concert, let's see. Down here, to me, the most wonderful part of it is that it was the world premiere of a sonata for tuba and piano by chemistry professor John Berry. Yes. So he's a serious musician. He wrote this sonata for tuba for a friend of his, and it was performed for the first time in the chemistry building, And then there were other performers, chemists, chemical engineers. We had a few musicians, to perhaps raise the level of performance a little bit, graduate students. And this picture in the middle, the graphic, whoops, my finger keeps slipping. Yeah, wrong way. This picture in the middle, the yellow is a molecule which is constructed by Professor Berry. So the chemist here can tell what kind of a chemist he is. And the blue notes are the theme from one of the movements of the sonata. So that's John Berry. Rather than a picture of him, we have a picture of what he does. So we also, Sam and I, tried to bring music. Deb already showed us this much better than I will be able to hear with her wonderful production facilities. But we involve students, young people doing experiments and performing music during one of the Christmas lectures. Here we have musicians. This is the Pro Arte Quartet, the campus string quartet performing during a Christmas lecture. And we have actors. We prepared a script. This was on, what was it, the 2019. Anyway, the movie, Wizard of Oz came out in 1939, and it was a nice round number anniversary of that. And so Bassam thought, well, let's have the characters from the, I'm getting too carried away here. Let's go back. Come on. Let's have characters from, let's have characters from the movie show up in our show. And here we have Dorothy pouring a pH indicator, universal indicator, into a cylinder of milk of magnesia. And then she's going to pour vinegar on the top, and that's going to change the color of the indicator. It's universal indicator, so you get all colors of the rainbow, which triggers her to sing Over the Rainbow, which Deb had already shown us. And every now and then, this guy appears in the Christmas lecture too. Here I'm doing, let's see, every year the Christmas lecture taking place, we've featured the anniversary of, yeah, that's me, a few years ago. So how long ago? This is rubidium. It was the featured element. What is the atomic number? Some of you have got those nifty. So we featured rubidium, and what we were showing is the reactivity of the alkali metals with water. So that is a sample of lithium. Here's potassium, sodium, potassium, and rubidium. And then these 4 cylinders of water, and I dropped lithium in one, sodium in the next, potassium, which is what I'm doing now in this picture, in the third one, and the rubidium is in the last one. So we got fizzle, sputter, bang, and boom. And that was quite a boom.
Glass cylinders.
Yeah, in the glass cylinders, yeah, but they're open. So, but it did splash. The rubidium is quite enthusiastic. Okay, this is a little bit of spontaneous insertion into my presentation. This is for the old-time chemical demonstrators. Does that remind you, Bassam, of anything? No? It reminds me of a demo that we did frequently during these Christmas lectures, the ice bomb, where it was a cast iron globe, looked kind of like that. That would be filled with water, and then you put the screw a stopper into it, a metal stopper, and put it in a bath of dry ice, and then stand back, because the water inside would freeze and expand, and it would expand with so much force that the cast iron globe would shatter and send pieces flying. This is a lot larger than the cast iron. The ones we used were only hand size. I went to the San Francisco Museum of Modern Art yesterday and saw this. And so this is sort of a spontaneous interaction of art and science. I doubt that the artist who made this even realized that some scientist would think of a science demo that this could be connected with. And now, science and politics. At many of Bassam's presentations, he will distribute this booklet, which contains the text of the Declaration of Independence, the Constitution, and the Bill of Rights. Because those things they are probably more important to him as an immigrant than they are to us who are native born. And he wants us to value what we have, what we just fell into by accident. And there was a beautiful discussion yesterday of the effect of being an immigrant in America on Bassam. So, what's Bassam known for? Well, the program description isn't wrong. Bassam is known for the science shows through which he shares the enthusiasm for science. He tries to encourage people to develop an interest in literacy in science. But along with that, he fosters an appreciation for the humanities, the visual arts, music, theater, and politics. In other words, he encourages people of all ages, all of us, to become fully human. Thank you, Bassam. My teacher, my friend, my colleague,
Thank you, Rodney. And I can go on and on about my relationship with Rodney and his relationship with me. Where do I start? Everything that you see on the website originated with Rodney. He was the webmaster at the beginning. All the artwork on the Science is Fun t-shirt, Rodney. The Science is Fun buttons, Rodney. The artwork that you saw, Concert in Chemistry, Rodney. If you're in doubt about anything you see on my website, say Rodney, because there's no doubt in my mind about the depth on the beauty of the relationship that we have. And I've been very fortunate and continue to be fortunate to share the joy of science with all aspects of human endeavors with Rodney, because he and I share the same ethos and we believe in everything that is good for connecting science with society. Rodney and I have had and continue to have a wonderful relationship, and everything that you hear about me or see about me, always think Rodney. Think Rodney. And so thank you very much, Rod. Thanks.
For the close of the morning, we have a phenomenal talk by the Charnay brothers called "What Makes a Chemist? The Role of Science Communication in the Making of Scientists." That's yours, right? I hope. I don't know where I put mine.
Because there's two of us, I'll try to just project and hopefully it makes it to the microphone despite the distance from the actual thing. So, like was just mentioned, our talk is titled, "What Makes a Chemist? The Role of Science Communication in the Making of Scientists." Make sure the clicker works. All right, so just as an introduction, why might we be here? To start, there's a picture with us and the man himself. To make things clear, that's me on the far side in red. Don't worry, we come color coded, red and blue. My name is Aaron. I am a third-year graduate student in the Stanford Chemistry Department. I'm studying physical chemistry with Professor Michael D. Fair. I use ultrafast laser spectroscopy to measure the reorientation of molecules in polymer membranes. It sounds a bit like physics. I didn't mention any chemical names just now. Don't worry. I am a card-carrying chemist. There's a zoomed-in version of that. For those who couldn't see, it's signed by none other than Bassam Shakhashiri at the Boston Museum of Science in 2016 when we met Bassam. So that's my part. Yeah, so I've been told to mention, why were we in Boston? We were visiting the Science Museum after we had gone on a duck boat ride because that's where they docked. We were interested in science broadly. We walked in and we saw a table that said something like Week of Chemistry, and there were some periodic tables. And I was like, you might like chemistry, but do you have a pocket periodic table? I said to the guy. So I pulled out my one, and I have two more in here actually, pocket periodic tables. But then he said, "Do you know Bassam Shakhashiri is presenting later?" Wait, what do you mean? We had no idea he was presenting at that time, but we'll get into it. We had known about him from a previous experience, but we'll get into that in a minute. So that's Aaron on the far left. We all recognize Bassam in the middle by process of elimination. That's me on the right. I think there's a bit of an incongruity here. Why are there two 24-year-olds presenting at the Senior Chemists Symposium for Bassam Shakhashiri? Okay, there's a cute story that we know Bassam at all. That's fun. But then I think we can also provide some perspective that's maybe not the de default here. And that is how and why someone would become a chemist today. And then we come bearing questions for you all on what it means for us becoming chemical educators tomorrow. So some background, why did we know who Bassam Shakhashiri was when we went to Boston? So we're originally from Cincinnati, Ohio. We went to a public school there called Sycamore Community Schools. And we were the ACS Chem Club presidents at our school. The quote, Chem Club teacher advisor, that's the ACS term for him, was Mr. Michael Geyer. He was in charge of the Chem Club, but he was much more than that. He helped us with our science fair project, which we did in high school. He showed us how to do demonstrations using a series of books by none other than. And we had Mr. Michael Geyer as a teacher, a role model, and a friend. And so it goes to show that becoming a chemist for us had so much to do with people showing us what it meant to be a chemist, a role model, a teacher, etc. And so we propose then, the title is The Making of a Chemist. Neither of us are synthetic, organic, or inorganic chemists, but we propose a route. So, making of a chemist, the synthetic route. So, I'm a physical chemist, a spectroscopist. I fancy myself a physical electrochemist. And neither of us has done any synthesis since undergrad, but let's have a go at it, a first go. So we start with kids, we add demos, and we get chemists. So that's our first pass. Let's think about it. But do you have any literature on this? I think any good chemist, especially inexperienced in the field, should always refer to literature first. So we go to the highest source, the 5-book series on chemical demonstrations, and we try and pick something flashy for our first demonstration, sophomore year of high school. As at the very end, we're going to be presidents next year, but we want to draw an audience. We want to make an impression. So we choose chapter 1, experiment 36 from the series Chemical Demonstrations, the thermite reaction. Addition of a small amount of glycerin to a pile of iron oxide, aluminum powder, and potassium fermenting it produces sparks, flame, and molten iron. So a note, we did not choose the oxidation of glycerin to provide activation energy for this kilogram of thermite. Instead, we chose a magnesium sparkler, which provides the activation energy to then allow this simple redox reaction of iron oxide and aluminum, which is highly exothermic and exergonic, to proceed, with no small amount of flame, spark, and light. And they were doing renovations in our school library at the time. And there's this large landing surrounding it. So we saw this as an opportunity. Okay, we can do something indoors, which we usually can't, with a wonderful audience. Passersby will see a fireball explode for no reason in the middle of the library. And I thought this would be a great way to really set the stage for our incoming presidency to our chem club. And then, for safety's sake, we didn't drop it into water that can trigger, separation into hydrogen and oxygen, and then a subsequent explosion. We drifted into sand, and then we allowed people to take a magnet before the starting material. Exhibits no magnetism, but here, chunks of pure iron. How fantastic. What a fun way to start. What will we do for our first demonstration, our junior year as presidents? Oxidations of luminol, chapter 2, experiment 4. In a darkened room, a colorless liquid and a blue liquid are poured simultaneously into a large glass funnel with a spiral delivery tube. This is a video taken with an iPhone 4 back in the day. That is us in high school doing exactly by the book, featuring helical tube and all the luminol demo. I thought I'd speak on this because I'm a big spectroscopy guy these days, so light is my bit. But anyway, the point of the demo, you can talk about, there's this Witter ion, it's exergonic, it relaxes, and you see light as opposed to what you might see as heat, and it kind of goes against exothermic, exergonic, and that's cool, and you can talk about it. But as a first pass, remember, this is our first pass synthetic route. We want showy, we want flashy. This is a beautiful thing. In the background of this video, there's no sound in this, but a kid goes, it's like a glow stick, the things you snap. And at the time I thought of it, oh no, don't compare it to that. This is a whole beautiful thing. But that's actually the more important thing, the comparison that student made. He made a connection between what was being shown and his life experience. And in fact, that they are both exergonic, light is being emitted, right? So that's actually a beautiful connection that a student made without my input. And I think I've grown as a chemical educator because of that. Okay. So
we've done 2 of the most flashy demonstrations from the first 2 books in the series, Chemical Demonstrations. Let's review the hierarchy. Can we explain mechanistically what we expect to be going on? Because we can't rely just on, you know, experiment. There's some theory. We're physical chemists after all. So there's first in this hierarchy, observing phenomena and learning facts. So we do thermite, we say it's a redox reaction. You can remember that. Okay, electrons moved back and forth. Reduction is gaining, or oil rig. Yeah, that's excellent. Then understanding models and theories. Can we say something about kinetic molecular theory or something like this? Maybe. I think we've hit on these first 2 steps, but can we go further? Developing reasoning skills. This is something you can take away in your own research, in your own life. A priori, can I make a prediction? Can I have an expectation about what's going to happen? And then if you want to become a practicing chemist, I think above and beyond is the examining of chemical epistemology. How do we know something? We observed this phenomena. We made an experiment. We see a result. Why does that tell us this is what's happening? So let's consider our progress so far. We definitely observed phenomena. We saw a big fireball. We saw magma pour out of a pot. We tried our best to explain the reactions, talk about the chemistry. This is iron oxide, this is aluminum oxide, this is iron, etc. So maybe so far in our synthetic model, we've hit 2 out of 4. So let's say we've hit 1 and 2, but can we go further? Can we push developing reasoning skills and examining chemical epistemology? So let's try to go further. Skewering a balloon. Not so flashy, right? But important. And I would actually argue this is my favorite demo that I saw Bassam perform on that day in October 2016 at the Boston Museum of Science. So being the great chemical demonstrator, he wanted some audience participation. And because we had talked beforehand, he chose me to come up and do the skewer demo. So he produced a bamboo skewer and a balloon, put some lubricant on the skewer and said, oh, you've done my demos, do this. Pop the balloon. He said, okay, we bring extras just in case. He gives me a second balloon. I pop a second balloon. He provides me with a third balloon. And again, I pop the balloon, to which Bassam said, and I quote, so we know he likes to pop balloons. So I was embarrassed, whatever, but it's okay. The point is, how does this work? How can we get why this works? Well, spoilers, I'm sorry. There's a thicker part of the balloon at the bottom. There's not under tension, right? So when you stab it, you don't release the tension built up by the elastomer of the balloon. You pierce it as if it were not blown up, and you don't pop an unblown up balloon, so you can pierce the balloon. But it's that reasoning skill, that number 3, that was important in this demo. It's like a magic trick, right? But not so much with the chemistry. You can explain that it's an elastomer, but this is really about critical thinking. And this is what really carries over not only into chemistry, but into a scientifically literate populace. Don't forget to pay attention. The great quote. I think there's some challenge in elevating it to this highest, this 4th in the hierarchy, questions of chemical epistemology. I think this is rather interesting. 1128, formation of a silver mirror. This is the Tollens test, the famous, you can make a Christmas ornament, you can silver a glass bottle of Coca-Cola, you can silver a giant round bottom flask by swirling in this way. Be careful, forms of, nitrides, silver nitride is contact explosive. You have to dilute with water after, but that's in the safety half. That's what we show people is this beautiful silver finish. 2 colorless liquids are poured into a large round bottom flask, swirled. This picture is from my graduate research in electrochemistry in the lab of Professor Matthew Cannon at Stanford, where we focus in utilization and removal of carbon dioxide. That's one of the lessons and messages I've taken away from my relationship with Bassam is this climate crisis we have, and the role and responsibility of chemists as people who are getting credentialed or otherwise to do something about this. And in my own research, I developed these electrochemical reactors, and in the prototyping thereof, I 3D print models, and then, but I'm an electrochemist, things have to be conductive. So you go back to senior year of high school, I silvered a glass Coke bottle. I know how to make something conductive that otherwise wasn't. A tolerance test on the surface of plastic, which then allows me to measure and study ion transport in a pursuit ultimately of transforming carbon dioxide into carbonates for permanent storage, much in the blowing CO2 into the solution of calcium hydroxide. And these are just some of the equations which Einstein, Shmulekowski, and otherwise that model how ion transport goes, and how this reaction allows me to ask and probe these questions of chemical epistemology. So let's look, let's review. Earlier, I proposed the synthetic route where we took kids, added demos, and made chemists. But I remember from sophomore year organic chemistry that at the end of the day, I had to mass something or something along these lines. I'm not an organic chemist. But we had to evaluate our products. So we had a goal product, right? The title of our talk was Making a Chemist. So let's ask, how many chemists did we make? Let's say greater than, less than 1% of chemists. We became chemists, or so we hope. But does that mean everybody who saw the Christmas demos that Bassam put on became chemists? No, let's say 99% didn't. So we had, quote, goal products, chemists, and we had side products. Let's evaluate a scientifically literate public. Let us also ask the question, were we ever trying to make chemists? Is the goal of a scientific educator to make scientists or to make people curious about the world, make them ask questions, make them go through that hierarchy of the chemical demonstration list in their day-to-day lives? Perhaps that was our goal the whole time. So to quote, science and society have what is essentially a social contract that enables great intellectual achievements, but comes with mutual expectations of benefiting the human condition and protecting our planet. So we can meet this social contract both by becoming chemists and by educating others in what science concludes by its methods, right? We can do good in the world this way. And that's a quote from Bassam. Then Bassam, I think, shares this message on scifund.org. He urges personal and community action above and beyond what a scientist's role is. So I ostensibly am a scientist, a chemist working on the climate, the carbon problem, but it's not just the responsibility of scientists, it's also a scientifically literate public. And you can't have this social contract without mutual respect, right? It's easy for someone in academia in the ivory tower to look down on the public. They don't understand anything. This is above them. And it's very easy for someone outside of academia to say, oh, we're snobs and they don't know what they're talking about. Clearly, these are forces too big to control. This is never the message, right? We have to come from a place of mutual respect and say there are things that we can do. And first and foremost is increase your scientific knowledge of climate change, commit to taking responsible action, engage your family and friends, be respectful, trustworthy, and confident when you speak in all things scientific, and then especially about global warming. And in our journeys to graduate school, we talked to Bassam a lot, and he encouraged us that one of the biggest reasons to go to graduate school is to become credentialed so that you can speak on these things from an informed and respected place. And when we first met Bassam, we engaged with some emails. So I mentioned earlier that we worked on a science fair project in high school that Bassam gave input and helped us with. And in our email thread, we had asked him at one point, oh, what could we do to repay you? Because we were so thankful for what he had done to help us. And he sat with us, two kids he didn't know, at the Boston Science Museum for more than half an hour before his presentation. So we asked, what can we do? And this was his answer. This is a quote straight out of my email from October of 2016. Aaron and Ben, here's how you thank me. Do good in the world. And so that is our goal as chemists. as members of the community and as citizens. Thank you. Now, we said we had questions to the audience. So usually in these type of things, a presenter gives a talk and then someone comes up and asks questions. We thought we're in a unique position today to hear from you all with much more experience than us. So we came ready with questions. Why did you become a chemist? What would you want someone going into chemistry now to know about academia that you didn't know when you started? And what is your personal philosophy on being an educator? Now, I don't want to be a teacher and watch as we get no hands and no one to come up to the microphone, but I will do cold call outs if no one answers. Anybody answers to our questions?
I need a microphone.
I can answer all three.
Please, please.
Go ahead, Larry, you're first, but I get to be second.
I loved magic. So at 8 years old, I was either going to be a magician or a chemist. Okay. And I think a lot of us had that as a motivation. 2, you have to be absolutely out of your mind to go into academia. You have to be crazy. But if I could do it all, if I did it all over again, I would do exactly the same thing. Okay. And then personal philosophy on being an educator. I think you have to challenge the students all the time, okay, to keep them thinking. And if any of my students are successful at doing anything, I feel I really did my job.
Thank you.
So I can't resist answering the question. Why did I become a chemist? And I was very opposite from Larry. You have to remember I'm old. And so for that reason, they hadn't invented television. There weren't movies. We rode to school in a wagon with horses. And I started school in Missouri when I was 4 years old because my mother needed to work in the field. She carried my baby brother on the cotton sack when she picked cotton, but I got to ride to the school and go to school when I was 4. I learned to read and read lots of books. Then I moved to Oklahoma when I was 5, and they had a law in Oklahoma, you had to be 6 years old. This was before Head Start. And so I stayed out a year. And then when I started school at Elm Grove, I went to Acorn Ridge in Missouri, moved to Elm Grove in Oklahoma, and I read voraciously. Every book that my brother and sister checked out in the library, they brought home, and my mother read them and I read them. And I read the biography of Marie Curie. When after I became president, a guy bought me an autograph book that he had had for years. And he said, I want someone to have this that will appreciate it and love it the way I did. And I read that and I thought, I want to grow up to be like Marie Curie. I want to win a Nobel Prize. I love science, but one-room schoolhouse, no, absolutely no interaction with industry, nothing. But I had that dream in my mind. I wanted to be a Marie Curie. First 4 years, I went to the one-room school. There were only 13 the last year I was there. So they made us go to a bigger school that had 100 kids. And then I came in and they said, she even knows how to do math. And I did because I wanted to be Marie Curie. And so that's why I became a chemist. And then I'm going to tell you the rest of the story. I tell this so many times to my kids. And I started high school in 56. And then a very big thing happened in the world. On October the 4th, 1957, Russia launched Sputnik. Changed forever my life. The government suddenly said, we need to get more young people going into STEM. They started the visiting scientist. They started the National Science Foundation started summer programs for high school students. Because I wanted to take physics when I was a senior, I signed a petition in my junior year with 16 boys and me in my freshman year to have a physics class. So I had to take chemistry my junior year, little school. I had to finish the book by the time high school teacher. made us finish the book by the time January came, because that's when they had the state chemistry contest. I won it. We had no telephone. We had, I lived way out in the country. We made our living as farmers. And my high school teacher, I'm telling you this because he sent my name in as a nominee for the first ever National Science Foundation High School Institute Summer Academy. And I don't know, somehow he must have written a good letter because we didn't have a telephone. I lived in the country. They called me and got me out of history class and said, you've been selected to attend the Oklahoma High School Institute in Chemical Engineering for 6 weeks, all expenses paid. And I thought, geez, this sounds like a great idea. And I said, I wonder if Daddy will let me go, because I had to work in the fields in the summer. And I thought 6 weeks, I'm going to get killed. But I went home and I said, Daddy, I got a chance to go to this summer institute this next summer. And I really want to go. I said, it won't cost us anything. And he said, is this important to you? Mama said, it is. And I said, yes, sir, it is. And I went and I came home with a slide rule after 6 weeks with my name engraved on it. There were 6 girls, by the way, and 20 boys. They were from all over the United States. We had one from New York, one from California, 2 from Arizona, and 2 from Oklahoma. And then the guys were from everywhere. I came home from that. This is not my talk, so I'm going to shut up. So that's why I became a chemist. I came home with that slide reel engraved, my name engraved on it, never looked back, never looked back. And what would you want someone going into chemistry now to know about academia that you didn't know? I didn't even want to be a teacher at first. I wanted to make money. I was poor. And when I couldn't get it, I got my degree in chemical engineering. Nobody wanted me. They weren't ready for women. That's a whole nother story. So I changed my major and got a degree in chemistry and taught a year of high school. Another story I'm going to write one of these days. So then I went back to school, got a master's degree, got a job teaching. I sent out 40 resumes, weren't ready for me. So my professor said, Ann, you should be a teacher. So I became a teacher. Absolutely loved it. And my philosophy as an educator is, I want to prepare my students for the future. And I want them to love chemistry. That's it.
Thank you. Oh, thank you. We'll send you. Any other respondees? High school. It's a common thread. Yeah. Also, our mom made a big difference. She was very encouraging. Yeah, we've been very fortunate. Yeah.
I think there always has to be at least one person that's inspiration.
Yeah. No. That's this. This was to prompt conversation with an audience with more knowledge and experience than we have. Any other takers? Because we can answer for ourselves.
Yes.
So why did I want to be a chemist? So my interest in chemistry specifically started, I wanted to be a physicist, and I've heard this a million times. I wanted to be a physicist, but I wasn't good enough at math. That's partially true, but I ended up a physical chemist, so maybe I'm okay at math. But I became a chemist because everything I touch, everything that I interact with in the physical world is a chemical. It's a chemical thing. It's made up of chemicals. And I feel like the interactions thereof are so fundamental to everyday life that there's no other field that I could otherwise do if I want to understand the world I am in. So that's what drew me to chemistry as a scientific field. Why STEM? Our grandfathers were an electrical engineer and a chemical engineer from the Soviet Union before they immigrated to the United States. And they both encouraged us to do math, to do science, to play with cardboard, scissors, and paper and tape, make whatever we wanted to. So they encouraged us to be creative scientifically. And then later on, our mom was very supportive. And then, of course, our high school teacher, Mr. Michael Geyer, helped us along the way. I can't answer the second one. And then my personal philosophy for being an educator,
I'm limited in this regard. I've TA'd general chemistry, quantum mechanics, and spectroscopy lab. So I've taught some students, and I think the key is to be part of their learning experience. Instead of they're over here and I'm over here on a chalkboard, I write down a question, I pick someone, I give them the chalk, and I go sit down with them. I pretend that I don't know, and they have to explain it to me. So that's been my personal approach so far. But I have, of course, there's room to grow, and I hope I do. Anyway, so again, I'll skip that middle one. I love Aaron's answer to why becoming a chemist was the only option as far as he could tell. I also think it was the only thing that I could have ever done, if I'm being honest with myself. At one point I said I would be a dentist or an aerospace engineer, but that was all joking to myself and like trying to make adults happy or something. No, I think what motivates me, even as a child playing with cardboard, scissors, and tape, was seeing, identifying, and then addressing a problem. And I think the problems in our world today are so big and so numerous, but the unifying piece is that they are chemical fundamentally. Carbon dioxide is an acidic gas. The solution will be somehow a base. That's a fact. It is always chemistry, I think, that will solve the biggest problems in our world. And that's why I felt that I needed to know as much as I could about that. And then as far as being an educator, our mother was a math teacher in the Soviet Union. She says we have it. I don't know if that's true, but my personal philosophy is just to be engaged. I think I've seen so many lectures where it's a chore for the lecturer, or at least seems to be that way. I love this topic. I love this field. I want that to come across. Obviously, we're young, stars in our eyes, but when I TA analytical chemistry, electrochemistry, I want to show you something, I want to explain it to you, and I want to do it with you, and I want you to feel what I feel about that. If I could ever convey that, even a little bit, I think we could have this 1 to 99% yield for an educated populace and chemists. Thank you. Thank you.
My job yesterday, but part of teaching is to entertain. You guys are great entertainers, by the way. I love it.
Aaron, this is for you. Thank you. Ben, this is for you. Yes, pay attention.
Pay attention.
Pay attention. It's important to pay attention. What's more important is what you do after you pay attention. And I want you to know how proud I am of both of you after you paid attention in 2016. Thank you both very much, and do good in the world.
That's right.
I'd like to welcome everyone to this third and last session of the symposium to honor Bassam Shakhashiri. And we're going to have 6 papers this afternoon. One of them will be virtual, one will be recorded, and the rest will be in person. So it should be a very, very wonderful afternoon. The first presenter requires no accoutrements, no screen, no nothing, just himself. Brian Coppola is going to present a talk entitled Bassam Shakhashiri, Educator. So Brian.
For God's sakes.
All right. Is everybody on? You can hear me. I know that's pretty loud. Too bad. I teach in a classroom with real students. Let's see if we can go a little lower.
Yes. But I don't think because usually we see the name. Well, I think.
This is frozen in place so that it's not flipping around. Okay, is that a little less loud? It's a little less loud. Is it okay? If I be myself, I'm gonna blast you right out the windows. Okay, welcome back from lunch. I am, everybody sit back, relax, go into your food comas. I'll try not to give you indigestion. Thanks to the organizers. Thanks for the invitation. Thanks for the opportunity. Thanks for being here. So I have 4 parts to the story that I want to tell this afternoon. So let's see how I do. And there's going to be nothing there to see except that advertisement. So look here. Part 1 of 4. Part 1 of 4 is titled, "What is a Professor Shakhashiri?" If you read these abstracts and look at the talks, listen to the talks, describing Bassam, Professor Shakhashiri, is a bit like the old fable of the blind men and the elephants. Everybody is using their own perspective and experience in order to answer the same underlying question. And that underlying question is, what is a Professor Shakhashiri? Some describe Professor Shakhashiri as an author. Some have described him as an activist, a scientist, a citizen scholar, a politician, an advocate, a leader, an innovator, a communicator, a cajoler. Harry Gray called him a critic, a visionary. I elected to use educator. Let me try to draw the answer to that underlying question. What is a Professor Shakhashiri? From these various descriptions of his metaphorical trunk, ears, tail, legs. To that end, coming up with a unified picture. To that end, I end up with a familiar term. The term is a word that represents a solemn tradition, the practice of bearing witness to important things and to speaking truth. To bear witness to important things and to speak truth. You know what that verb is? That is the verb to profess, the noun form, professor. The question was, what is a Professor Shakhashiri? The answer is, yes, exactly. A professor to him, and I assure you all of this if you do not know it, but you should know it. A professor to him is not a job description, a title, or an honorific. It describes an obligation, a responsibility that he takes seriously, which he's always taken seriously in the decades that I've known him. To bear witness to things that are important and to speak truth. Part 2 of 4 is titled 1981. If you read my goofy little abstract, you recognize that 1981 appears there. And that was a warning to you that I'm about to get autobiographical. I joined the PhD program in organic chemistry at the University of Wisconsin-Madison in 1978. I was 100% on board for a career as a faculty member. I had been interested in education since the first day I stepped into first grade. I wasn't interested in being a chemistry faculty member at that time. I was going to be a teacher, but it, evolved over time. I was always strongly motivated by and had nothing but the most extreme admiration for the educators in my life. And as a footnote, in 1978, when I began graduate school, I entered graduate school with 10 publications in the Journal of Chemical Education. Spoiler note, they were cartoons. I was the cartoonist. I didn't teach in grad school, actually, at least not as a TA, because I was on fellowship. And my vision of my faculty or future faculty work was really quite traditional, using the research enterprise as a vehicle for education in the laboratory, and a person who has supreme didactic skills in the classroom. I had no awareness or understanding at all of what was going on in the general chemistry program at UW-Madison at the time. I wasn't a TA. I basically didn't know what else was going on outside of the 5th and 6th floors of the chemistry building where the research labs were located. Although I guess I knew where the library was, I knew where the NMRs were, and I knew where the vending machines were because I like Snicker bars. By 1980, all of that lifetime of exuberance and optimism had turned into cynicism, depression, apathy, and lots of personal drama. And I will be the first to say that had I access to a time machine, the first thing I would do is go back to 1980 and kick myself in the ass. Worst of all, I had intentionally disconnected from that lifelong career goal. I was not going to do that anymore. I didn't want to be those people. And to illustrate to you exactly how serious this is, and this is not some kind of rose-colored story that I'm presenting to you today. One of my views as a faculty member is a person who has an elegant office, wooden bookshelves on all the walls filled with your reference library. I'm just from the 1930s. And during my first 2 years of graduate school, I had already invested some effort and fellowship stipend into building that library. And once I decided that wasn't for me anymore, in a peak of acting out, I sold all those books. Aw, Mike, you had exactly the reaction I wanted you to have. Aw. Well, I'm here. So the story turned out. Two things happened to turn me around. First, I started volunteering as a graduate student in a brand new student-run study group program called the Greater University Tutorial Service, known as GUTS. It was actually the brainchild of some School of Education graduate students. Itself is a really interesting story. I was the very first graduate student to ever teach in that program, and I was the very first person they ever found who was willing to lead sessions in organic chemistry. This work, even honestly thinking about this work, had reignited my fire to get involved in education. It did not, however, solve the problem of how I was going to get through grad school. So the thermodynamics was set, the kinetics was still open. Second, the director of our organic laboratory person, a fellow named Paul Schatz. Schatz was a graduate of the department, and he was very much an informant in the department, a person to whom graduate students turned all the time, including me. He was probably sick to death of me being in his office whining to him about my life and failed career. He had the good sense, however, to ask me whether I had ever talked to Professor Shakhashiri. I said, no, I don't know who that is. Paul said he would be a good person to talk with. Now, I suppose that meant that I ended up having to walk down an actual hallway and knock on an actual door. This is 1980, there's no email. I could have sent a carrier pigeon, I suppose. I don't actually know if he invited me in at that moment after I knocked on the door, if we made an appointment. I don't remember. But my recollection, the thing burned into my memory, is the very first part of the meeting when we had it. Gentleman scholar that he is, he sat and listened to me whine for a while. Although I reckon it was a story he had heard before. The first thing he said to me, and this is now burned, there's a whole group of neurons just associated with this, and it will be there moments through my death. He looked at me and he said, you're a grad student. 3 things happen in grad school. First, you hate your chemistry. Second, you hate your advisor. Third, you just want to get the hell out. The effect of hearing that, I promise you, that simple generalization was profound for me, because my reaction at the moment, and I tell you this is true, was, oh, so this is a thing that happens. It normalized it in a sense. Now, I'm pretty sure that the rest of the conversation was more or less a boot up my ass. And I don't have much impression about the details of it, except for the overriding message. It happens to everyone. Put your head down, lean into it, get the job done. I have that conversation and had that conversation with many graduate students in my office over the years. My version of that, because I wouldn't want to steal that copyrighted line. My version of that goes like this: stop treating graduate school as a career. Your only job is to get out. I won't pretend that the rest of my graduate career went smoothly, but at least I had one. And I am convinced that my collision as the 8 ball on the table with the Shakhashiri cue ball is what knocked me on path. Part 3, an academic uncle. Family psychologists study the important roles that aunts and uncles play in the lives of children. Given how much stock we collectively place on academic lineage, our academic parent, our academic grandparent, our academic children, our academic siblings, I point out to you that it's kind of weird. We don't talk about our academic aunts and uncles. At least I've never heard anybody talk about it. According to the literature on family psychology, when adults reflect on their relationships with their aunts and uncles, the first thing, of course, they remember is having fun with them. But being a good aunt or uncle is not just about being playful. It's about being a supportive and loving person who serves as a lifelong role model. In fact, just last week, I was back in New England, which is where my family is, and spent a glorious day with my best favorite aunt in the whole world, who is still alive, still sharp as a tack, and about to turn 90 years old. It was a great visit. Everything the literature says is true. And according to the literature, an aunt or uncle, listen carefully to these descriptions, an aunt or uncle has up to 6 different characteristics. 1, you are the cool adult in the room. Your life experiences are different than those of the parent, and that makes you cool right off the bat. You don't have responsibility for the parenting role, and you allow the kid in you to come out. Number 2, you are a confidant and a trusted advisor. People always generally say that they can talk to their aunts and uncles about things that they are uncomfortable talking to their parents about. You, as the aunt or uncle, add a different perspective. They may be open to telling you things and listening to your advice at the point when you really need it. 3, you are a provider of what they call extras. Maybe you're slipping your niece some money for something. Maybe you're taking your nephew on a trip. You are supporting them to take a risk. My aunt that I told you about, I have such vividly wonderful memories of her taking me to museums, because I can assure you that if my parents ever walked into a museum, it would have burst into flames. The aunt and uncle make them feel special with these extras, particularly the open availability of candid conversation related to the shaping of life experiences. Number 4, you are a role model. You represent an alternative life of an adult through example. Whereas the parents might give advice that is telling, you are showing. You are what is called, number 5, you are what is called the family compadre. This means that you have insider knowledge. The aunt or uncle knows the parents and the history of the parents. So the aunt or uncle can become the mediator or peacemaker in ways that the parent-child dynamic excludes. 6 of 6. you are a cheerleader. Aunts and uncles keep up with the activities and goals of their nieces and nephews through triumphs and failures. You are a fan, no matter what happens, and they know it. Do I need to explain this any further? I hope not. These are the traits that are self-evident in my history with Bassam. The cool adult, the confidant and advisor, the provider of open conversations, role model, the family compadre who understood my academic parent, and a cheerleader. The person who helped make the difference at that critical moment was Uncle Shakhashiri. As it turns out, years later, I found out that I had two other uncles in that department. People who were watching this dysfunctional dynamic happening between me and my academic father, who told me years later that they were ready to intervene had things gone south. I didn't know that at the time, and it was really, really interesting to find that out. It suggests to me that we don't talk enough about this concept of the academic aunt and uncle and the role that these people play. One more moment of self-deprecation, then I'll stop. Believe me when I say the majority of the discord here was on me. I can be nothing if I'm not a giant pain in the butt. This concept of the academic aunt and uncle, this is a good one, I think. And it is certainly one I have embraced. My door has been opened. Appointments have been had. Conversations have been had. And I have tried to be good in turn. I embrace it personally. Part 4 of 4. Part 4 of 4 is called N equals 1. Something that gets overlooked, I think, in the answer to the questions, what is a Professor Shakhashiri, is his seminal role in demonstrating that the title Professor of Chemistry was absolutely positively the legitimate title for the work of his career. And that a title such as Professor of Chemistry Education is not only unnecessary, but completely wrong. It immediately would have put a second-class asterisk on being a professor. If I limit myself to the usual suspects, and we heard about some this morning, the usual suspects of the top 25 chemistry departments, by whose ever measure we care to use, then prior to 1996, the number of junior faculty at one of those departments that had a tenure review because of their contribution to education was exactly 1. The 1976 review of Bassam Shakhashiri. Now, I'm not talking about departments that go out and hire a senior person, although you can't find any of those in those departments. I'm not talking about departments in which somebody has taken their previous tenure for laboratory chemistry and changed it over. I'm talking about the intentional and deliberate decision from the front end to have a person in that position and to carry out the review in one of those departments. Now, the how and why of this happening at Madison at that moment turned out to be an interesting story. I'm not going to relay that story. You want to know that story? Let's see. The details fade over time, and they're not my important message. My important message is one of precedent and leadership. Because when the thing finally happens, the argument, "It'll never fly, Orville," disappears. Just as in science, once you have N equals 1, that concept that it's never been done before becomes moot. Unlike science, however, this particular precedent can result in replication, but the replication is not cloning. Social context, individuality, prevailing norms differ from department to department and collection of people to collection of people. You are not going to get an exact copy. 1976, N went from 0 to 1, which as far as I know is an infinite increase. The second tenure review case does not happen until 1996. He is by no means a clone of Bassam Shakhashiri. He is, however, the person talking right now. There was plenty of debates in the years leading up to the decision on my case, but I will tell you that the Shakhashiri precedent was enormously important. My college had a very heady policy debate on the inclusion of discipline-based education as a part of the professor ranks at my university, and that was a great debate for them to have. After the decision on my case in 1996, a few other departments at the University of Michigan tried to use my precedent to move other people forward, get those positions in. But social context matters. It always does. There was, the year after my case was decided, a new dean in the College of Literature, Science, and Arts. Someone who had been an associate dean in the department, in the college, and a person who had been perhaps the most vocal detractor for my case. He was opposed. Now he was dean. So when those other departments came forward, he had a single 2-word reply to them for 10 years. Never again. Well, never is a long time. Deans have term limits. Time went by, norms change. In 2021, 2 years ago, the third tenure review case at a top-ranked chemistry department in education took place in my department. She is not a clone by any stretch of the imagination. Norms change, social context changes. There are 2 other upcoming reviews of such individuals. Both of them are at UW-Madison. No clones. And I am sure that the fact that these things are happening at Ann Arbor and Madison is a simple coincidence, he says ironically. My point is that Shakhashiri was N=1 for the tenure review process that I'm talking about, and that should not be forgotten in the list of answers to the question, what is a Professor Shakhashiri? So, in summary, 1, Bassam Shakhashiri is a professor in what I consider to be the most sacred sense of the term, bearing witness to important things and speaking truth. With his open office and open conversation, he helped knock me back on my path. We should not overlook the value of our academic aunts and uncles and should talk about them more, which if there's a bottom line to what I have to say, that's the one I'd like you to walk away with. And finally, Shakhashiri had an important role for helping define the breadth of what it means to be a professor of chemistry, and that should not by any means be overlooked. So my final summary comment, I'm going to leave you with the words of another singular rebel, a true N=1 person, the late Stan Lee. Stan Lee, who was the N=1 pioneer in the world of superhero comic books. He was the uncle to some awesome creators. Uncle Stan's most frequent advice to young people is an apt description, I think, of Bassam's life and the example that he sets. And I quote, "Figure out what you think you should be doing, what you are excited about, what you think is right and important, and give it your best shot." Bassam, thank you.
To say, Brian, that you make your uncle proud would be an understatement. The sincerity and the depth of what you tried to communicate with us is moving. But it is in keeping with the relationship that we have. And I express deep gratitude to you for attempting and beginning to document what this whole process is about. The process of clearly identifying and looking up to what a professor is. Thank you very much, Brian. Thank you, thank you, thank you.
Our second presentation this afternoon has three presenters: Ann Nalley, Elizabeth Nalley, and Zafra, Lerman, and Morton Hoffman. And the title is Bassam Shakhashiri, Global Educator and Promoter of International Peace through the Malta Conferences. That's a mouthful, but I'm sure it's going to be a great presentation. Ann? All yours.
So what is an educator? So I started off yesterday. And what we've heard for the last day and a half is, I think Brian said, who is Bassam? What is an educator? What does it mean to change the world? So we've heard in our many presentations today, the Bassam has had a big role in that. But what you don't know is that not only did he care about his students, but he cares about what's going on around the world. And so early on, I told you yesterday about my story of how I met Bassam when I was a young faculty member, and he was a young faculty member, but he had it together, and I didn't quite have it together yet. But as we got to know each other, we found out that we had another calling, that we cared about not only our students, but the future of our world. The future of our world has to mean that we care not only about what goes on here in the US, but what goes on around the world. We had an opportunity to serve together in the American Chemical Society on a subcommittee of international activities. Now, I'm going to say this, and I'm not criticizing the American Chemical Society. Suddenly, about a lot of things, they're waking up. They started an office of DEIR. They're calling more attention now by establishing international chapters. But Sam and I worked under a woman who's going to actually do most of the talking today. Another one of my mentors and my role models, Dr. Zafra Lerman. She stood before us and told us that we could make a difference around the world. Sam chipped right in. And as he moved on to become the president, he tried to carry that forward. So what we're going to talk to you today about is a common love, something I call the Malta Conferences. And following 9/11, we wanted to, or I didn't, it was Zafra's dream that what was going on in the United States, if somebody wore a turban or spoke Arabic, even looked Arabic, people turned away from them. If you looked international, they turned away from them. So we wanted to change the world, and we knew the only way we could do that is if we understand cultures of other people around the world. Maybe we can bring them together, and we have to make them understand each other, and we had to make them begin to work toward world peace. So Zafra came to the board, came to our subcommittee with the idea of creating something called the Malta Conference. What the Malta Conference was all about was bringing the scientists in the Middle East together in a protective environment where they could get to know one another, where they could understand each other's culture. And as we know each other, we begin to respect and admire one another. And that's where world peace begins. If our country can understand that, maybe one of these days we won't see fighting all over countries throughout the Middle East. And so that was our goal. And today we're going to learn from the person who has the most passion of anybody I know about this. And so she's going to tell the story of how we started the Malta Conference. We celebrated our 10th anniversary because they're biennial. this last November. And guess what, Zafra? Well, it's great technology. I'll let Zafra try to figure out how to move it forward because it's not moving forward for me. I punched all the buttons. It doesn't do anything. Try it. Nothing works.
Oh, Ben.
Totally dead.
I'm here, Ben.
It's totally dead.
Hold on.
I tried that. Oh, it's working now.
Okay,
Works
go
now.
back to where.
We had to have the
it was.
magic fingers. That's why I can't keep teaching.
Okay,
because
which
I
one
know I
is
can't-
forward and which one is backward? This is forward?
Forward.
Okay. For the last 2 days, we heard a lot about Bassam. We heard what a great teacher he is, what a great human being he is, and what great demonstrations he did and taught the world. I want to discuss a completely different part of Bassam. We come both from the same part of the world, and we grew up probably only 300 miles away from each other. When I met Bassam the first time in 1981 in the ICC International Conference on Chemical Education of IUPAC, the first thing people told me, he's from Lebanon. I said, wow, just across the border from me. So he's almost a relative already. But I saw part of Bassam that was not mentioned yet. Bassam was kind enough, and he probably does remember, it's more than 40 years ago, to introduce me to his parents that came to the last evening when Bassam was the MC of this evening. And I had a chance to talk to them. And what impressed me more about Bassam than his demonstration is respect and love for his parents and the admiration his parents showed to him. And I thought, this is a special human being. Demonstration is one thing, but to know to respect your parents and to invite them to a conference is something that only an unusual human being can do. We since then met in many parts of the world, from Montpellier, France, to Brazil, to China, to a lot of countries. So I had the opportunity to see more of Bassam's family. I think it was Brazil that you brought your sister. Wow, I'm proud of my memory, Bassam. And this is when I had a chance to spend more time with a member of the family and hear from his sister what a great brother she has. Something again that was unusual to hear. So I realized that for Bassam, his family comes first. And then all the great things that we heard for the last 2 days. And then I was lucky enough to meet Elizabeth, Bassam's daughter, in China. And I saw what an outstanding father Bassam was, how proud he was of Elizabeth. And I knew she will go far only because of the encouragement and the love she received from Bassam. So this is the Bassam I had seen. We heard a lot how he encouraged a lot of people to do demonstration, and a lot of people learned from him to do demonstration. I must say that his effect on me was completely the opposite. When I saw his demonstration, I said, wow, I'm not even going to try. There is no way I can do demonstration like that. There is no way I can even learn to do 1% of what he's doing. So I had to develop another way to let my students that were mainly majoring in the arts and communication to do different visualization of chemistry concept. And my students visualize the concept through art, music, dance, drama, rap, animation, but demonstration was never my part of my career. So Bassam, thank you for teaching me early enough to stay away from demonstration and do something else I can do good. So, and what I want to talk now is about the Malta Conference. When after September 11, the board of ACS approved to have a project where we'll end, it was unheard of in 2002 when we came to the board to do what we wanted, and it's unheard of now. This is the only place that can do it, is to bring together scientists from all over the Middle East, from Iran, from Iraq, from Syria, from Lebanon, Israel, Palestine, all the Middle East countries for 5 days under the same roof, where everybody will eat together, everybody in the same hotel, everybody will socialize together and develop friendships that can overcome the chasm of distrust and intolerance. And the most important thing, that they can develop collaboration that will help solving problems of the region and the world, really, that cannot be solved by one country. And this is water, energy, climate change. And who was the closest to join? My neighbor that comes from the same part of the world. So this is when the first Malta Conference was born. You see the cover of the first Malta Conference program. After that, the programs grew much bigger. And you can see here the list of the organizing committee. I don't know if Bassam remembers, his name was on the first program of the Malta Conference. And we met for the first time in 2003 on the island of Malta. And the idea of the island of Malta was the thought that island might be safer than the mainland, because this was the height of the Intifada. For people that don't know what was the Intifada, it was the uprising of the Palestinian, and there were suicide bombing and killing on both sides. That was a terrible period. And despite all that, we managed to bring everybody under one roof with several Nobel laureates. As a matter of fact, Malta One had 6 Nobel laureates that spent the whole time with us and interacted with the people. So this was Malta One. This is the map of the Middle East. You don't see any borders here. The environment doesn't see the border, nature does not. But in this part of the world, the lines on the map were put there by the British and the French to a lesser extent, but nature never recognized these borders. Therefore, the aqueducts for water don't know where the line on the map here, and they go through several countries, and therefore we have to work together to solve this problem in this part of the world. This is Malta 10. That was the 10th anniversary and was a big, big celebration. It was the largest one. We had 100 people. Usually we try to keep the number less than 100. We had 40% women, something unheard of in the Middle East. We had 40% of young people that came to this conference, and it was really, and sure, always several Nobel laureates, and it was an unbelievable experience. You can see here the group picture On the first row next to me is the president of the Republic of Malta, because we always try to get dignitaries to help to our science diplomacy. From the other side is Peter Agre, that received his Nobel Prize in chemistry. And for him, it was the first time. Also, there was Nobel laureates that attended many, many times. Roald Hoffmann attended almost all of them, but the last two. The Malta Conference is designed to give people a platform to see what unites them, really what separates them, to really see that they can solve together the problems of the region. And the most important part is to see that they are all really equal, because there is a tendency to demonize the unknown other. And in the first conference, when the Iraqis came, after the second day, they came to me with tears in their eyes, and they said, we learned and we heard for so many years about these horrible Israelis, that they don't even look like us. And the first time we found that they are exactly like us. They are wonderful people, great scientists, and we are ready to collaborate. And sure enough, the Malta Conference has to catalyze the collaboration across borders. That is not an easy task. Here you see two Nobel laureates, Roald Hoffmann and Martin Karplus. And this conference was in Morocco, and you can see the rules for the Malta Conference. In the beginning, when the rule no accompanying members came, there was a hustle in ACS. What do you mean? We cannot bring our spouses? And the answer was no, you cannot bring. And Eli Pierce, bless his memory, got so angry and said, but I bring Judy everywhere. And I said, this is not a place you can bring Judy, sorry. And the Middle Eastern participant told me that it was the best rule that we could put, because as you know, all of you, that when you dilute the solution, the interaction is much slower. And we don't have time to dilute the interaction in this conference. So nobody can have an accompanying member. Here you have the list of all the Malta conferences, their dates, and the places that they had been. Most of them were in Malta, but we had few of them that moved to Turkey, Jordan. 2011 was the International Year of Chemistry, and UNESCO asked that the Malta will be the last event for the International Year of Chemistry in their headquarters in Paris. So therefore, the Malta 5 was held in Paris. And then there was Morocco, but most of them were on the island of Malta. Till today, as I said, the Malta conferences are the only platform that brings under the same roof for 5 days scientists from all the 15 Middle East countries. And we have Morocco and Pakistan, that they are not in the Middle East, but they requested to participate, especially Pakistan, that they said they would like to copy this model for a Malta conference between Pakistan and India. And now we were contacted if we will do a Malta conference model between the scientists from Ukraine and Russia. So meanwhile, we are working with the Ukraine side. Those are the Nobel laureates that participated in the Malta conferences. 17 of them, I'm sure you know all of them. And if you think about that there were 10 conferences, you can see that many of them participated many times. And in every conference, we have several Nobel laureates. And you can see the statement from Ada Yonat that for a long time was the only woman with the Nobel Prize in chemistry. Now we call it science diplomacy as a bridge to peace in the Middle East. And in order to do diplomacy, we need dignitaries to help us. So the three people on top, each of them was president of the Republic of Malta when we had the Malta conference. And below you see Prince Hassan bin Talal from Jordan, King Hussein's brother, that is very involved with us and participated in several Malta conferences. And the lady is Irina Bokova, that was for 10 years Director General of UNESCO, and she's the one that invited the Malta conference to be in UNESCO, and she opened the conference. Here you can see the different workshops. They are all interactive, so the people can interact with each other, and the different subjects are there. Every workshop has an entrepreneurship component to that. So we have several entrepreneurs that attend the Malta conferences and work with each of these workshops. Now the Sustainable Development Goal. The Malta conferences are dealing with the list, 6 of them that you see listed there. We started before they became the UN Sustainable Goal, but now they are part of it. So we are proud that we have 6 of them. As you can see, the 6 are listed there. And in every Malta conference, we deal with them. The number 6, the goal 16 is peace and justice. And I must say that I attended a lot of international conferences where I saw a lot of the goals that people work on, but I still did not see any place that they work on peace and justice. And sure, we work on peace and justice. You can see here an education workshop. This is Roald Hoffmann with a group from Egypt, Lebanon, Iraq, Jordan, Qatar, and as you see, they work all of them together, and this is an education workshop. Here you see the women, because gender equality is now a new workshop that we added in Malta 9 for women to empower each other. The water risk I mentioned before is one of the biggest workshops that we have. I don't know how many of you know that Gaza, for example, doesn't have any clean drinking water. And as a result of that, they have a lot of diseases, and a lot of effort is going in order to help to find a way to clean the water in Gaza, with collaboration, as a matter of fact, between Gaza and Israel. Solar energy is one of important parts, and this is part of what came out as Malta, where USAID gave the group that worked on that to develop this solar technology in the desert. And this is climate change. The pictures are from my own students, that one of them is an art student and did a painting of what it's doing to the cities and the human, and the other one produced a video on how all the glaciers are melting. This is peace and justice. And for the Malta conferences, I accepted in the UN summit, Novo Summit, where they gave awards to people that already had some achievements in one of the goals. And when they arrived to goal 16, they called my name. It was a big surprise for me. So my acceptance speech is still on the UN web that you can see. And the other picture is a tweet that they sent immediately as I was accepting my award for Malta. This is because we had few foundations that supported young people, ACS, the Bader Foundation. So we took a picture of the young people to show them that they really were in Malta. This is the head table for Malta 10. So we have from right to left, the president of the Council of Sesame. Sesame is the big synchrotron project in Jordan. Next to him is our own president from last year, Angela Wilson. Next to her is one of the main advisors, Omar Rifai, to Prince Hassan from Jordan. Next to him is the French ambassador to Malta, and she hosted us for an evening of reception and dinner. And next to her is me, and next to me is the president of the Republic of Malta. Next to him is a member of the French Parliament that adores the Malta conferences and loves to participate. And next to her is the president-elect of IUPAC that will take over next week in The Hague. And each of them greeted the participant in the name of their organization. We had, during the pandemic, a Zoom meeting where the first collaboration between the UAE and Israel was announced. It was covered by 568 newspapers around the world. In the US, it was the Wall Street Journal and the New York Times. And where you see our logo is the New York Times that published it with our logo. Challenges. The biggest challenge in this fractured world is to get a visa for everybody. And there is no country in the world that is ready to give us a visa for all the participants. One country, Morocco, for example, it was no Iraq or Syria. At the end, everybody got a visa, but it took a lot of sleepless nights and a lot of connection. Others is usually Iran and Syria. Gaza is a problem. So the visa issue became the most complicated, and we don't want to leave anybody behind because of a visa issue. And meanwhile, till Malta 10, we succeeded, but just before Malta 10, Malta had an election and a new Minister of Foreign Affairs came, and till the last minute, also the president interfered. He refused to give us a visa for the people from Syria. So we will move somewhere else for the next Malta conference. The fundraising is another obstacle because we pay for all the participants. We don't want them to have to go and ask anywhere for money and explain where they are going, who will be there. So we are paying for all the participants. In addition, we believe in equality. Everybody in the conference is equal. So we pay for everybody all the expenses, and we have to raise all this money. And sure, to do the collaboration across border is another obstacle that we have to solve all the time. 4 speeches were done on the floor of the Congress, 2 in the Senate, 2 in the House of Representatives about Malta, and now it's in the permanent congressional record. we received honors, as I said, the Prize for Peace of Justice from the UN Novo Summit. I was invited to deliver a lecture on Malta in the Norwegian Nobel Peace Institute. The American Physical Society, the Andrei Sakharov Award for Human Rights, and the Malta conferences, and from the AAS Award, the American Association for the Advancement of Science, the Science Diplomacy Award. So at least there is some recognition to our hard work. And this is Chicago. And the thank yous there is every country that listened to a lecture about Malta. So they have thank you in their own language. So, and thank you very much to all of you for listening. And there is some light at the end of a very, very dark tunnel. Thank you very much.
Thank you, Zafra. Thank you so much. Especially touching to me is your mention of my parents, and my sister and my daughter. That speaks to the all importance of human connectivity despite political boundaries.
This what endeared me on you.
Thank you, Zafra. And I like the map that you showed with the borders. Yes. And you and Ann and Mort, I very much enjoyed working with you and helping in my small way to get Malta launched and sustained. So, Ann, you also get one of those bags. I know, but you get two bags. I'll send one for Mort. For Mort, you're getting one too.
Oh, you should send me. He will be very
I think it's one of the most moving slides that you showed was the young people. And I was going to save this till later, but I'm going to say it now. The Senior Chemist Committee and the Younger Chemist Committee should be the most visible and effective committees in ACS. That's not going to happen by itself. We need middle-aged people to be in between those. And so I request that the executive committee of the Senior Chemist Committee and the Younger Chemist Committee really discuss the issues that make us care for each other and care for the science that we so much love. But it's going to take leadership. Both the younger people are enthusiastic. They want to do good things. They also need uncles and aunts. Yes, and so this is my plea as part of acknowledging the talk by Ann, Zafra, and Mort. Thank you very much.
Before we begin our next presentation, just let's comment about senior and YCC chemists. We've often noted that to be a senior chemist, you have to be 50 years or older. And to be a younger chemist, it works up till 40. So we have a gap of 10 years there that we need to work on. Okay, our next presentation is Donna Nelson, and the title is on the screen. So I'll let you go from there.
Significant current challenges in chemistry. So I think the best way to describe this is that it is Shakhashiri style. So he's always involved in significant challenges, and especially to chemical education. So I'm going to talk about 3 different topics, each of which does involve students. And these are relatively new I think. So let's look at the next. So it's, first of all, it's the fentanyl challenge for, we've got so many deaths of students. I don't know how else to put it. And then in chemical education, this is about artificial intelligence applied to chemical education. And then recently, I don't know if you keep up with the bad press that's happening, but I'm going to discuss it a little bit. And so there's 3 different topics and I've got 23 minutes. So I'm going to have to hurry a little bit. Yes, I will. So first of all, there's the fentanyl up there in the upper right-hand corner. That's the structure. So this is our growing opioid crisis. And so this is over the screen. I'll read it from up there. We're seeing an increasing number of news reports. I know that almost 210,000 people have died in the years 2015 through 2021. In 6 states, illicit fentanyl fatalities recently increased by a factor of 5 in only 2 years. Fentanyl is the leading cause of death for U.S. adults aged 18 through 45. Among children, the death rate's rising faster than any other age group, and they tripled in just 2 years. And data from the government agencies such as CDC and the Border Patrol presented in tables and graphs are interesting statistics such as recent deaths due to fentanyl versus other drugs, recent U.S. death rates by year, recent death rates by year disaggregated by race and gender, and I'll show you that and more. And this is I was in UT Austin recently to visit a friend who's also working on fentanyl, and I walked over to the area where they have just finished some student apartments. And I'm not talking about this particular student, but there was another instance in which I looked up the sidewalk and I thought, this was early on a Sunday morning, and I was having to race to get to the airport, but I wanted to walk through the area, and I looked up and I thought, oh my gosh, one of these crazy students left their coat up there. They must have been out partying and just left their coat out all night. And as I walked on up there, I recognized it wasn't a coat, it was a student out on the ground. And so this is, you see this at UT Austin. It has not come to OU yet, thank goodness. But this is sad, things like this. So here's the fentanyl deaths per year. You may have heard of Kamala Harris's Director of National Drug Control Policy at the White House, Dr. Rahul Gupta, said, we're flatlining the numbers. I think that's a really unfortunate choice of words to use for this. They're his words, not mine. And I'm a little bit familiar with the numbers, so I thought, wow, I didn't think that was the case. So we looked at it a little bit more closely, and you can see here's the, let's go back. Here's you can see up there, this is the most 2 current years, and you can see it's not flatlined. It's not reached a plateau yet. It is slowing. The death rate is slowing. So what this slide depicts is the number of deaths each year by the years. And you can see it has skyrocketed since 2014. This is the death rate due to fentanyl. So it's really sad. It is really sad. This is the deaths by race, by gender, and by year. And you can see, here's the legend, 2021 down through 2015. And you can see for Blacks, you can see how it's increased. Initially in 2015, the death rate for Blacks was lower than for whites, and now it has increased greatly, a lot faster than for whites. Native Americans is increasing very rapidly also. I think that when we get the 2022 numbers, we're going to see that for Native Americans, it's surpassed the death rate for whites also. And then this is, I think, perhaps the scariest. This is the seizure weight by month. And you can see just So far this year, their year for the Border Patrol goes October through September. And so far, you can see this is 22,000 pounds seized. And you know that the amount that it takes to kill a person is 2 milligrams. And so that amount, the 22,000 pounds, is enough to kill every person in the United States 5 times over. And so that is how much was seized. And we know that a lot more than that is making it into our country. And the rumor, and this is purely a rumor, is that it's being stockpiled. And what I wonder is, what for? Why are they pumping so much of this into our country? It's just sort of scary. So a lot of times people aren't aware that the numbers are this high. So that's sort of alarming. So I thought I would show you. So there's the number, 22,000 pounds of fentanyl. And here, this is the death rate by age group. And so for the ages 18 through 45, this, like I said earlier, it's fentanyl causes more deaths than any other cause, and that includes suicide, other drugs, etc. So that's the challenge. We're working on this, and the fentanyl problem. Then we're looking at the chemical education, and you hear a lot about cyber learning nowadays. And in the AI in chemistry, there's the conversation generation, chat GPT. There's also machine learning, and then there's expert systems. And we've worked in expert systems. And so years ago, I applied expert systems to troubleshooting a GC. And now I'm applying expert systems to organic chemistry teaching. And so this is sort of exciting. I'm very happy to be able to do that. So the reason that we applied it to GC was the GC is really easy to mess up. I was having undergraduates come in and do research with me, and they would screw up the GC and they couldn't fix it. And I would try to teach them how to troubleshoot it, and they just couldn't learn it. It was just too complicated. Troubleshooting a GC is difficult. And so what I did is I made a decision tree. I wrote it out by hand. And then a friend of mine put it into a computer program, and we loaded that onto a computer and put the computer right next to the GC. And it was just a series of yes, no questions. So when the students screwed up the GC, which was every day, at least once, they would just step over and go through that computer program. And then they knew, did they need to change the septum? Did they need to tighten the valve around the column, et cetera, et cetera. And they were able to do that. And so they enjoyed that. They liked that. They were able to help themselves. And so they were able, that was successful. And so then it hit me, well, why don't I apply this to organic chemistry education? Because it's the same situation. The students, the class size is so huge. I mean, I've had a class as large as 380 students in organic chemistry with no TA. And that is a challenge. And it's very difficult to teach that way. And so you have more students with needing more personalized attention than you can give. At least this was my experience. And so what I did is I literally filmed every single lecture in Org 1 and also in Org 2 and put that all up so that the students could, watch them whenever they wanted to. If they wanted to go in and watch them at 3 a.m., they could. If they wanted to watch it 5 times, they could. If they wanted to watch one 10-minute segment or one 10-second segment right in the middle of the film, they could. And so they like that. I teach the class as a flipped class. So then during the class period, I would just give them questions. We just solved questions, solved work problems in class. And so I think that the students need to be able to see problems worked in order to learn organic chemistry. And so this worked out great. The students liked it. So they would watch the assigned lecture before class, and I also gave them the textbook. They could read the textbook and watch the lecture before class, and then we just worked problems during class. So they liked this. The exam questions then come from the worked problems. And so they like that. That's fair. If they've already seen the question worked out, then it's fair to put it on the exam. And so the students liked it. They liked that format. And so how to apply expert systems to the course. So what I am doing, and this is what I'm doing now, I'm in the process of this because it finally just dawned on me, hey, I could apply this to my organic chemistry teaching. So the student will take a comprehensive organic chemistry exam, the style of the ACS standardized exam. And then the answers are keyed to the textbook sections and the lecture videos. And so whatever it is that the students miss, whichever questions they miss, that will dictate what sections of the textbook or which videos they need to go back and review. That will tell them what they have not learned, what they are lacking. And then so the computer program will analyze that, and then the computer program will tell them what they need to go back and study again. And so that's what we're doing with the organic chemistry, AI and organic chemistry. Now, in the spirit of time conservation, I'm going to go on to the bad press in academia. I don't know how many of you pay attention to any of this, but there's a lot of negative press in the news right now. I mean, for example, you may or may not be keeping up with what's going on at West Virginia University, in which, and this is in the news, I'm not saying anything that everybody does not have access to. So what's happened is they announced, because of budget problems, they're going to have to reduce their tenured faculty by 7%. And so, or, you know, some other solution. And so the provost and many of the administrators have been deciding what to do about that. And so they just decided that they're going to terminate that many people. And it just came out in the news, I think it was just yesterday, that they hadn't had any conversations with the faculty. They hadn't involved the faculty in coming to this solution. You know, I can remember when OU faced this exact same problem during one of the oil busts. And the way OU handled it is they gave it to the faculty senate, and the faculty senate decided that all of the faculty would take a pay cut. Instead of terminating some of the people, we all just sort of spread the misery out, you know, and that's a much more fair solution, I think. So here their decision is to terminate 7% of the faculty. So that's what I mean. There's a lot of really negative publicity surrounding West Virginia University right now. And inappropriate behavior and resignations are in the news about many different universities. I don't know if you have kept up with this. Most involve chairs, deans, some presidents. It's a difficult, stressful time with many controversial topics. Many news stories make administrators, in some cases, they just seem clueless and unable to predict or handle publicity. For example, Maitland Jones. Most of you know Maitland Jones, right? So this is a really unfortunate thing that happened at New York University, and it's all over the news. And Maitland is a fabulous person, a highly respected organic chemist, many publications, terrific researcher. He had and still has a very famous organic chemistry textbook for Org 1 and Org 2. Tenured professor at Princeton. He retired from Princeton and went to New York University. And so he did not have tenure at New York. Furthermore, he wasn't even an adjunct. His status there was listed as other. And so he was teaching the large classes. He was selected as one of New York University's coolest professors while he was there teaching at New York University. But here's some more basics. So numbers quoted in the news are that 30 students out of 475 in a classroom filed a petition asking for more help in his class. And then 82, this is another class, out of 350 students in his course signed a petition. And the complaint was that the grades he gave would not get them into medical school. That's the news report, okay? And so, and there's Maitland up there. Once again, the administrators did not discuss it with him. He was blindsided by what happened. And you know, administrator workshops, I've attended these and I'm certain that you have also. And we are taught that the first thing that you're supposed to do whenever students have a complaint is you send them back to the professor and give the professor a chance to resolve the issue. They're supposed to have an opportunity to solve the problem. And that didn't happen. So what happened, he was terminated. He was terminated. He was blindsided by it. He was other faculty, so he was not tenured or adjunct, so he had no rights to appeal. It was just, you ought to go in and read about it. It's even worse than what I'm saying. Later, after he was terminated, then the students said they didn't want him fired. They only wanted higher grades. I don't think that the students understand what they're doing sometimes. I don't think they understand the consequences. So I reviewed this actually because I was so horrified by it. I reviewed it in an ACS book I was writing at the time about teaching during COVID. It's the introduction is titled Student Stress and the Role of Administrators to Manage It. And that's the name of the book, Chemical Educational Research During COVID, Lessons Learned During the Pandemic. And there's the cover of the book. I have a little bit of a funny story to tell about the cover. So, you know, this was supposed to be good things coming out of COVID. Since we had to learn different teaching styles during COVID, it forced us to improve our teaching and to develop new ways of teaching. And so I said, when they were saying to me, we need you to select an image for the cover. And I said, you know what? There was an idea that COVID came from bats. And in Native American culture, new ideas and new ways of doing things and growth are signified by butterflies. So we need to have a bat morphing into a butterfly on the cover. And all they said is, Donna, we are not putting a bat on the cover of an ACS series book. And so I said, okay. And they said, but we will put a butterfly on the cover. And I said, okay. And so, and they found this, a butterfly coming out of the tunnel, heading toward the light to signify us coming out of COVID, heading towards the light, I think. And so that's the cover. I thought that was a funny story, but it's good. It looks good. So that's coming out next month, about a month from now. So when an incident like the above happens, the instructor can be blindsided, and I am just almost through here. So it would be helpful to have information, advice, warnings in advance, I think. So here are a few things that a person might do when they find them. This is a list of possible advice. Consult an education attorney. I didn't even know that they have a certain name. That's the type of attorney that is supposed to help faculty, So if you're needing an attorney, you consult an education attorney, not a patent attorney, an education attorney. And so that's what they call themselves. Attend an administrator workshop. I have done that many times. I strongly recommend doing that way before you ever need it. And then you know what the administrators around you are doing wrong. You find out by studying all this stuff that the deans often don't even verify the information. They'll just get told information and they just believe it and then they act on it without actually verifying it. They're not chemists like us. They can be people who with degrees in history or social science or whatever, and they don't realize that they need to verify their information before they act on it. And some deans don't even read the faculty response. When the faculty member responds, they just still keep going. Some deans don't consider confidentiality, and that's how the stuff gets out to the press. Talk to a university ombudsman, trusted friend or faculty senate appeals board, and also when anybody gets into any problems with this, move the important papers home. Don't leave them in your office. Don't leave them on your computer because you might need them and you can get locked out of your email and you can get locked out of your office and then you can't even get back in to get the papers that you need to defend yourself. And that I know of people that has happened to. That's true. And so all of these things are true where I've seen it happen to people or I've read about it in the news. So fentanyl needs action, chemical education, expert systems has no downside that I can see anyway. And the administrators behaving badly, that needs action. And so those are the three areas that, and they all impact students. They all impact chemical education, actually. And so that's in Bassam's area. And so I would say that these are sort of Shakhashiri style or Bassam-esque, maybe. So thank you. And if you have any questions, I have about 30 seconds. 35 seconds. Yes.
Controversy, but I was looking at a graph several months ago and it showed inflation over the last 50 years versus the cost of getting college education. And the cost of college education is about 5 times the rate of inflation. Then I talked to a few people and they tell me they think the problem in universities is it's become administration heavy.
Administration what?
Administration heavy.
Oh, yes, I can believe that. I do. I believe we've had a faster increase in administrators than we have in faculty and sadly in students. Yeah.
I was in academia for 52 years. It probably took me 35 years before I realized that universities are businesses. And there's a huge difference between teachers befriending students and administrators pandering to students. Okay. And I think that's a big difference, right? Right there.
Between
because it's a business.
And what we were hearing was faculty befriending students versus administrators. What? Pandering.
Way.
Okay. Yes.
No, I think I hope I said it all. Okay.
Okay.
And I encourage people to read the Chronicle of Higher Education. You can just subscribe and get all of the news and articles, and you're going to get a much more factual, straight story about what's going on there. There's a lot of news out there that's just not news.
Yeah. I pay a lot of attention to Inside Higher Ed. I don't know if you guys are keyed into that, but the two people that run that came out of the Chronicle. They used to be editors there, so.
And I want to make one more comment on
Yes.
fentanyl. I have a son-in-law who is type 1 diabetes, double amputee, end-stage kidney failure. And he's in severe pain frequently. And it turns out that fentanyl is really a very good pain relieving drug.
Yeah.
Unfortunately, all the states have, really strangled the medical profession in this, and it really becomes tough for the people who really need it on a regular basis. And obviously I'm not defending having it all out there. I noticed in your graph that June of 2020 is where all the seizures jumped up a whole bunch. And I was wondering, that's where it started. And I was wondering if that's just a coincidence, or the DEA and the Border Patrol, it's all of a sudden became aware of this problem. But that really struck me.
I don't know, but Jim Rao might know. We have the founder of Families Against Fentanyl in the audience, and he is a true expert, so he might be able to answer this. And by the way, we do have a symposium on fentanyl coming up starting tomorrow, actually starting at the poster session tonight. And I have some of the programs with me if anybody wants a copy. Okay, let me get them while he's answering your question.
Fentanyl is flooding the country at an amazing rate. The DEA says no matter what they're catching, they're not catching more than 10%. And those amounts have been doubling and doubling and doubling. It appears that fentanyl is being stockpiled in the United States. I have no other explanation for it. There was recently an animation that was put on Reuters showing a little table full of fentanyl with an agent standing behind it that showed what the fentanyl input was 3 years ago. And then it zooms out and there's a giant mountain of fentanyl behind them. And this is coming in at such a rate that there's no explanation for it. The only thing I can come up with is that it's being stockpiled for some reason in the United States. It's so cheap and easy to make. And there's so many different analogs, there's almost an infinite amount of analogs that could be made from it. So it's being done on purpose. And I think that this is a form of asymmetric warfare. This in no way is a pharmacological drug. It's gone through no pharmacological rigors. There's tons and tons of different analogs, and they put other materials in with it. And so far, it's infiltrated the illicit drug supply because it can attack the addicted or the adventurous or whatever. And I think it's soon going to start moving into the general public by introduction to air, food, and water, unfortunately.
And just let me say one more thing. Congratulations so much. You have had such a program it's such an honor to have this. And it's such an honor to me to have been invited to participate. And thank you, Ann, and thank you, Bassam. I really appreciate it.
Thank you, Donna. This is for you.
Oh, thank you.
I hope you'll enjoy what's in there. And I remember with great fondness and appreciation, you're hosting me in Oklahoma and all the other places where we have visited, trying to get ACS to be a strong, professional, scientific, educational, and learned society. So thank you very much, Donna.
Thank you again. And congratulations again. This is so fabulous.
And I do want to give one of those bags to Larry Berliner because he was the presiding officer this morning, and I was overwhelmed by what was being said, so I forgot to do that. So Larry, this is for you.
Good afternoon, everyone. I want to first express my gratitude to Ann Nalley for inviting me to participate in the symposium and to share my journey with you. My name is Elizabeth Reynolds, and I am here both as a proud member of the scientific community and as the fortunate child of my dad, Bassam Shakhashiri. Unfortunately, I couldn't be with you in person today, but I'm very grateful for this opportunity to take you on a voyage through my childhood and a little bit of my adulthood too, and to share the profound impact my dad has had on shaping not only my scientific curiosity, but also my values and approach to life. In fact, actually, as you're watching this today on Monday, August 14th, I am hopefully putting some of those values to the test and driving with my 5-year-old daughter through Yellowstone National Park, maybe learning about geology, volcanology, ecology, biology, climate science, conservation, and maybe even a little chemistry along the way. The title of my speech, as you can see, is Growing Up Shakhashiri, and this is a little bit of a journey of science, family, and inspiration. I grew up on the shores of Lake Mendota in Madison, Wisconsin, which was a privilege that laid the foundation for my journey into the wonders of science. With my father, as you all know, a brilliant science educator, as my guide, I was immersed from a young age in a world of wonder and curiosity. You may not know this, but Lake Mendota has the honorable distinction of being the most studied lake in the world, according to me, and I think also the University of Wisconsin. So it seems fitting that this is where my dad chose to settle. And if you've spent any time in Madison with my dad, you know he's deeply committed to exploring and enjoying the lake's ecosystem, especially via his pontoon boat, which you can see here. And here he is exploring the lake with his esteemed co-captain, August 2nd Morrow. That's my son. On the left side is Lake Mendota 2022, and then the right side is this past summer, a couple months ago. My father's love for the world around us was and still is infectious. As a kid together, we spent countless hours exploring the lake's ecosystem, as I've said, conducting simple experiments and uncovering the hidden chemistry behind everyday phenomena. This picturesque environment served as the backdrop for my early journey into the wonders of science. From a young age, I learned that science wasn't just something to read about in textbooks or explore in laboratories. It surrounded us in the lake, the sky, from the colors of the grass to the bees and our wildflowers. Science was happening all of the time, all around us. One of my more formative early science memories is watching the impressive physical changes to the lake unfold, particularly in the wintertime when the water would freeze and expand, pushing the shoreline outward, ruining the rocks around the shoreline, and then listening to the ice crack and buckle as it strained under its own pressure in the hot winter sun. You may have guessed that throughout my childhood, our house functioned as a giant, sometimes wonky makeshift lab with my dad as the fun scientist at its center. I recall watching in awe as he and occasionally his friends demonstrated chemical reactions with household items, sometimes even involving household appliances, like that time Dick Zare put a light bulb in our microwave. Thankfully, our kitchen was spared any chaos, that time anyway. These controlled scientific explosions, both at home and in the lab, sparked my curiosity. But at the same time, my dad encouraged me to ask questions and to explore the world around me, not just listen to what other people had to say. As I grew older, my dad became more than just a fun dad. He became a dedicated science education mentor. He instilled in me a love for learning that extended far beyond the classroom walls. Thanks to him, I understood that chemical reactions weren't just confined to laboratories. They were happening all around us. As I said, in the lake, in the sky, even in the freezer when I accidentally left a can of soda in there for too long, which is unfortunately something I still do all the time, much to my family's chagrin. For my dad, science and life is a journey, and the pursuit of knowledge is an ongoing adventure for him and for all of us. Growing up with him, no inquiry was too small or too unconventional for his attention. As a matter of principle, my dad firmly believes there are no stupid questions. But if you've ever had a conversation with my dad, which I'm guessing most of you have, you'll know that his approach to teaching is not always about giving direct answers. Rather, he encourages others, or me, as it were, to seek understanding and discover solutions on my own. Frustrating as this was when I wanted the answer to a simple or very specific question in my science homework, I realized many years later that this style was aimed at guiding me towards discovering solutions on my own. Through this approach, he taught me the value of self-directed learning and also the joy of just seeking answers. My connection with chemistry extended into my undergraduate career, where I took freshman chemistry from my dad. Maybe some of you know this anecdote already, but true to his rigorous academic style, he treated me like any other student in the class, which meant that I earned my less than stellar grade through my own rigorous effort, or lack thereof. Of course, getting what would turn out to be the worst grade of my college career was disheartening, but my dad responded with his characteristic encouragement and wisdom. He reminded me that failure is an important part of the learning process and that we can and should persevere through setbacks. This experience taught me resilience, humility, and honestly, the value of genuine achievement. I'd like to kind of talk about adventures of the non-science kind for a moment, which were pretty standard in the Shakhashiri household. I've traveled pretty extensively with my dad, starting at a very young age, and these travels together have also helped me view the world through a lens of wonder and appreciation. Here we are in Hawaii in 1993. I was still small enough to be carted around in a little luggage cart. And again, we also visited Hawaii in 2015. This is instead of being carted around in a luggage cart, that we went on some nice hikes together, which was lovely. As we immersed ourselves in different cultures, my dad encouraged me to embrace the unknown, to engage with locals, and foster meaningful connections that transcended language or cultural barriers. Through these interactions, I learned the importance of empathy, understanding, and also respecting the customs and traditions of others. You can see that my dad really enjoys replicating statues, which is something that was echoes through our travels, I would say. Our family's journeys not only provided unforgettable memories, but also served as a practical extension of many lessons he taught in his classroom. Whether it was exploring the Great Wall of China or the tombs of the ancient pharaohs of Egypt, my father would point out the marvels of human achievement that underpinned these incredible feats of ingenuity. Here we are in France in 2000, and then this slide actually, this was probably my favorite vacation that we ever took together. We visited his home country of Lebanon in 2016. The picture on the left, the larger picture, is us in front of the cedars of Lebanon. And the picture on the right is my dad and my cousins and I in front of his childhood home, where he was actually born in Menfi, which is on the Mediterranean Sea. And it's really just possibly the most special and beautiful place I've ever been in my whole life. Occasionally, we do some science-related events together, and this is us at the Kavli Prize Banquet in 2016 in Oslo, which was really a lot of fun for both of us. And I guess this is a good segue back into the science portion of this, but my father's passion for science education has always been evident in the way that he engages with others. He has a gift for explaining complex concepts in really simple terms, making science accessible and exciting for everyone. Maybe I should say fun. This, more than anything, has had the biggest impact on my own career, as it forms the foundation for my own chosen work, helping graduate students with their science communication skills. As most of you have likely experienced, his enthusiasm and energy for science education and communication are honestly boundless and very infectious. He's capable of igniting a spark of interest in even the most skeptical minds. I should know, I think I was at one point one of those skeptical minds. One of the most cherished traditions in not only my family, but also the families of countless others across Wisconsin and the country was my dad's annual Christmas lectures. Once upon a Christmas cheery in the lab of Shakhashiri. For 50 remarkable years, he captivated audiences with exciting demonstrations that made science come alive before their eyes. I was so lucky to participate in a lot of these Christmas lectures and other lecture demonstrations across the years, frequently, as you can see, as the resident bubble blower. Here I am, either blowing or preparing to blow some more bubbles. I've spent a lot of hours in my life participating and attending my dad's demonstrations, but I've also spent considerable time talking to audience members and hearing their stories about their relationship with my dad's demonstrations. And countless people over the years have shared with me how special this annual tradition was for their families. So special, in fact, that many who attended regularly when they were kids also brought their own children many years later. To me, this, maybe more than anything, serves as proof that my dad's shows were never just about the wonders of chemistry and how shocking and exciting huge explosions can be, though obviously they are shocking and exciting. More importantly, these shows were about a celebration of human curiosity and the magic of learning. Here's a couple more stills of some of my dad and I, of me participating in some of these demonstrations as I got older. And in 2019, on the 50th anniversary of my dad's Christmas lectures, I had the joy of bringing my own daughter, Violet, who was then 2, to see the annual Christmas lecture. Watching her experience the joyful shock of exploding balloons and liquid nitrogen flash freezing anything was really super special. She was not a huge fan of Santa, though, or Bucky, unfortunately. But this experience for me was a testament to one of my dad's most remarkable qualities, which is that, namely, his unwavering commitment to fostering curiosity through the joy of discovery. Both through his engaging and exciting demonstrations and his one-on-one interactions, he has this unique ability to fan the flames of wonder and awe in nearly everyone, including my own children. Detouring from science again for a minute, I want to touch briefly on how my dad has helped shape me as a citizen of the United States. My father's journey to the US as a teenager and his subsequent naturalization have had a profound impact on my understanding of what it means to be a good citizen. He exemplifies, more than anyone I've ever met, the true essence of being an engaged and responsible member of society. Throughout my life, I've witnessed his unwavering dedication to his adopted country, from serving as the president of the American Chemical Society to many other community commitments. He continues to work tirelessly, contribute positively to the community and make a meaningful difference in the lives of others, just as he has for well over half a century. My dad taught me that citizenship is not to be taken for granted. It's not merely a legal status, it's a profound commitment to championing the values and principles that make a nation great. From participating in civic activities to advocating for the importance of science education, my dad has shown me that being a good citizen is about actively caring for others, promoting inclusivity, and continuously striving to build a better society for everyone, not just those at the top. His proud journey to become and uphold what it means to be an engaged citizen has instilled in me a really deep sense of gratitude for the privileges of living in this diverse and super vibrant country. I try to carry his example with me as I try myself to be an informed, compassionate, and engaged voter and member of my own community in Chicago. And as I get older and raise my own children, I have a much deeper appreciation for how tirelessly he has worked and continues to work to ensure a brighter future for their generation, one that relies on science and facts to steer decision-making and guide policy, something I think we can all agree is more necessary than ever. Oh, to explain these slides for a second, here is a cake commemorating 52 years in the United States in 2009, which is pretty remarkable. And this is my jadoo, my dad's dad, Bassam Shakhashiri in the middle and on the right, who both, I think, had an impact on both of us. And it's really, I think, his legacy that both of us are trying to carry forward. Going back to my own children, who I think I've mentioned at least once or twice at this point, my dad is also a grandfather, or Jiddu, as my kids call him. Violet and August are 5 and 2. As you can see from these pictures, he's been hard at work for nearly the last 6 years, teaching them that science is fun. He wears that shirt everywhere, all of the time. And he's also taught Violet a few card games too. During summers, my children really love to visit their Jiddu, and I watch with pride and honestly a lot of fun as he shares with them the same sense of delight that he once instilled in me. I watch their eyes light up with excitement as he performs experiments with dry ice, which was the primary ingredient in my own favorite experiments as a kid. You may have guessed that from all the bubble blowing over dry ice in the previous slides. And this is Violet kind of getting to do her own experiments. As you can see, there's some vinegar, lots of dry ice, a mallet. Hopefully she wasn't using that at the time. I don't actually remember. Above all, one of the most enduring lessons I have learned from my dad is the significance of integrity in both science and life. Throughout my upbringing, he exemplified unwavering honesty, ethical conduct, and a commitment to doing what is right, even when it's not the easiest path to take, which I've learned it's not always. Whether in the classroom, the lab, or our home, he always emphasized the importance of being true to oneself and acting with sincerity. His words and actions are always congruent, and that consistency has served as a guiding light for me throughout my life and my career. From him, I learned that integrity is not just a virtue, it is the foundation upon which trust, respect, and genuine connections are built. I strive to embody these own values in my own life and pass them down to my kids, knowing that they are among my dad's greatest legacies. These are just a couple of pictures of my dad with Violet and Augie in maybe 2022. And then I had to include this freshman chemistry is no sweat. My favorite photo on the left here. Here is this past summer, my dad with August. As you can see, he also is willing to engage with anyone on their level, which includes digging in the dirt with these little faux diggers with my son. My dad's influence, as I know you all know, reaches so far beyond our own immediate family. I have met, as I kind of mentioned before, so many individuals who credit him for sparking their love of science or inspiring their careers in chemistry. In fact, I don't even think I've told my dad this, but a friend from high school very recently reached out and told me that my dad was the reason he went to med school and decided to pursue a career in medical research. So I understand as well as anyone how deeply his dedication to public outreach has touched the lives of people all over the world, fostering a generation of scientifically literate and very curious minds. And as I stand here, I wrote stand, but I guess I'm really sitting here today, I credit him for passing down the torch of curiosity and awe for the natural world to my own children and the many parents he has inspired along the way. This kind of brings us to the end here, but thank you everyone for sharing this journey with me. I hope I've been able to demonstrate today that my dad is not just a great educator, a great chemist, he is also an amazing human being who continues to enrich the lives of those around him. My hope is that we can all strive to carry forward his legacy of scientific passion and the desire to make the world a better place. And if anything, I think perhaps his most lasting message to all of us would be this, which is embrace your curiosity and let the pursuit of knowledge be a lifelong journey of discovery. Also, science is fun.
You want to make?
This is the first time I see this and I hear all this. I've heard snippets of it before, but seeing it put together like this, very moving. And I'll just say two more things. Elizabeth was a very good student. She was a National Merit Scholar. She was Phi Beta Kappa. The only B she got in college was in my course. She will not let me forget that. But I told her that's what you earned. And I had, not been involved in handling her grades anyway. The second thing is when August was born, I was called by Elizabeth and Bob, her husband, and they told me that they gave him his name, August Zekken. His middle name is Zekken, which is the same as my middle name, which is my dad's first name. I was speechless. Does anyone know me ever to be speechless? So that was very special to me. And I thank you, Ann, for including Elizabeth in this presentation. She wanted to be here, but she had made all these travel arrangements before the symposium was put together. So thank you for welcoming Elizabeth.
And thank you, Ann, for putting this symposium together and for inviting me to take part. This is going to be a rather personal reflection on my quests with Bassam, which range from quixotic to fulfilling. Bassam and I met in 1971 at the ACS meeting when we were had both been appointed to the program committee of the Division of Chemical Education. And we hit it off pretty well. We've been collaborators, colleagues, and most importantly, friends from over half a century now, which is in a sense kind of odd because we have fairly different personalities. To make it really simplistic, Bassam's personality is public. And you've seen many, many examples of that in this symposium as people have talked about his outreach and his public presentations and so forth. My personality is much more private. I'm not involved in many of those things. But what brought us together really was our common advocacy for the use of phenomena in classroom teaching. As we know, I don't know why we're not moving forward here. There we are. As we know, classroom teaching with phenomena is we do because that engages the students and gives them a basis for learning the concepts that we're interested in teaching them. We have different presentation styles, Bassam and I, but we share the same philosophy that there should be a learning goal to using a chemical demonstration or a chemical experiment in the classroom. The overriding question that we should always think about as we're going to do these is why are we using this demonstration? What is it that it's going to help the students learn? And this slide just illustrates the enormous amount of effort and output that Bassam and his coworkers, especially Rodney, whom you heard from earlier today, have put into helping all of us understand better about chemical demonstrations and their usefulness in the classroom. I contributed a couple of such demonstrations in those earlier years, the 1 through 4 volumes, but I'm really, really, really glad and pleased that I was able to co-author with Bassam and Rodney volume 5. David. That's way ahead of the story that I really want to tell. We're back to the early 70s when Bassam and I first met. That was the time when the biennial conferences in chemical education were just beginning. At that time, the infrastructure, which is now available for those who want to put on one of these conferences, was not available at all. But at the third conference, which was at Pennsylvania State University, Bassam and I got together and thought about it and said to the Division of Chemical Education, we will run the fourth conference, Bassam as general chair and I as the program chair. Here is a poster about the fourth biennial conference. You'll see that at the bottom, it says this is participant-paced programming. What that meant was that there were no concurrent oral sessions. Everything was plenary. There were lots of poster sessions, posters, and the posters were up for the entire conference, and anybody and the poster presenters were given times when they were supposed to be available, so everyone could participate in the posters. Another part of the participant-paced programming was the way we suggested that presentations would be done. For a 20-minute presentation, we gave the presenter 5 minutes to give the presentation and 15 minutes for questions. That led to some really kind of very interesting things, things happening during the conference. But it certainly was one of our more quixotic things to think about, because no one, as far as I can tell, has ever done the same thing again. There were a few plenary presentations at the conference, and one in particular stands out to me. This is Sherry Rowland getting the Nobel Prize in 1995. But interestingly, in 1976, at the our biennial conference, it was 2 years after Rowland and his postdoc, Mario Molina had published a paper that indicated that CFCs could be fertilized to the stratosphere, and the chlorine item that was produced could be a catalyst for the destruction of ozone. Two years later, in '76, there was some experimental evidence that such a thing was happening, but it wasn't really all that, it hadn't been really proven at that point. Sherry was vilified by the industry that produced CFCs. The ACS wasn't much help because they didn't really, take his side very much. But I thought that it would be useful to hear this kind of research that had enormous, could have enormous impact on society. for chemical educators to hear, because this might be exactly what they're going to have to be teaching, not too distant future. So in some sense, this was sort of a win, because even though it was early on in the CFC story, we got to tell that story, or Sherry told that story in our conference. So let's go on. We move on, jump to 1984. The first day of spring, at a dinner party that evening. You can tell from Marianne's dress that this is probably a wedding. And indeed it was. Between the appetizers and the entree, she and I were married. Before I continue the story with the narrative with Bassam, I'd like to take just an instant to say something else about another connection that we can see in this symposium in terms of the people that are here, or at least virtually. When Marianne was a first-year graduate student in biochemistry at Boston University, a call went out from the chemistry department at the main campus. She was at medical school, because they had a shortfall in TAs, and they needed graduate students who could be teaching assistants and had some background in the chemistry that was required. Well, she was a perfect example, because in the last 2 years of her undergraduate career, she'd been a teaching aide in the chemistry department at her college. So she became a TA in the chemistry department at BU with Morton Hoffman in his honors general chemistry course. She gives great praise to Morton's teaching at that point, and I think probably Morton appreciated what she did. But let's go back to the story with Bassam. Just before he'd come to Boston for the wedding, he'd been offered a position as assistant director for science and engineering education at the National Science Foundation. Now he had to make a decision. The afternoon before the wedding, Bassam and I sat in his hotel room for several hours discussing this. The reason for that was that a year before, the Institute for Science Education had been set up at the University of Wisconsin under Bassam's leadership. We had been thinking about that and trying to conceptualize that for several years, and now it was a reality. Well, what if Bassam left that? What was going to happen? So we were faced with several issues. I mean, who was going to take over? How could it be maintained at the University of Wisconsin? So we worked about that. We wrestled with that for several hours. Then we had to go to the wedding, but we hadn't actually resolved those issues. We had the issues more clarified, but we hadn't really reached, well, at least I hadn't reached any conclusion. What I learned later from Bassam was that the next day, on a plane ride to the West Coast, someplace over the Great Plains, he said to himself, I'm going to accept that, because we both knew he had to do that. And so, as we've seen more than once at this meeting, Bassam took the job, and here he is being sworn in as the assistant director with his parents in attendance. And the first thing, or one of the first things that he was advised, was that he should appoint or try to get some help with some trusted friends who could come and do some of the day-to-day operations of the directorate, because he was going to be too busy doing other things like keeping it afloat. And so, of course, I found myself on the other end of this argument or this discussion that we'd had about going to the National Science Foundation. So we discussed that. We didn't discuss it in a hotel room. We discussed it, as I recall, wandering around the University of Wisconsin campus in a nice sunny summer day, with me saying, "But wait, you know, if you've been keeping track of the timing here, I've only been married for a few months. I have some professional obligations, like I have teaching assignments this coming fall, and now it's the middle of summer." But talking with Marianne, we knew that I had to take the job. I had to go to Washington with Bassam, or to help Bassam. She and I made some arrangements, made some plans about spending weekends partly in DC, partly in Boston. Most of those plans got kind of kiboshed when we had our first daughter, but we carried on, and I was the director of the division that was assigned, or that did the projects that involved teachers and the professional development of teachers. I'd been doing that sort of thing, professional development of teachers, for about 20 years previously, almost since I began my career as a chemist. So it made perfect sense that I should be involved doing that. Here's an interesting artifact. I don't have too many artifacts. This is the only artifact I still have from my 2 years at the National Science Foundation. I did have a map at one point, a very large wall map that was mounted on a bulletin board, and into which I put colored push pins to indicate the places where our division had made grants to support those projects that were doing the kinds of things that we thought were very important in terms of making sure that teachers were engaged, teachers could do things that engage their students and so forth. You can think about this. You notice that this is the first iteration of this pin. I don't know whether you noticed, but in Zafra's presentation, there was a picture of Bassam wearing such a pin with a slightly different design, but still the same thing. Science is fun, and the NSF logo. you can think of this as being a sort of for me, a kind of a talisman of the things that happened at NSF. From a cynical point of view, you can think of this as being a kind of a way of looking at the non-fun that we had, trying to keep the directorate afloat when people were saying, there isn't any reason for having education at the National Science Foundation. From a more positive point of view, at least my point of view, is that this is a way of indicating my satisfaction of supporting excellent programs that, in fact, might provide students with the science, with science being fun, in the way that we think about, where we've thought about this in terms of the fun being the way which science is done, meeting phenomena, logic, so forth, that were just a part of essentially the kind of thing that Elizabeth was just talking about in terms of the fun that she had with her dad, in terms of having fun with science. I was pleased to be a part of keeping the directorate alive for 2 years. As you all know, Bassam kept it alive for a lot longer than that. It's still alive. He resuscitated it, even though we think we kind of had the idea that we were brought there to bury it. He actually made it, strengthened it enormously in his time. But after 2 years, I'd signed on for 2 years. I had a marriage to get back to. I had other professional things that I was interested in, and so I left the foundation, and returned to Boston. Maybe you might be interested. You might think, well, what happened in terms of that marriage? After our second daughter and a very large number of wonderful experiences, professional and family, and so on, here are Marianne and I sitting on the Greenland ice sheet in 2018. Why were we sitting on the Greenland ice sheet? Because about the beginning of the 2000s, I began to think about the climate and about the way in which humans were disrupting the climate, because the experimental evidence was becoming just overwhelming, that we were actually having an enormous effect on the world. That was so I began to do workshops, or even my workshops that for professional development, which I was still doing. I kind of focused on the use of demonstrations, experiments, and so forth in classrooms that would have an impact that would help people understand the science of climate. I was especially interested in the kind of experimentation or the kind of activities and so forth that were based on actual experimental evidence. And I really, one of the things that most interesting was the loss of ice around the world, because obviously, if the world was warming, ice should obviously be disappearing. That's why we're sitting on the glacier, or not the glacier, the ice sheet in this case. But there are glaciers that are disappearing all over the world, and probably one of the most iconic ones is Grinnell Glacier in Glacier National Park. One of the few that's left. The number of glaciers in Glacier National Park has decreased by about 80% over the last century. Here we have the photograph from 1940, when we had this glacier, which the tongue of the glacier extends very far down toward the left. And in 2008, from the same vantage point, the photograph shows that what was a glacier, at least the tongue, is now Grinnell Lake, as the glacier has melted. And the graph in the background, of course, is probably familiar in terms of the warming of the globe as time has gone along. Come back to Sherry Rowland for a moment. The paragraph at the top of this slide is reported. It's reported that Sherry said this someplace toward the end of the 1990s at a meeting that had to do with the changes in the climate and so forth, when he said basically, if you have some information, you scientists, that there's something going on that affects the environment and therefore the society, and therefore the people that on Earth, don't you have a responsibility to do something about it? Something such that the action, that something actually happens. And then, if not who, if not now, when? Let's get it done. Taking that to heart, the bottom paragraph, part of the paragraph, Razy, is from Bassam's statement as the incoming president of the ACS in 2012. It says ACS has a clear position on climate change. Yes, it did and does. It accepts the overwhelming experimental evidence that the climate is changing and that humans are responsible. Human activities. In 2011, he appointed a working group to develop a climate science toolkit to equip every ACS member with enough information that they could go forward and talk with others about the climate. Having a conversation. And he appointed me as the leader of that group. Well, we produced the toolkit. A couple of people have talked about that Cecilia Vollbrecht said, I mean, she was involved at the University of Wisconsin in terms, that's not here, in thinking about these kinds of things. Mary talked about it in her talk about the toolkit. The toolkit is still there. It didn't quite work the way we'd hoped. The idea was that the ACS, given this resource, could become a leader, and its members could be urged to take action as Roland had suggested, but the policy statement still does not urge this. There are places within the ACS where one can think about the climate, but there's nothing there. There's nothing in the policy statement that suggests that we have this, that the members have this responsibility. So that's a kind of a quixotic part of what happened. The toolkit is based on experiments. This is just a screenshot to indicate what kinds of things you can see in the toolkit, or if you aren't familiar with it. That graph is based on information which was measurements which were taken by satellite about 1,000 kilometers above the surface of the radiation, infrared radiation, which was being emitted at the from the atmosphere at that point. It's a striking graph, and it's being, it can be taken over and over again. This graph, this measurement is from 1970, so it's older than the friendship that Bassam and I share. Based on the based on the work which we had done with the workshop, with the toolkit and so forth, and the working group, I developed a series of workshops for professional development for high school teachers and college teachers that suggested ways in which the demonstrations and experiments that they normally used in classrooms could be also used not only to talk about the concepts that were they'd normally done, but also could involve the concepts that were part of climate science. So we did workshops. We did the workshops, and then came along the pandemic. Couldn't do any more workshops, and so instead of workshops, I wrote a workbook which took those activities and so forth that we put together for the workshops and codified them into print, which is available online as a climate science workbook, which makes it possible for people to access this anywhere, any place through the Science is Fun website which we have here. I'd like to do, as in closing, is say how much I've enjoyed my quests with Bassam, whether they were quixotic or fulfilling, doesn't matter. They were fun. As they've allowed us to meld our different personalities. We still have different personalities, in ways that target the same goals as scientists and citizen scientists. Thanks, Bassam.
Thank you, Jerry. Another part of the journey. So many different collaborators, friends, family members. Thank you, Jerry, very much.
All
Ready?
right.
I'm ready.
Okay. Just one comment. We've learned much and much has been shared about Bassam Shakhashiri, and now he's going to have the final word on this symposium.
Thank you very much. Thank you, Adriane. And what I'd really like to say to begin with is to ask that you focus your attention on this shield here. This is a representation of the University of Wisconsin shield. My tenured appointment at the University of Wisconsin-Madison made it all possible. Yes, N was equal to 1. I have to say, someone asked me in the hall just a few minutes ago, how do you feel? Do you feel numb? I said, no, I feel elated. I feel overjoyed. I feel good about having visited with friends, collaborators, and family. And I'd like to take a few moments to share with you some important convictions about chemistry, about teaching, about education. Teaching is a subset of education, about science, and the all-important charge we all have of connecting science with society. We want to be assured that when we connect science with society, we don't encounter any impedance problems. That takes careful planning, careful thinking. Let's see, just push this button here. Huh? Well, I'll just push the button on over here.
They have to push that.
We are the American Chemical Society. The American Chemical Society. We live in America. Some exist in America. We live in America. Our vitality, our research, our educational activities are crucial for the well-being of every American, for the well-being of everyone who inhabits the American soil. Sometimes people ask me, and this has happened quite a few times, who are you? Some of the speakers in this symposium attempted to address that. I think of myself as a human being first, an American second, a University of Wisconsin-Madison faculty member in the chemistry department third, The sequence is important here. As was mentioned before by several speakers, words are important to me, and they convey meaning and convictions. And there's fourth and fifth and so on. First, I'm a human being. Second, I'm an American. Third, I'm at the University of Wisconsin, faculty member in the chemistry department. I don't say that I'm a, whatever other people might say, I'm a synthetic organic chemist in this department at that university. Identity and affiliation are important. One important aspect of my own feelings and my own life is borrowed from the oath that the physicians take once they complete medical school. This is my version of it. The Hippocratic Oath says, first, do no harm. I say first and always do no harm. This, of course, is the subject of many conversations as to whether this is a valid statement or a statement that there are some times when you have to cause some harm. But this is my belief, this is my practice, this is my ethos. First and always do no harm. No, in everything that I have done, that has been my practice. And I'd like to now say a few things about Science is Fun. Science is Fun is, of course, viewed by many people as a slogan. It is a slogan, but it's much more than that. It's a philosophy. It's an ethos. It is what we stand for, I and my group, in the activities that we engage in. We live our Science is Fun philosophy by engaging with individuals and groups, both locally and around the world. Our purpose is to trigger cerebral and emotional connections to heighten the joy of learning. A major goal is to promote progress in addressing the grand challenges that face society. All of us must engage in respectful discourse on significant societal issues related to science, religion, politics, the economy, technology, and ethics. The Science is Fun philosophy and Science is Fun ethos says we together foster creativity. We advocate for working together with respect, trust, and confidence. And of course, we encourage skepticism and encourage harmony and also allow for dissonance. This is how progress is made. We do all this for the common good. I just share this with you as an attempt to explain what Science is Fun really means to me and to people who have been associated with me. Now, very quickly, we know that science in the Age of Enlightenment and the Industrial Revolution has had fantastic, fabulous effects on individuals and on society. You think of all the advances that we enjoy nowadays, they are the result of enlightenment and the result of what people did, especially scientists and technologists, since the Industrial Revolution. We are now in the beginning of the electronic revolution. The electronic revolution is in its infancy, and it's important for all of us to participate in this in a manner that reflects our responsibility, not only to satisfy our curiosity when we do research, but also to make sure that whatever discoveries are made are properly connected to the well-being of society. So new discoveries are made, they produce enlightenment, they cause societal progress, but they also cause societal problems. And it's our responsibility to address both the progress and the problems that are that accrue. And this is part of our ethos. This is a statement, and you'll forgive me for reading it to you because I know you can read it, but I would like you to hear the emphasis that I have in saying it. Science and society have what is essentially a social contract that enables great intellectual achievements, but comes with mutual expectations of benefiting the human condition and protecting our planet. I go on and say we must assure that the next generation of scientists, and I really like to amend that, we must assure that the present and next generation of scientists are both highly skilled technically and properly educated to carry on their scientific and educational work for the common good of society. Why do we make all these discoveries? Because we want to satisfy our curiosity. What happens after we satisfy our curiosity? We need to share not only with each other through the scientific literature, conferences, but we need to share the benefits with the rest of society. In a free and civil society, people must be virtuous as well as technically skilled. This is also an opening for another discussion, a big discussion. And I say the word virtuous selectively here and purposefully. I'm not talking about values. Gangs have values. Gang members look after each other. They protect each other. I'm speaking about being virtuous in our own personal and collective behavior. So this is the list of grand challenges to society and to scientists. And this is part of my presidential essay in 2012. And the question is how to help sustain Earth and its people in the face of population growth, finite resources, malnutrition, spreading disease, deadly violence, war, climate change. Some people have asked me, what does chemistry have to do with all of these things? What does chemistry have to do with war? What does it have to do with deadly violence? What does it have to do with spreading disease? We should address all these issues and see that the proper connections are made between our science and society. To me, the most important question is the last bullet here. The denial of basic human rights, especially the right to benefit from scientific and technological progress. The benefit must be universal. It isn't only for the people who make their own discoveries and publish their own papers. Very briefly, what is the purpose of education? The purpose of education is to enable individuals to fulfill their human potential, to enable them to fulfill their human potential. All individuals to fulfill their human potential. What's the purpose of research? Is to advance knowledge. What's the purpose of technology? To advance the human condition. I'd like to say a few words about my time at the National Science Foundation. You saw in several pictures when I was sworn in as the Assistant Director for Science and Engineering Education. The President's Science Advisor, George Keyworth, came to the foundation and swore me in. That's the only time in history that the president's science advisor has done this. And my parents were holding the Bible. NSF and ACS have great connections. Dick Zare, who spoke earlier today, was the chair of the National Science Board. Jerry Richmond, who spoke earlier today, she was on the National Science Board. Glenn Seaborg, president of the ACS, was part of my advisory committee, my Blue Ribbon Advisory Committee that I appointed in 1988. Then there is George Pimentel, who was ACS president, was deputy director of the National Science Foundation. There's many, many good connections between NSF and ACS, and we should all be aware of them. Another person is Mary Good, who was chair of the National Science Board and also very heavily involved with the American Chemical Society. She was a president of the ACS as well. And another person was Anna Harrison, who was president of the ACS and had some connections with the National Science Foundation as well. My time at the NSF was very challenging. As I mentioned to some people yesterday, I worked 14-hour days when I was at the NSF. I took the oath that I made when I took office very, very seriously. And I meant every word that I said in it. I was entrusted with science and engineering education at the National Science Foundation after the programs had essentially been zeroed out in the Reagan administration. And this is not the time to discuss the details of all the gyrations and maneuvers and the politics of what happened. But this is the time to mention that many, many chemists came to the NSF, including Jerry Bell, as you just heard, and Peter Yankwich, who was the senior vice president at the University of Illinois, and many others came to work at the NSF so that policies and practices for the improvement of science education at all educational levels would take place. I remember very clearly when I tried to start the programs for science education programs at the middle school level. And people said, middle school? There are no chemistry or physics courses at middle school. And then later on, we moved to the elementary school level. So it was a deliberate attempt to reach all students at all levels, not only those who are at the graduate level, where the National Science Foundation fellowships existed. The budgetary problems and the politics of it are not the topic to be discussed today. But I want to say that NSF remains, in my opinion, the leading and premier agency in the government that has a fighting chance of affecting the quality of science and the quality of science research and the quality of science education in America and actually around the world too. Now I'd like to say something about the American Chemical Society, a bit more than I said about NSF for now. This is the plaque that commemorates the establishment of ACS. You can read it in 1876, April 6th, and it is. And I was very proud when I spotted it on a visit to have my picture taken with it. So I have advocated and said repeatedly that the ACS is a scientific society, an educational society, a professional society, and a learned society. some people ask me, what do you mean by a learned society? And that to me was a prompt to share what the real mission that we all have to self-educate and educate others to the meaning of these entries that are shown on this slide here. So the ACS mission is advancing the broader chemistry enterprise and its practitioners for the benefit of Earth and all its people. When I was in the ACS board, when I was ACS president, I used to ask my fellow board members, if I call you up at 2 o'clock in the morning, can you tell me what the ACS mission is? Yes, that was the reaction. Yes. Yes. What is it that we're all about? Who are we? What do we stand for? We are a scientific, educational, professional, and learned society. And our programs and our offerings are in keeping with our goal of better connecting science with society. One of the activities that I started was to establish a commission on graduate education in the chemical sciences, and I asked them 2 questions. What are the purposes of graduate education in the chemical sciences? And then what steps should be taken to ensure that they, meaning the purposes, address important societal issues as well as the needs and aspirations of graduate students? I wanted to put the graduate students up there. And I remember very clearly meeting with the commission. I met with them every time they met, but did not participate in their deliberations. I said to them, please answer the questions that are being asked. Because I know as a classroom teacher, sometimes you get a correct answer, but not to the question that was asked. And so the commission report was issued. We all know about it. It has been followed through by NSF, by NIGMS, and other groups. But still, we have a long way to go in terms of dealing with the purposes of graduate education in the chemical sciences. We really have to focus sharply on what is it that we're trying to do in educating graduate students. There's training, which is a subset of education, but the conversation I wanted to focus on is graduate education in the chemical sciences. We also, you heard about the ACS toolkit, and again, I'd like to see ACS be engaged in doing much more than we are doing now, because we are a scientific, educational, professional, and learned society. And you heard from Jerry about one of the follow-ups to the task group, the working group, that is this workbook, which I invite you to go to the Sciences Fund website to get a hold of. Now, what I'd like to focus on now is the Chemical Professionals Code of Conduct. It's an important code of conduct that we have. We see statements about it related to harassment as we walk through the convention center here. I and others would like the code of conduct for all chemists to include this statement: chemical professionals should not participate in or otherwise enable government-mandated executions. Just for a moment, remember what our logo is: Chemistry for Life. And this statement is consistent with that. And at some point, we're going to start a grassroots effort to get this to be included in the code of conduct for chemical professionals. We started a process already, but it's not moving at all. And so this is why I say we're going to start a grassroots activity to get this done. So why? Because first and always, do no harm, as I mentioned before. So now I want to say a few things about the chemical demonstrations. Many times when I've given talks everywhere, people say, we came to see you to do the demonstrations. I said, yes, I will be doing demonstrations, but I'm going to be, my presentation is in two parts. First, I want to say a few things about science and science education, and then I'll get to the second part. And then when I get done, you tell me which part is better than the other part if they're not the same. So doing chemistry in the classroom and in public forums is something that we should do. And we always, as I practice myself, safety is paramount. All should be done very safely. A lot of chemistry is taking place in what you see here. And this has become a very popular experiment, and it's also been, let me show you where it is. It's made the cover of CNE News about 20 years ago, 2004 and so on. But I want to go back here for a second and say, what is the point of doing the demonstrations? Is it to show off that I can mix things up and blow things up? Is that the point? What is the point? And I think we have to be purposeful in everything that we do. So what is the point? Well, the purposes might include display phenomena, illustrate principles, convey attitude, spark interest, nurture curiosity, make connections, learn, think, so many other things. But the most important one to me is to convey an attitude about the subject matter that we are engaged in. So that's why I say attitude and motivation are crucial in using demonstrations, to convey an attitude, safety, proper practice, nature of interaction with the audience. I showed you this already. These are examples of flyers that we put together for the Once Upon a Christmas Cheer in the Lab of Shakhashiri. You can see they're colorful, they're attractive, and we did 50 of them. That's a few more than Michael Faraday did, who started all this. And so here's a shot of one from one Christmas lecture where Santa Claus is doing an experiment. I have a physics colleague at Wisconsin, Clint Spratt. He started a program called The Wonders of Physics, and he would tell me very frequently, he would say, but Sam, you're doing chemistry, you're not doing any physics. You know, look at this can that's collapsing. Like, okay, it's made of chemicals, okay? But why is it collapsing? And so this is why it says science is fun. It doesn't say chemistry is fun. It says science is fun, in keeping with the philosophy and the ethos I mentioned to you before. Here's Bucky Badger and Wisconsin, PBS Wisconsin recording this, doing this experiment. This is the 40th anniversary of that. So, and then we had the marching band, although you don't see them marching here, in the lecture hall as part of linking science, the arts, and the humanities. This is my favorite picture. Why? Because people ask me, Bassam, why do you do chemical experiments and public engagement? That's why. That's why. That's why. That's why. Look at every face in this picture. Look at the ages of the people who are there. This was done at a shopping mall in Madison. And the engagement is crucial in terms of what we do and what we should continue to do. I mentioned this, as was mentioned before, about communicating science. This is at the graduate level. We invite PhD students in science and engineering, not only in chemistry, to write a chapter in their thesis that describes their scholarly research to non-science audiences. in language that is understood by family members, by elected officials, local or federal officials. This is something that people who have graduate students at the PhD level should consider doing. Invite them to really do it, not only consider doing it. Oops.
That's the classic.
This is an object of art, but it's made of chemicals. And this person is also made of chemicals. And what goes on inside this person is also a chemical transformations. The beauty for me of looking at Roald Hoffmann, studying this ceramic, is at the heart of the connection between science, humanities, and the arts. I know you saw this in his presentation yesterday, but I couldn't help but include it here. Now I close by calling your attention to a couple of things that happened to me last year. I didn't know about them. The University of Wisconsin-Madison, specifically the Wisconsin Alumni Research Foundation, the Morgridge Institute for Research, and the Office of the Vice Chancellor for Research and Graduate Education established an award in my name called the Bassam Shakhashiri Public Science Engagement Award. And this is the description of it here, and it's given to two individuals, a faculty member and an academic staff member. It's a cash award, and it relates to science, technology, engineering, arts, and mathematics research. It's and I had no idea they were doing this, and I said, when they asked me if it's okay, I said, of course it's okay. And it's within a few days after this was announced, then a mural in the this so-called Discovery Building in Madison shows this, you see this representation. Who is this person here?
Looks like you.
That's me, yes. And this is a clickable, there are 17 other people involved there. These are the artists who did it. And they did it unbeknownst to me. But after I found out about it, I said, I want to have my picture taken with you. And that's what happened. So I come back to this. On September 17, 5 weeks from today, from yesterday, I will mark my 66th year in the United States. My parents, my two younger sisters, and I arrived in America. We went to Boston because my dad was on a sabbatical leave to the from the American University of Beirut. He was a visiting professor at Harvard. And my dad never went back to Lebanon. My mother went back to Lebanon once. My sisters have gone back. My daughter, you heard, she's gone back. So I close by saying, we are grateful for the great hospitality extended to us since we set foot on US soil. And we are thankful for the wonderful opportunities we continue to enjoy. May all immigrants and native-born citizens continue to prosper in the goodness of America. Thank you, America. And thank you all for being part of this symposium here and virtually. And a special thanks to the Senior Chemist Committee for organizing this, and Ann, who conceived the idea and pulled it all together. I'm very grateful for that. We've had speakers who ranged in age from 23, 24 to 87. And it's been a wonderful journey for me. And I thank everyone, not only the speakers, but those who participate in person and virtually, in being part of this celebration. Thank you very much.
So Bassam, I hope that you've enjoyed the last day and a half. I would like to remind everybody this has been recorded. And I hope it'll be on the web for you to view and to encourage others to view it. I'm overwhelmed. I thought I knew a lot about Bassam, but you never learn all there is to know about him. And so I think we all go away today feeling better about our world by having the opportunity, at least in my case, to know Bassam and to benefit from standing on the shoulders of giants. And Bassam is one of those. Bassam, thank you again for all you've done to promote chemistry and the appreciation for science and to make the whole world feel good about it like we do. Thank you again.